Data nerds, welcome to this full course tutorial on Intermediate SQL for data analytics. This is the course for those that understand the basics of SQL but want to take it to the next level. Perfect for those that took my first course on this. Now to master this tool, we'll break down more advanced SQL concepts in short 10-minute lessons. During this, you're going to be working right alongside me, completing real-world exercises. Following each lesson, you'll have the option to do interview-level practice problems to not only prep you for the job, but also reinforce your learnings. And by the end of the course, we'll have used SQL to build a fully customizable portfolio project that you can share to demonstrate your experience. Now, SQL is by far the most popular tool of data analysts. For those in the United States, it's the top skill that's in almost half of all job postings for data analysts. And this only increases in demand for senior data analyst roles, coming in at 2 out of every 3 job postings. Now, in related data jobs, like data engineers, it's almost the same, appearing in 2 of 3 job postings, and for data scientists, it's in almost half. Now, SQL, or SQL, is the language used to communicate between you and a database. It's my most used tool as a data analyst, starting with my first job working for a global Fortune 500 company, and even to my most recent role working with Mr. Beast. Yeah, even Jimmy uses it. This tool is so imperative, I use it all the time with Python, Excel, Power BI, and Tableau to connect to my databases. So over the years, I've been cataloging everything I've found helpful with using this tool, and I've put it all into this course. Now, you're probably wondering, who is this course for? Well, if you're unfortunate to take my first course, here's some items you should definitely know. Keywords used for data retrieval, functions and keywords used for aggregations and grouping, the different types of joins and also unions, keywords used for logic and conditions, along with date manipulation, data schema control, and finally subqueries and CTEs. Now, as far as the math required to take the course, if you have a secondary education, such as high school in the United States, you have the requisite knowledge to take this. We're going to be doing at most just some basic algebra and statistics. Now let's get into the course structure. We're going to be breaking this down into 2 halves. In the first half, we'll have an intro that will get you set up and comfortable with the database we'll be using throughout the entire course. Next, we'll jump right in, pivoting data using case statements. We'll be transforming and analyzing data using aggregation and also statistical methods. Then we're going to get into intermediate date and time functions, because frankly, you can't get away from date and time data in databases. We'll then wrap up the first half covering window functions. The most requested topic I've gotten by far on this, covering basic and also complex aggregations. Now for the second half of the course, we're going to shift gears. We're going to not only install Postgres on your machine, but also we're now going to be working in these lessons to building our portfolio project. We'll start by setting up the database locally and installing a top editor for running SQL queries. With this environment set up, we'll build our first view, and this will actually help us solve our first portfolio problem. After this, we'll transition into learning the most popular functions to transform messy data to solve our second portfolio project problem, and then we'll wrap all this up with query optimization, understanding how to use keywords like explain to optimize queries. So by the end of this, you'll have a real-world project to showcase your newfound skills and demonstrate your experience. Now, I'm a firm believer in open sourcing education and making it accessible to everyone. So this course is completely free. I've linked all the resources you need below, including the SQL environment and all the different files you need to run the queries remotely and locally. Oh, and I'll also include my final project that you can also model after. Now, unfortunately, YouTube isn't paying the bills like it used to. So I have an option for those that want to contribute and thus help support fund more future tutorials like this. For those that use the link below to contribute, you're going to get some more additional resources. Specifically, after each lesson, you're going to have access to interview-level SQL problems. It will not only reinforce your learnings, but also prep you for job interviews. In here, you're going to get community access to be able to ask any questions to fellow students, along with access to the queries and notes behind each lesson, so you can follow right along as I go through it. Finally, at the end, you'll receive a certificate of completion that you can share to LinkedIn. Now, for those that have bought those supporter resources, you're going to continue watching the course here on YouTube, but then you can go to my site to actually work through all these problems, access to the notes, and access to community. All right, we're about to get into the first lesson. Before we do that, I want to cover some common questions and answers. Specifically, we're going to start with this one first. Of what database are we even using? Well, every year Stack Overflow interviews a bunch of nerds to find out what are their top technologies that they're using. And 50,000 chose that Postgres was their top option to use and to use over the coming year. And according to this visual, it's not only the most admired, it's the most desired to learn database. So for this course, we're going to be using and learning with Postgres. Now that we know the database, how the heck are we going to be running these SQL commands? Well, as I mentioned previously, this course is broken into two halves. And we're going to be using an option for the first half to get you up and running quick. Specifically, we're going to be using Google Colab, which is a free option. And it allows us to have an environment that we can not only load the database in, but also query it. I've linked this notebook below and it includes all the code necessary to install this database and get into querying it. Now don't worry if you haven't used Colab before, I'm gonna break it down all in the next lesson, which for those that bought the course perks, you're gonna get access to these lessons which are in a Jupyter notebook. For the second half of the course, we're gonna shift gears and we're gonna install Postgres locally on your computer and run all the queries from there. We're gonna get you set up with pgadmin, which is Postgres custom GUI in order to interact with databases. But from there, we're gonna get you set up with the most popular database editor, DBeaver, which is used by over 8 million users. And this is where we're gonna be running our queries. And I like this editor because it's not only free, but it also connects to a host of different databases. So whatever you use and learn in this course with this editor, you can apply to other databases. Now that we know the database and the editor, what data set are we gonna be using for this? Well, I present to you 𝗏𝗏𝗄𝗏. And this is a data set created by Microsoft used to imitate real business data. Jumping back into DBeaver, we can see the ERD or Entity Relationship Diagram, and this shows how the data set revolves around sales data. That's the fact table, and then we also have 4 dimensional tables that relate to it. This is gonna be great for analyzing business transactions in a real world scenario. We're gonna go over everything you need to know for this after our Google Colab lesson. Now that we got that out of the way, let's get into some resources you have available, starting with those that have decided to support the course. First, I'm gonna walk you through how to get access to the course notes, which detail all the different topics and code that I use within each lesson. And next, you're gonna have access inside of the course platform to interview level SQL practice problems. After each lesson, I'm gonna provide you with a bunch of different practice problems that range in difficulty for you to go through and test your skills. If you get stuck, feel free to jump in the comment section below and talk with other students in the course. Speaking of help, how the heck do you get help in this course? Well, you could jump into the YouTube comment section and hope somebody comes and actually answers your question. Or you can get a really quick answer going to a reputable chatbot like ChatGPT. I use this bad boy all the time with my coding issues and it gets you an answer quick. All right, next question. Well, isn't really a question, it's more of a statement. People tell me all the time, Luke, this video is too long, I can't navigate it. Well, unfortunately, I think you don't know how. First of all, I include chapter markers for all the different lessons throughout this. The next is keyboard shortcuts. I like to use J and K in order to jump forward or backwards 10 seconds. And then finally, if you need more precise navigation, you can just click and drag up on the navigation bar of the video itself, and then you can do precise seeking. Pretty cool. All right, last question. Who helped build this course? And I'd be remiss if I didn't give a shout out to Kelly Adams. She was the brains behind putting together the lesson and also a lot of the practice problems for this. This course wouldn't have been possible without the help of her. All right, let's get into the first lesson. All right, in this lesson, we're gonna be going over how we're gonna be running SQL queries in this first half of the course using Google Colab, which is a type of Jupyter notebook. So link below is a blank notebook, and opening up, it's not fully blank, but it's blank enough to actually get started with writing SQL queries. Let's do a quick demo of how we're going to use this for SQL queries. First, I need to run this cell up top, and it's going to give me this warning that, hey, this notebook was not authored by Google. It's fine, it's run anyway, it's from me. You can trust me. It should take about 40 to 50 seconds to run this cell, which we'll go through more later in this video. Basically, it's loading the database and getting it set up for us to actually use. And now run SQL commands. So inside this code cell, let's provide a command. So we're going to begin by writing our command underneath this %% SQL syntax right here at the top. And I'll provide this query looking into the sales table, looking at those top 10 options. I can run it by pressing this play button or pressing Shift Enter. In less than a second, I have all the different results pictured below. If I want to run another cell, I can just come underneath it, click code, make sure that I add that %% to the top of the cell. It's not going to work otherwise. And then run my next command that I want to right underneath this. All right, with that out of the way, we're going to now dive deeper into understanding what is Google Colab, what are Jupyter Notebooks, how to actually use these to run SQL queries, and what the heck is going on with all that code that I had in those cells. Now, if you have familiarity with using Google Colab already, or are already confident in using Jupyter Notebooks, and you feel like any of this that I'm going to cover is not relevant to you, it's fine. Go ahead, skip to the next lesson. This is more focused on those that don't have any background with using Jupyter Notebooks. So let's start with Jupyter Notebooks. Here I have a Jupyter Notebook of this actual lesson inside of VSCode. Don't worry, you don't need to actually open it inside VSCode, just showing this for demonstration purposes. Now, personally, I love Jupyter Notebooks for performing analysis because not only can I have these text cells like are pictured right here, and then scrolling down even further, I can see that at the bottom, I have a SQL cell along with the SQL output. So I love these because I can use SQL to extract out and analyze the data I need, and then, if needed, use something like Python to visualize it. Now, moving into Google Colab, which you can see right here, I'm inside my web browser, and this is that same exact file that I had inside of VS Code, but now it's here inside of Google Colab. And similarly, it has that same functionality where I can write Python code in cells, along with using that SQL and the outputs of that below it. I really like Google Colab because it makes it super easy to share and collaborate with others. This isn't just a static document. I can come in here and actually run all the different cells inside of this notebook. And if somebody wanted to, they could come in and modify this query further. So right now, this one's only looking at years. And let's say we wanted to look at the actual total revenue. I could just add this line in the command, run it, and get the results right below. So super easy to collaborate with others. And now you may be wondering, why are we actually using Colab for running these SQL commands? Well, basically this code right here that I have in this cell that we're going to cover, I promise, allows us to load in our database and for you to have access to the database immediately without having to actually install it locally on your own computer. So basically we can get up and running with running all these different SQL commands really quickly. Let's start with a blank notebook to walk through this process of understanding how to use notebooks. If you navigate to colab.research.google.com, this is where we're going to start a new notebook, and it will have prompted you to log into Google at this point. Anyway, go and click this. So it starts this new one, which gives the title Untitled 0. You can go up here and actually change it. And I'll change it to something like Colab 101. Quick overview before diving into the center portion right here. We have a typical menu up at the top to do a bunch of different options. And then we also have this sidebar over to the left-hand side that gives us a lot of different options as well. In the center here is where the actual notebook is itself, and I can do things like either add a code cell or a text cell. If I wanted to, I could type into it, this is a text cell. I can also change the formatting of it by highlighting it and toggling it to being a heading. They also have multiple other options available as well. Whenever I'm done with this, all I have to do is press Shift Enter. And whenever I press Shift Enter, it then starts another cell, a coding cell below that. Now in Colab, these are exclusively Python cells. We have to do some magic, if you will, in order to get it to run SQL. But you may not realize it, but you actually know some Python, even if you don't know it. I can do something like 2 + 2, press Shift Enter. And what's going to happen here is it's going to run the cell of 2 + 2, and then we get the results of 4. Now, if I don't need certain cells, like this one up at the top, I just click into it and click the trash can. Similarly, I can do it to this one down below. Now let's go over these menus, and for this, I'm going to be demoing it using the actual lesson plan notebook from this, because it makes it more interactive to show what actually the capabilities of it. Anyway, over on the left-hand side, if I click this over on the left, I have the table of contents. Based on how I formatted all the different lesson notes, I can actually scroll through and see all the relevant topics. If I wanted to find something, I could just go in here and type find of markdown. And as expected, take me to all the different markdown things inside of here. We also have other things like variables, secrets, and also files. That's more in depth if you're using Python for this. You won't really need to use that. Along with these three at the bottom, also not going to be using as much in this SQL course. Now, up at the top in the File menu right here, File, Edit, View, Insert, everything like that's normal. Runtime is the one location that I find I'm actually using the most and find the most important. Anytime I'm opening a notebook, I'm going to be doing this run all. And I can also see that I can do this with the shortcut of Command F9. And this will go through and actually run all the cells. Down here at the bottom, it gives you a status update of what's going on along with the time it's taking so far. Now, scrolling through all these different cells, I can see they all executed properly. But sometimes we run into bugs and they're not running properly. In that case, we can come up here into runtime. And I recommend running this of just restart session and run all. It will prompt you if you really want to do this, and yes, go ahead and do it. Basically clear everything out and run it again. Now, that's only if you're having problems. You shouldn't, but if you did, now you know. In this last section of the lesson, let's understand what is going on with how we're running SQL queries inside of this notebook. For this, I want you to actually open up that blank SQL notebook and load it into your window, and you can follow along with me. If you haven't done it already, go ahead and up at Runtime, click Run All. So I mentioned earlier, all of this code here, which is in Python, goes through and actually installs and sets up your database. We're gonna walk through it really quickly, but the important thing to understand here is not necessarily the code or that you need to code it yourself. It's mainly to understand what's going on behind the scenes. First, it goes in and imports some important libraries that we need for this. Next, if it's in Colab, which we're in, we go in and install Postgres. So Postgres is actually running inside of this environment that we're inside of. It goes through and sets up a user, a password, and then from there actually installs the database itself, which you can get at this link right here. From there, we import in a SQL library in order to be able to run SQL commands. Specifically, it's called 𝗖ecie𝘂𝗿𝗀𝗄. And then with this 𝗖ecie𝘂𝗂𝗀𝗄𝗃, we go ahead and load the extension, actually connect to this database that we loaded in from up above, and we do some other fancy things that help us get formatting and everything else set up properly. So similar to before, below this magic command of %% I can write a SQL query. As I'm writing these SQL commands, you should have autocomplete come up. So in this case, I have select. If I want to use it, all I have to do is press tab. And then once I have everything I need there, once again, I can press Shift Enter. Now that magic command is really important. If I were to copy this, paste it below, one, I get all of this highlighting saying that it's misspelled and that they have syntax errors. And then two, when I actually try to run it, I get actual syntax errors. So very important that you put these magic commands up at the top. Now, so people don't think I'm crazy, magic commands are the actual official language of this. And we're not only limited to SQL magic commands, they also have a host of other ones. Let's say I want to use this one of 𝗏𝑖𝑚eit, where it measures the execution time of the next line of code. I could type the magic command of %𝗏𝑖𝑚eit. Some help pops up of what actually is going on with this module that we're actually using here, which is pretty actually useful. And then underneath it, I can put in some Python in here. I'll just do something simple like 2 + 2. Running this, pressing Shift Enter. We can see that the special command provides the time of this took 9.93 nanoseconds. Now with these magic commands, you can also use just 1% sign, and that means it applies only to the line that it's currently on. So in this case, I could do 2 + 2 on this line, press Shift Enter, it's still going to run it. Which in this case, it looks like it's a little bit faster. But if I actually had only 1% sign, and let's say this is on another line, pressing Shift Enter, it's just going to output the 4 and it's not going to actually time it. It's not until I actually use 2 of the percent times and run it that it will actually time it. And now we're back up to 9.85 nanoseconds. So I'm just reinforcing this because it's very important that you remember to do that %% SQL before any SQL command. Now, if you're a nerd like me and you want to dive deeper into the documentation of 𝗖ecie𝘂𝗂𝗀𝗃, basically the brains behind that SQL magic command, you can. I'll link it below. All right, for those that purchase the supporter resources, you now have some practice problems to go through and get more familiar with how to use Jupyter notebooks and SQL queries together. In the next lesson, we're going to be diving deeper into the database to understand all the different tables and what comes along with it. With that, I'll see you in the next one. In this lesson, we're going to be getting an intro into the database that we're going to be using for the entirety of this course, specifically the Conditional database. For this, we're not only going to explore why we're using this data set, but also the components about it, exploring all the different tables using things like the ERD or Entity Relationship Diagram. Now we're going to use this lesson as a warm-up to get ready to get into using intermediate SQL. So during the course of this, I will be covering different past topics that you should know in order to get you up to speed as fast as possible if you haven't used SQL in a while. By the end of this, we're going to be covering a query from scratch in order to dive into the most popular tables while using Google's Colab and some additional AI features to speed up your workflow. Now, the 𝗏𝗲𝗄𝗏 database that we're going to be using for this is based off of a data set from Microsoft, which they've been using for years whenever they launch any products, specifically SQL products, in order for you to explore how to use the functionality of it. Anyway, this database is really robust because it contains a lot of different information in it, such as sales transactions, product information, store details, and even date and time data. And this database is great because it allows us not only to explore all these different intermediate SQL topics that we're going to be using for this, but also it's based on a real world business set of data. So what you're going to learn in this course, you can apply to the real world. And so you may be like, Luke, how the heck do I get this database installed? Well, remember from the last video, we have this Python code up at the top that actually goes through and installs the database. The database or the SQL file for loading it is located at this link. And we go through this script right here in order to load it in to this Colab notebook, which I've conveniently linked a blank notebook below that you'll be able to follow along any of the lessons with. So this diagram shows via these lines between all these different tables how they are actually related. And there's actually a lot of columns inside of these tables themselves. So we put these ellipses at the bottom to basically signify or symbolize all the different columns that are in it. So let's get into breaking this bad boy down. We have a total of 6 tables in this 𝗏𝗏𝗄𝗏 database. Specifically, our main fact table is the sales table. And this contains all of our quantitative business metrics that we're actually going to be analyzing and inspecting as we go throughout the course. So it's probably the most important table you need to know. Then we have 4 related tables, or commonly known as dimensional tables. These things have descriptive attributes that we can use in our analysis. So for things like store, we relate it using the store key and the sales and then stores table. And the store database has information on, well, the stores. Similarly, this can be said about the product and also the customer table. The date table is slightly different in that it relates to the different dates, specifically our order and delivery date. The last table in this is that currency exchange table, and it's not related at all to our fact table, and we'll show why in a little bit. Now you may be wondering, how can you actually go through and see what this database looks like and understand what are the tables in it? Well, we're going to be exploring tools later in the course. Specifically, this is pgadmin right here, where I can visualize that ERD. And it shows how our fact table of that sales table is related to all those other different dimensional tables. Additionally, it's pretty nice because I have this 𝗏𝗏𝗄𝗏 100K, and I can go into something like schemas and then down to tables. And further, I can further explore all these other different tables as well, even looking at things like the columns for the sales table. But we're getting ahead of ourselves. We'll learn how to do that in a bit. I'll teach you some shortcuts on how you can actually do something similar to this in Colab. So let's get into run some queries. First thing we need to do is go through and actually run all the different cells in your notebook, basically get that database loaded into our environment. And so we're looking to explore what are the tables in this database that we just loaded into here. I'm going to use Gemini for this. If it's your first time using this AI model from Google, it's going to prompt you with this privacy notice. Make sure you click continue. And I can prompt it this of what SQL query shows the tables in a database. What we can do is access all these different table names by looking in information schema, which is a meta database, and specifically using the dot attribute, looking at the tables within it, which is a table. Now for this, you can either click copy cell or you can do add code cell. Now, remember, we're going to have all the syntax highlighting issues because we don't have in that magic command we need to put at the top, specifically that %% SQL. So I'll just copy that from here, paste it up here, and then run this bad boy. So from this, we confirm we do have 6 tables in our database. And if I wanted to, I can convert this data frame to an interactive table like this. then we also have this option to visualize it, which we're doing later down the road. So let's explore first that sales table, as that's the most important part of this whole puzzle. I want to see all the different columns of this, so I'm going to use select and then star. We're going to do this from that sales table. Now, if you're noticing right now, I have some auto completion happening right now. You see I type sales and I have this underscore fact underneath it. This is the AI auto completion. Especially whenever I'm learning how to use SQL, I don't find this very helpful and actually quite distracting. So we can turn this off real quick. If we go into open settings and select under AI assistance, we can uncheck this option here for show AI powered inline completions. Whenever we close this, we can see no longer pops up. Now, this is good enough query as is, but anytime I do a select star type thing, it's very resource intensive, especially if there's a lot of columns and rows. So with this, I'm going to limit this to just the first 10 rows. Then from there, press Control Enter. Also don't need this query off to the side, so I'm going to close that. So with this sales table, we can see that it has all those different relations to those other tables, such as the dates, customer key, store key, and product key. From there, we have information on what is actually sold in this sale, specifically the quantity, the price, the cost, and then also the currency used and its exchange rate. In our example at the end of this, we'll go through calculating what is the net revenue and how we need to actually multiply or use all this together to calculate that. But let's get through exploring these tables. Specifically, we're going to go with the easiest one first, next of exchange rate. If you recall, our currency exchange table is in no way related to that sales fact table. But what the heck is in it? Well, exploring it, we can actually see that in it has a date column, from currency to currency, and exchange rate. Basically, at a specific time in history, it tells you how you could convert a currency from one to another, what the rate you need to use for that. Now, conveniently, our sales table automatically just includes this exchange rate, which was calculated from this table. So technically, this table is only needed if you need to go back and dive into understanding the exchange rate and how it's trending over time. All right, we have 4 tables left, and they're all the dimensional tables that are related to our sales table. Let's start with store first. This one is related to that sales table on a store key, and then has information on where this is located, such as country, name of the store, even the size. Next up is our product information, and it's related to that sales table on that product key. It has information on the product, specifically what is the name, who's the manufacturer, how much it even weighs, and what categories and subcategories that falls into. Next up is our customer table. It's related to that sales table on our customer key. And this has a bunch of information related to the customer itself, like where they're located, what their name is, what their birth date is, blah, blah, blah. Anyway, what you notice right here in the middle is we have these ellipses, and that's because there were so many columns in this, it didn't show it here. Now, previously, whenever we were looking for the tables in the database, we could run this on that metadata inside the information schema. So what I'm going to do is I'm going to take this right here, Command-C this, and I'm going to paste it right into here. But for this, we don't want to use tables, we want to use columns. Running Shift-Enter on this. This only gives us table name information. So I'm actually going to change this to select star, run Shift-Enter so we can see everything available in this query. And inside of here, I can see of this columns table, we have a table name and column name. So what I can do is I can now filter this for the table of customers. So I'll specify where table name is equal to customers. Running this again, pressing Control Enter. Oh, got a typo. It's customer. Running Control Enter again. So now I have a way to view all the different column names, and it's not cut off. And so we can see everything inside of it. But not really finding anything that great right here for now, but other stuff we'll use in the future. Last table to explore is that date table. This is related using that date column here to the sales table, order date, and delivery date. Now this table has a lot of different ways that you could aggregate all the different date data in here by looking at maybe day of week or month or year. So this is great and all, especially if you're using a tool like Power BI and you want to just grab something quickly in order to filter maybe for January 2015 data. But in this course, we're going to be diving deeper into using different date functions And so we're not really going to rely on this table at all to get the data out because you won't always have a date table available in order to investigate things. So basically, just ignore this bad boy. Now let's wrap this lesson up by getting into an investigation of how we can use all these tables together for a common example. So let's say my boss, who's not so good at SQL, comes to me and wants to get some different revenue data that has information about customers and also products they're purchasing and whether they're of different high value or low value items. So we're going to walk through this example, calculating the net revenue for this and how we can put this all together using all the different tables. First thing we need to do is calculate net revenue. So let's look back at that sales table. We're going to use that same query as below, and we get this table that we saw previously. Now for this, how do we want to actually calculate that net revenue? Well, in order to do this, you need to use the net price. Now you'll notice from this, the net price is less than the unit price. And that's because the net price is the price after all the different discounts, promotions, or any adjustments. So basically, it's what we actually charge to the customer when they pay for the product. And with this net price, we need to multiply it times that quantity. So what I'm going to do is put a comma here, go into a next line, and say we want to multiply the quantity times the net price. And we'll say this, we'll label this as the net revenue. Now, when I name variables or when I name new column names, I'm going to put this underscore between it. I just find it easier to read than the naming convention that 𝗏𝗏𝗄𝗏's database is using. And looks like I have a typo, which is pretty good that we hit this right now because this is how I'm actually going to go through and troubleshoot this. First, it will tell me that there's this runtime error. Anytime I'm running a query, you can just ignore that. You're going to be seeing that all the time. But it actually points this caret here to where the issue is. Specifically, it's pointing to this line. And it has to deal with quantity is not spelled correctly at all. Running this again, pressing Control Enter. Okay, we actually have it now. And over to the side, we have that net revenue. Double checking this, it looks like all the numbers are actually getting calculated correctly. There's one last step to do, and that is we need to convert it to a common currency. Right now, you can see that they're using pounds here and then US dollars below. Basically, we're going to use it all the same. I'm in America, so we're going to be using US dollars. All we have to do for this is just multiply by the exchange rate. Gone ahead and added it in, and now we can see that it is in fact adjusted for what it needs to be. Now we're going to be adding customer and also product information using this customer key and product key. But this table's already getting sort of large, so I want to condense it down to different columns I'm going to use. And really the only other thing I care about is order date. So we'll go ahead and simplify this table down to this. Next, we'll move into our second of 5 steps, and we want to filter for our recent sales. Specifically, we want things from 2020 and greater. For this, I'm going to use a where clause, and I want this for that order date that we have in that sales table to be greater than or equal to January 1st, 2020. Now, let's go ahead and try to run this. And it looks like it works. Now, I would say in order to be safe, if you're ever working with date data that you're not sure if it was converted to the date type, specifically in Postgres, you can use this : operator and then specify the data type you want to use for this. In this case, date. So order date is getting converted or cast as a date. This is going to work just fine, but just a tip for you. All right, next thing my boss wants added in is the customer info about who ordered that order. Now, in order to do this, we need to use a join, and there's 4 major types of joins: left join, right join, inner join, and then full outer join. In our case, we want to perform a left join because table A is our sales table, and we want any related data to that A table in the sales table returned from that B table or customer table. So let's add this left join. Remember, it's going to go between from and where. I'll add in a left join. We want to do this on the customer table. We're going to give it the alias just C to make it easy. Similarly, I want to give sales an alias as well. I'm actually going to bring this down and then indent this over. I'll give this the alias of S. Now, for this left join, we want to do this on. From the sales table, we want to use that customer key. And then from the customer table, we want to use customer key. So we're going to use good actual naming conventions here. I'm going to add that S dot to the front of order date, along with the front to quantity, net price, and exchange rate. Now I'm going to go ahead and run this to see if it actually works. And it looks like it works. We don't have anything from the customer table. I'm going to go ahead and add in all the different columns by doing basically a C.star notation to bring all those in. All right, so from this list, I can see there's a few different columns we want that my boss has told me about. Specifically, we want to get the given name or first name, surname, country full, and then also the continent that they're from. All right, second to last step, we need to now add that product information in. And similarly, we're going to be forming a left join with this. We'll give that product table an alias of P, and we'll be connecting it on the product key of the sales table and the product table. Once again, I want to see everything from that product table, so I'll do P.star. Running this, Control Enter. I can see that we connected it properly with all the different product information. Once again, I don't want all the different columns associated with this. I only want a select few designated by my boss. Specifically, these 4 columns of product key, product name, category name, and subcategory name. All right, so looking pretty good with this. Only one last step to do, and we'll have all the information we need. Specifically, we want to look at whether a customer is high value or low value. Looking at the net revenue, we want to basically bin these customers into whether they're spending less than $1,000 or greater than $1,000. In order to accomplish this, we need to use a case when statement. And we're going to add it in at that last column right here. So we'll say case when. We want to look at the net revenue, but we can't use an alias inside of the select statement because it's not necessarily defined yet. So we just need to take all of this below, paste it in here, and say greater than 1,000. And in that case, we want to say that it is high. Else, we want to say that it's low. So we can end this, and then we're going to use the alias for this of high, low. Real original, I know. Let's run this, pressing Control Enter. Inspecting it, we can see that our formula is working for those values that are greater than 1,000. We're marking it as high. So this has everything that we need in it for my boss. Remember, right now we're doing this limit 10. We actually need all the different data in it. So I'll go ahead and press play. Looks like we have 124,000 different rows in this. And if I wanted to export this to my boss, I could click this here in order to convert this into this type of table. But what's really convenient about this is I can now copy this entire table, which allows us to either export to a CSV, JSON, or even Markdown. CSV is most common, so I'll use that. All right, so now that's our initial dive into this 𝗏𝗏𝗀𝗏 dataset. We now have some practice problems for you to go through and get even more familiar with this dataset, working through some problems. In the next lesson or the next chapter, we're going to be diving into using the case statement in order to pivot data. Super exciting. All right, with that, see you in the next chapter. Welcome to this chapter on pivoting with case statements. And specifically, we're going to be using statements like case when and aggregation in order to pivot data. But what the heck is pivoting data? Let's take a look at this simple example, focusing on that first table first. Typically, our data comes in a long format. And in this case, we have an example of a columns of date, category, and sales, where we have different categories of A and B. It's very common to pivot things, such as on the category here of A and B, so that way we get to more of a wider format as shown below. This is not only easier to read and understand and analyze, but also easier to visualize, which we'll be doing in this. So what will we be covering in the lessons in this chapter? In this lesson, we're going to be focusing on understanding the basics of using aggregation methods such as count and sum in order to pivot data. We'll use count to analyze the number of customers per region, and then we'll use sum to calculate the net revenue based on different categories in different years. In lesson 2, we're going to build this up further and start looking at statistical functions such as min, max, median, and average. For this, we'll get into an example of calculating what is the median sales across categories. And then finally, in lesson 3, we're going to jump into advanced use cases of case statements. Specifically, we're going to be looking at things like segmentation. We'll learn how to analyze by multiple AND conditions in order to look at things like bucketing for certain years based on revenue. And then similarly, we'll use multiple when conditions in order to analyze different bucketing of revenue tiers and see how they apply across different categories. Now, I just showed a bunch of visuals, and the goal of this course is not learning how to build or make visuals, which I will show in this, but really I want to be able to show that, hey, with these insights that we're gaining, you can take it a step further and visualize it. All right, with that, let's get into it. In this first example, we're going to do a review understanding count, but also distinct count in order to calculate the total number of customers per day in 2023. This will be the final table that we end up getting. As always, if you want to follow along, open up that blank SQL notebook and run all the cells in it so we can get started. So remember, we want the total number of customers per order date. We can uniquely identify this based on the customer key. So I'll add a select statement. From there, I'll add order date, followed by customer key. And then we'll get this from that sales table. Let's start with this first. So as we can see from this, this is the first of 2015. We have duplicate customer keys, but then we also have a bunch of different ones. We're going to start simple first. We're just going to do a count of all the customer keys. So I'll wrap customer key in count and provide it the alias as total customers. Let's run this. And this isn't going to work right because, well, we need a group by, right? So adding that group by statement, we'll add in, we want to do this by that order date and then run this again. All right, so now we have the order date by total customers. Right now I'm noticing that the dates are not in order. So I'll add in an order by order date, and not too bad. But remember, previously, whenever we were actually looking at it, we could see that customer key is actually duplicated. We want to find the unique customer. So we want to use something like distinct. So going back up into our original query, all I'm going to do is add in distinct in here and then run Control Enter. And now those numbers are going to drop right because we're going to remove all those duplicates. Last thing we need to do for this one is just add a where condition for filtering for dates in 2023. So I'll add an order date. And for this, I recommend using the keyword between. So you don't have to do that greater than, less than, all that kind of mess. And then putting in between January 1st, 2023 to December 31st, 2023. Running this, we can actually check the contents. Yep, January 1st to December 31st. One quick note on visualizing this. You can use this button right here and actually select it to go through and draft different visualizations to try to understand what is going on here with the data. What it will do is it will give you different previews. In our case, this is time series data, so I know that's the best choice to use for the visualization. Whenever I go to select it, it will auto-generate all the different Python code you need in order to visualize that data. And then all you have to do is click Add Cell. And then running this, you can actually visualize it in more detail right below. So that's why I really like Colab for this, is because it has Gemini implemented into it. It makes it super simple for you to just go forward and actually visualize this. All right, let's now get into actually pivoting using count as an aggregation. And for this, we're going to be looking at something similar from that last example, understanding how many daily customers we have, but broken down by region, specifically 3 continents of Europe, North America, and Australia. For this, we're going to be getting this final table where we have things like order date in the leftmost column, and then we have the customers based on the different regions in their own individual column. First things first though, what continents do we actually have available inside of our database? It's underneath the customer table, and when we run this, we can see, as I previously reported, you got Europe, North America, and Australia. So let's go forward with actually adding this table into the query that we just made at that last example. In order to do that, we're going to be performing, very commonly, a left join. And that'll be with the customer table with an alias of C. And we'll do this on our customer key. And what we'll need to do now, because we have 2 tables in here, we'll need to assign an alias also to our sales table, and then also to all those other different columns that come from the sales table. Running this to make sure that there's no errors. There are. Accidentally messed up order date. Run this again. Okay, everything's working fine now. But now we need to create individual columns for total customers based on continent. So how are we going to do this? Well, let's focus on this syntax right here. We're going to be using the count distinct as we used previously. And inside of this, we're going to be throwing in a case when statement. It's case when a condition, then what the output we want it to be, the column in this case, and then end, and then finally assigned an alias. So I'm going to go ahead and copy this right here, and I'm going to insert it in the next line underneath here. But we need to go through and actually fill it out. So the condition is we're looking for if it equals a certain continent. So for the continent from that customer table, we're going to see in this case if it equals to Europe. And specifically the column that we want from this is then that customer key. So I'll go ahead and put that in. And this one will give the alias in this case called EU_customers. Let's try this bad boy out. And bam, now we have our European customers in here. Let's go ahead and add the other two as well of North America and Australia. All right, I got those in as well. Have the North America and then also the Australian customers. Go ahead and run this. And scrolling down, we can see that based on the total customers, the Europe, North America, and Australian, they do add up to this line right here. So that field of total customers is now somewhat redundant. I'm gonna go ahead and actually remove that. And this will be our final query. Now, visualizing this one, similar to the last one, this one I find, especially it has multiple different columns in it, the visualizations it provide aren't that good. Specifically, it is here in these time series, but it's broken up to where this one's Europe, this one's North America, and then this one's Australia. They're not all on the same graph. So unfortunately, Gemini in this case is not that strong in producing graphs. If you really want to visualize it and you want to know my method for it, all you have to do is go ahead and click that table. And then remember, you can actually copy it. And this is going to copy the table to your clipboard. So this content's right here. I want it as a CSV. I'll go ahead and copy it. And we'll need to put it into some sort of document because it's pretty long. So you want to put it into a document such as CSV. So on Mac, I'll put it into something like TextEdit. On Windows, you'll put it into something like Notepad. I'll just paste the contents in using Command V, and then from there, just save it. Inside your favorite chatbot, in my case, I really like ChatGPT. You could use Gemini, Claude, whatever. I'll give it the simple prompt with the actual document of visualize this as a line chart. And then with it visualized, we can actually, I like going in this interactive mode on ChatGPT. We can actually go through and you can see all three of these regions along with visualize. If you want to download the graph, you can, just click it there. Last example for this lesson. For this one, we're going to be looking at using the sum function with case when in order to look at what is the total revenue by category. And we're going to be using that case when in order to look at 2022 versus 2023. This is the final table that we'll be creating where we have category in the leftmost column, and then we'll have the total net revenue for 2022 and then for 2023 right next to it. Now for this, I don't want to start from scratch, so I'm going to take this last query that we took right here and then paste it into cell, make sure it runs properly. All right, now for this, I want to just start simple. I want to first look at what is the total revenue by order date. So I'll just start by first removing, we're going to be done in 2022 and 2023, removing this where clause. Also, we don't need this customer table, so I'll remove this as well, along with this count distinct that we did for all the different customers. With it just simply like this, I'll just run it and make sure, yep, everything's appearing. It's got all the different order dates in it. Okay, now let's get the total revenue, and that's going to be done by using sum. Now, if you remember from a couple of lessons ago, you need three things for this: quantity, net price, and then also exchange rate. So I'll add all three of them here using multiplication, and I'll sign this as the alias of net revenue. Remember, anytime we're doing aggregation, you need to have that group by. Let's go ahead and run this. Not bad, but right now we're aggregating it by order date, and we actually want to break this down based on the category. Just as a refresher, you don't need to run this query. What we need is from the product table is right here, this category name. So one, we're going to need to merge this with our sales table, and two, extract out that category name. So inside of our original query, we're going to go ahead and do a left join, connecting in the product table with the alias P and on specifically that product key. We'll go ahead and run this to make sure that it's still executing properly. Okay, good. We didn't bring anything from the product table in. We need to do that now. And what we want to do is replace this order date now, but with category name. And we have it in 3 places. So I'm going to show you a shortcut real quick. So what I'm going to do is I'm going to highlight all of this. Right now you can see it's only selected on the top one. I'm going to press on Mac, Command-Shift-L. On Windows, you'd press Control-Shift-L. And now all of these are, when I press backspace, all of them are removed. And then as I type, all of them get typed in. Super convenient, saves a lot of time. And then I'll go ahead and run this again by pressing Control-Enter. And bam, now we have category name and net revenue for each. Granted, there's net revenue across the entire data set. Still need to filter down, but there's pretty good so far. Now, in order to do this, base it up on 2022 and 2023, we need to be using a similar type syntax that we used before. Specifically, wrapped in our sum function, we'll use our case when it meets a certain condition of 2022, 2023, we'll provide it the net revenue when it meets that condition. Else, if it's not that year, it's going to be 0. So whenever we sum it all up, you only sum up if it's that year. And then finally, we'll end it with an alias. So I'm going to go ahead and just copy this all. And then inside of here, I'm going to paste it down below. So our first condition is checking on whether the date is in 2022. So for this, we're going to be using that order date column. And we want to check if it's between a certain date, specifically between January 1st, 2022 to December 31st, 2022. I had a brain fart there. For the column for this, we're going to be using what's above here inside of our net revenue of all 3 of these columns multiplied together. And then finally, the alias will provide it. We'll call it total net revenue 2022. Let's go ahead and run this. And bam, we have it for 2022. This is looking good. Let's go ahead and put comma on the end. And I'm going to go ahead and copy this and then pasting it right below. Then I'll just need to go through and update it to make sure that we're now using, instead of 2022, that we're actually using 2023. Make sure to also change the alias. Okay, running this, pressing Control-Enter, we get almost our final results. Once again, we don't need that net revenue in there. It's not telling us what we need. So we'll go ahead and remove it. And now we have our final table. And from this, we can see that for some strange reason from 2022 to 23, for all of these columns, all the data went down. That's not really good. I'll leave that to my boss to figure out. All right, it's your turn now to go through. We have some practice problems aligned for this to get you more familiar with how you can use case when statements in order to pivot data using these different types of aggregation methods. In the next lesson, we'll be building on this, focusing on statistical functions such as min, max, average, and median, and diving further into revenue. With that, see you in the next one. Now that we're warmed up using basic functions to analyze pivoted data, we're going to now shift our focus in using statistical functions for this. Specifically, we're going to be covering these functions. We're going to warm up by focusing on the easy ones first of average, min, and max in order to pivot that database and understand some data insights. And then from there, use the percentile count or continuous function in order to analyze the median revenue of sales. And we'll continue on that same trend of analyzing this based on all these different categories to see what is the highest performing category. So where can we find out what statistical functions are available to us? Well, we'll go to the source documentation. Here at Postgres, they have this section on all the aggregate functions, which includes the statistical functions. And scrolling on down, we can see max and min, which we're going to be using shortly, which find the maximum or minimum value of expressions across all non-null input values. And then similarly, we have a whole host of in-depth statistical functions, those around correlation, looking at R-squared, standard deviation, and even variance. So let's get into actually analyzing using min, max, and also average. I need you to start up a blank notebook for you to work with. And so what are we going to be analyzing for this? Well, if we remember back from last lesson, we calculated the total net revenue by category broken down for 2022 and 2023. We're going to be doing a very similar approach to keep it simple, looking at things like min, max, and average. Because of this, If you still have that query, you can go ahead and just copy that query right above, as we're going to be reusing that and modifying that to apply these new functions. So inside my blank notebook, I'm going to go ahead and paste that right here and actually running it, press Control Enter. First one we're going to try is average, and this finds the arithmetic mean of all non-null input values. So pretty simple in here. We're going to keep this query mostly all the same, but instead of doing sums here, we're going to be performing the actual averages. Because of that, I need to name the aliases appropriately, naming them average net revenue 2023. I'll press Control Enter, go ahead and run this. And bam, now we have our average values. And this is pretty neat because if we remember back, computers had the highest total revenue, but yet in this, home appliances have the highest average net revenue. Anyway, if we want to visualize this, we could click that graph thing and try to actually visualize it below. But being that this is categorical data, I don't find that the graphs it ever provides are that good. Because this table is so small, I actually sometimes can just take this and copy the entire contents and just paste it right inside the chat itself, since it doesn't take up too much space, and give it the prompt to visualize this. And then bam, we can see the different average values for these different categories across the years and actually compare them. Seeing things like computers actually were lower in 2022 than 2023. Now that we understand average, let's explore min and max. And it's going to be a very similar syntax to this. So I'm going to use some AI to automate this. I'm going to go ahead and just copy this query right here, open up Gemini, and I give it the prompt, add in min and max statements, similar as done with these average statements. And then below this, just go ahead and paste it in. Let's see if we can actually do this. I'm going to expand this out to actually be able to inspect this. And it looks like we got it done. So we don't need to be all repetitive. Anytime there's a repetitive task, you can give it to AI to actually do this. I'm going to go ahead and actually insert this into here and close out of Gemini. And then I have all of these syntax errors because remember, we don't have the magic command for SQL at the front. And now I can go ahead and actually run this, pressing Control Enter, and bam. Now in one table, we have not only the average, the min, and also the max, all formatted and typed out correctly. Pretty neat with AI. So let's crank this up a notch and start looking at a similar analysis, but now using the median. And for those that are not familiar with what a median is, if you were to have a list of numbers and then you were to sort them in order, the median is the middle number. So in this case, when we have these 7 numbers right here, 6 is the middle number. Whereas when we have 8 numbers, we take the average between the 4th and 5th number, which could be like 4 and 5, and that becomes 4.5. Now, median is extremely important, especially when you're working with data. In this case, we're looking at salary distribution. This is from my Python course. And we're looking at salary distributions. And you can see that we have the salary go up and then go down, but then it goes out and we have like high out values way out past 350,000. If we just use the average, this average is going to be pushed towards a higher number and is not going to be representative of the actual data. So median helps fix this issue by basically sorting all those numbers, taking that middle number and getting a more representative number of what you would expect to see. In this case, salary, what would you expect to see? I wouldn't expect to see a higher salary when I know I'm going to get a lower. So you may be like, this is pretty easy. All I got to do is change all these average values to median and then run this. Unfortunately, there's no such function as median. Hence the no function matches this given name and argument type. And that's common across all databases. Whether you're using Postgres, SQL Server, or MySQL, we're going to use this percentile count or continuous. And that continuous portion is a key part because now this function that we're using, percentile count, is not only an aggregate function, but it's an ordered set aggregate function. So what does this all mean? Not only do we have to use percentile count and what fraction we want to use for this, in this case, the median or half of it is 0.5, but we also have to use this other syntax here of within group and then order by. So let's actually break this syntax down. Using this percentile continuous function, we need to provide it basically a list of ordered values. It's not going to sort it itself and be able to pick it out like other aggregate functions. Because of this, we first in parentheses have this order by column. This specifies how we want to order the values that we're going to be picking out the median value from. But this only sorts the values. We actually need to bind it to this percentile continuous function. That's why we have this within group portion right here, to bind that ordered set, if you will, to that function. So let's just take a simple example first using net price. Here I have a simple select statement of net price. We're taking it from sales itself, and it looks like we have almost 200,000 rows of net price. Let's get the median value from this. So I'll first start by using that percentile continuous function. Notice they also have a percentile discrete. That's if you don't want it to average. If you have two numbers in the middle, you don't want it to average. If you want to actually pick a certain value, you use discrete. I mostly stick to continuous. And then we're finding the median value, or that is at the 50th percentile, hence 0.50. And we need to first bind what we're going to be binding this. So we're going to use that within group. And then in parentheses, we'll use that order by, specifically of that net price. And then we'll assign an alias of median price. Let's go ahead and run this bad boy. And bam, we get that median price of $191. Just out of curiosity, I'm going to compare it to that average net price. And similar to what we saw with that salary data that I was showing previously, the average price is much higher. And that's because we have these high value items that aren't necessarily purchased as much, driving that average up. So median in this case is a lot better at getting a representative understanding of what the common net price is people are seeing. So what are we going to be calculating in this last example? Well, we want to find out what are the median sales by category comparing 2022 to 2023. Notice here we're going to say sales. I'm going to use sales more frequently, but this is technically net revenue. But in the business side, we typically just say this is sales. I don't like to start from scratch from this, so I'm going to work with that very last query that we just did, where we found out the average, min, and max for different categories. So I'm going to go ahead and just copy this all and then paste it into a new code cell here. Remember, we're not going to be using this average, min, or max, so I'm going to go ahead and remove it. Let's just start by getting the median net revenue or sales for basically all the years, and then we'll filter down by 2022 and 2023 after. So I'll define that we want the median by specifying percentile continuous. We'll use the binding function within group, and then we'll use that order by. And this will be done on the net revenue, which is quantity times net price times that exchange rate. We'll give it the alias as median sales. All right, let's see if this bad boy works. Control Enter. All right, not bad. We have our median sales for our columns. But fast forwarding to the future, remember we want a column on 2022 and 2023. So starting with 2022 first, I'll put year 2022 here. So know that that's what we're working with. Basically, we want to provide the necessary values right here inside the parentheses to filter down for 2022. So because of that, we need to use a case when statement. So I'll add in case, and then from there, I'll press enter and indent this in. And then we need to fill in when the column name equals a condition, then we want this value of the net revenue. And so after that, we'll actually end it. Okay, so we need to fill in this column name equals condition. Mainly, we want to meet the condition of verifying the order date is in 2022. So we'll remove this out and we'll start by defining the order date. We'll use that between argument and specifying that we want between January 1st, 2022 to January or December 31st. Then it's equal to these values. I'm gonna go ahead and just for good measure to make sure it's a little bit more readable, put that into parentheses. So just to be clear, right, you can see this order by, we have this pink parentheses right here. It's then doing a case statement to determine if they're within a certain date, then it's equal to this value. Else, not gonna have any values. Let's go ahead and run this. All right, not too bad. I want to add in 2023 now. I don't feel like retyping all the values, so I'm going to use Gemini for this, and I'll paste in the code, giving the prompt of add in 2023, also under this thing. And it looks like it did it correctly. I'll go ahead and insert this in, double checking it. Yeah, looking good. And now running this final query, we have the median sales for 2022 and 2023. So just taking it a step further, actually analyzing this, we can see that comparing those median sales to that total net revenue, which is also total sales, We can see some interesting insights, specifically for computers from 2022 to 2023, the median sale actually went down, and corresponding with this, the total sales of that same category of computers went down. So maybe it's something you could bring up to the SVP of computers. All right, so you now have some practice problems to go through and get even more familiar with using these statistical functions when applied with pivoting and using case-when statements. In the next lesson, we're going to be getting into advanced segmentation. We're going to learn how to use keywords like and when to break down analysis even further. With that, I'll see you in the next one. Welcome to this last lesson on using case statements in order to pivot data. And in this lesson, we're going to be going into advanced segmentation. So what is segmentation? Well, it's a really important data analytics concept in order for you to take large data sets and break it down into smaller pieces in order to analyze different behaviors. As a data analyst, I'm applying this concept all the time when I'm using large data sets so I can dive deeper into the details and understand different behaviors. So how are we going to do this? Well, we're going to start off easy. In our first one, we're going to learn how to use the and statement within a case-when statement in order to analyze multiple conditions. For that net revenue of all those 8 categories, we're going to break it down looking at segmentation of year based on 2022 or 2023, along with looking at whether it has a high or low value median price. Mainly look at the net revenue for orders that are less than the median value and look at the net revenue for those greater than the median value. For our second and also final example, we're going to be looking at how we can use multiple when clauses within a single case block. This is particularly important whenever you need different outcomes based on different conditions. And for the example we'll be breaking down the revenue into multiple different tiers. So instead of looking at orders less than and greater than the median value, with this, we're going to take it a step further, and we're going to be able to look at orders based on where they fall in certain percentiles. Now, before we get into both those examples, I want to just demonstrate it real quick how to actually use both of these concepts. The first concept is we could use and to combine multiple conditions within a case-when statement. And this is simply just done by adding condition 1 and condition 2, and then using an and statement. So for this one, we're going to be looking at 2 things, quantity and net price. I'm going to go ahead and run this query right here. We can see based on our order date, we can see things like the quantity and then also the net price. What we want to do is create a new column and classify whether these orders are a high value order. So basically I have a quantity greater than or equal to 2 and the net price is greater than or equal to maybe $50. And then if it's not that, we just want to call it a standard order. So I'm going to insert a new line underneath this select statement, starting with our case statement, and then indent it in to insert in when. We're going to be checking 2 things, right? We're looking at what is the quantity, and that it's greater than or equal to 2, and adding in the and keyword, we're going to look at the net price and whether that one is greater than or equal to 50. In this multiple condition case, we want to categorize this as a high value order. Else, we want to categorize this as a standard order. We'll end this case statement and give it the alias of order type. Okay, running this, pressing Control Enter, we can now see that this allows us to do multiple conditions, and those that have greater than 1 or greater than 50 are categorized as high value orders. The second concept to understand is we can use multiple when clauses within a single case block. Now there's no limit to the number of whens we can put into here, but basically it's shown as every time you have a when, you then need to have that then keyword and specifying what you want after that, and then usually end it with some sort of else. Now I find myself using this type of approach of multiple when statements whenever I have to break it up into different categories. For example, we're going to be following the same approach, right? Looking at quantity and net price, but we're going to want to categorize this now. So previously we were just categorizing high value orders, those greater than 2 and greater than 50, and everything else is a standard order. Instead, we want to more precisely fine tune this. We want to classify when it's a multiple high value item, so greater than 2, and we're going to change the value to greater than 100. Then we want to also check for single high value items, so those that are greater than 100 but are a quantity less than 2, so 1. And then we'll categorize those that are multiple standard items. So those that are greater than 2, but still less than 100. And then everything else is going to be a single standard item. So we can build on this query that we already used previously. One thing to note is, like I said, we changed this. So this is no longer 50. I'm going to change that to 100 and call this multiple high value order. For this, we just enter a new line, enter in our when statement, and then use what we're going to analyze for. Is the net price greater than or equal to 100? Then in that case, we're calling it a single high value item. Next, when quantity is greater than or equal to 2, then we'll have multiple standard items. And then finally, the else will be a single standard item. Okay, let's go ahead and run this bad boy. And scrolling on down, we can see that it appropriately classified based on these multiple different conditions. Pretty neat. All right, so if there's anything you get out of this video, it's these two concepts, because we're now about to get into more technical examples to demonstrate how you would use this in the real world. So as always, I like to start out with what we're going to be aiming to achieve in this. And similarly, we're going to continue our analysis looking at our categories. But for this, we want to not only break it down by year, looking at revenue in 2022 versus 2023, but the reason why we need this and condition is we want to segment it further in order to understand the low revenue and high revenue. What do I mean by that? In the last lesson, we looked at what was the median order value for a single order. Well, basically, we want to see what is the total or net revenue for orders less than median, and then what are those greater than median, thus high. Now, technically, as we showed in the last lesson, we have median values for each of the different categories. In order to understand how this and condition works in here, we're going to keep it really simple at first, and we're just going to calculate a single median value for all the categories and apply it to all. So let's start by calculating that median value. We'll start with select, and then use that percentile continuous function, and then use within group as our bridge to then put in order by for our calculation of our net revenue of quantity, net price, and exchange rate. We'll name this as the median for right now. We need this from the sales table. And since we're working between 2022 and 2023, we'll add a where clause on this as well, specifying using order date between 2022 and 2023. And I have a syntax error because I applied an alias of S for sales. We'll be using this later, so we'll keep it. I'll add that S there, run this again, and we get a median value of 398. So remember, what do we want to do? We want to calculate basically the revenue that is less than the median value and the revenue that is higher than the median value. So just as a reminder, we're trying to calculate with that median value of 398 for orders that are less than 398, what is that total revenue, low revenue, and then also the higher, what is higher. I'm doing this for 2022 and 2023. So what I'm going to do is go back to the problem that we used previously, because we reuse this where we're calculating those median sales at the end of lesson 2 in the last lesson. I'm going to go ahead and copy this. And then back in our blank notebook, underneath our median calculation, I'm going to go ahead and paste this in. Now, we're not going to be using these median sales like we calculated it right here. So let's just run this to see what we have right now, and it should just show all 8 of our categories. And now we can add in those calculations. So specifically for this one, I don't care about the 2022 and 2023. I just want to calculate the low net revenue and the high net revenue. We'll start with low first. We know we're going to be adding everything up, so we're going to be using the sum function for this. And then we're going to have a case when condition. And it's going to have that syntax of case when, the condition, then the value, and then end it. And we'll end it with the alias of low net revenue. So the condition is we want it to be less than that 398 that order value is. So we'll add in quantity times net price times exchange rate and make sure that it is less than 398. This line's getting a little long, so I'll go ahead and bump this on down and then also indent it in. And now we need, what is the value? Well, the value is, what is that revenue? So I'll copy the same formula that we used above, Command C, and place this into value 1. So let's go see if this works right now as written. And looks like it does. Do these numbers make sense? Yeah, they do. So now let's add a statement for the high net revenue. I'll go ahead and copy this all, add a comma, and then paste it into here. changing this to greater than equal to 398, and then changing this to high. And then going ahead and run this, make sure we have no errors. Looks like we have everything here. So now we've at least gotten that low net revenue and that high net revenue. The next thing we need to do is now actually segment it down based on 2022 and then 2023. And this is where we're finally actually getting into what we're trying to teach with this concept of using an and in a case when condition. Specifically, inside of our case when, we can use two different conditions using that and keyword. So basically, we want to add our multiple conditions right here inside of here before the then. So what I'm going to do is enter down and then indent in and start that second and condition. So we've already checked for the first condition of, hey, is it less than the median value? The next thing we need to look at is the order date between January 1st, 2022 and December 31st, 2022. And I can actually go ahead and copy this and also place it in this condition as well. I'll then update this to be, this is 2022, and this is also 2022. Let's run this to make sure that it's working properly. And I got a little bit of a typo. I added two betweens in here. I don't know what I'm thinking there. Try it again. Okay, now it's working. All right, this is looking pretty good. Now all we got to do is add in 2023. So I'll use Gemini for this because I don't really want to fix all that code. Paste in the formula, giving you the prompt of add in two columns for 2023. It generated it, so I'll add that code cell in. And then from there, add in that SQL magic command, run this, pressing Control Enter, and bam, now we have that net revenue for 2022 and 2023, whether low or high. So that's how you use the and condition, but I'm going to be honest, this query, I don't like hard coding in values like this. And so I'm going to show you real quick a little advanced technique so that you don't have to hard code values in. So if you scroll back up to our original query right here that actually calculates our median value, we can use a CTE to insert in this value into that query. Now, as a refresher for CTEs, they start with that with command. And then from there, you're going to be assigning the name of that CTE. So I'll name this one median value and use as. From there, I'll put an opening and closing parentheses along with actually pasting in that value. I like to indent it in to just make it easier to read. We're not using it yet, but I'm just going to press Control Enter to make sure that my query is still operating correctly. It is. And then now all I need to do is insert it into this from command right here. So I'll insert it in as median value, giving it the alias of MV. And then if we remember, the column name is median. So I'm going to replace that 398. Remember, we can press Command-Shift-L to select all of it and then type in mv.median. Okay, let's run this bad boy. Hope it works. And it does, gets our final value. Now this is pretty good now that we can see these breakdowns between the years based on high and low net revenue. If we visualize this, we can actually understand better what happened with the computer sector. Specifically, remember computers drop down in revenue. Well, it's not for those low revenue or those value of orders less than the median value. Really what happened is they saw a drop in the orders for those high value orders, those that are greater than the median. So pretty interesting insight that we found out, and we actually break it down further in the next example. And in this example, we're going to be building on that last example further by using multiple when clauses within a case block. Previously, we were only using one when clause, but we're going to actually step it up a notch and use two when clauses. Why is this important? Well, this is going to allow us to segment within a column into, in our case, different revenue tiers. So all of these will be categorized whether high, low, or medium, along with the associated calculating for the total revenue. So what does this high, low, and medium revenue even mean? We're going to be segmenting based on where an order falls within its percentile. Specifically, if an order's revenue is less than the 25th percentile, we'll categorize this as low. Between 25 and 75 is medium, and greater than 75 is high. Now, why this 25th and 75th percentile? Well, it's actually pretty common in statistics to use these values in order to bucket things into their different quartiles. Technically, statisticians like to call that range between 25 and 75 the entire quartile range. We're just going to call it medium. And then everything less than this, low, and everything higher than this, high. So that's the basis on where we're getting these numbers for. Now you may be like, Luke, how the heck do I calculate the 25th and 75th percentile? Well, remember, the median is the 50th percentile. So that's why in this case, we use that 0.5. So let's go ahead and copy this that we used before. And I'll put in here 0.25, and we'll call this that 25th percentile. Going ahead and running this, we get an error because, silly me, can't start an alias with a number in SQL. We actually need to use a letter to start. So I'll just say, hey, this is revenue, 25th percentile, and now run this. Okay, not bad. Let's do this for the 75th percentile. And adding it all in, pressing Control Enter, we have the 25th percentile and 75th. 75th should be much greater than the 25th, as expected. Looking good. All right, we're going to be using these values in our final query. So we're going to be not going to be hard coding them in. So I'm going to create another CTE. So I'll go ahead and tab this over. And then from there, create a CTE of percentiles. And then assigning it inside parentheses here. So running this, make sure it works just fine. Not going to, because we need to insert a query below it. I don't want to start from scratch with that bottom query. So I'm going to actually just going to scroll up to that previous one that we just created. I'm going to copy this one and we'll modify this one to make sure that it works. Pasting it in here, first thing, I'm going to just get rid of all of these conditions that we created along with that median value because we're no longer using it. But I will go ahead and add in that CTE of percentiles, and we'll just name it something like percentile. Okay, let's actually try to run this. And I can see what the error is now. I have this comma after the end before the from. Let's try this again. Okay, we got all the categories as expected. And we have our CTE inside of there. So the first thing I think the easiest is, because we already have this group by and everything like that, let's add an aggregation in here to actually provide what is that total revenue. So we use the sum function for this. Then we'll add in the quantity times net price times exchange rate. And we'll give this the alias total revenue. All right, let's go ahead and now run this. All right, so we have our categories and total revenues. We now need to do one more step, and this is actually what we're trying to learn of implementing, specifically breaking down all these different categories into those revenue tiers. And so for this, we're going to be using the multiple when statements within our case. I'm going to go ahead and copy this right here and then paste it in between here. All right, so the first thing that we want to check for is whether we're meeting that low tier condition, basically that the order revenue is less than that 25 percentile. So for the condition, we're checking whether this value here, I'm gonna go ahead and copy this and paste it in here, is less than or equal to that revenue 25th percentile that we're calculating up here. So we brought it in with that alias of PCTL, and that's that revenue 25th percentile. And we're going to assign it the value of low. For the next condition, I'm going to go ahead and just copy this right here, paste it into condition 2. And I'm going to just say we want to check to make sure that it's greater than or equal to the 75th percentile. In that case, it's going to be high. Everything else is going to be classified as medium. For the alias for this, we'll name it as revenue tier. All right, looks like everything's in order. Let's go ahead and run this bad boy, press Control Enter, and we get an error, which I'm catching it because it's pointing out that it's with the when clause right here. Now we're aggregating, right? We're doing the sum of the total revenue based on these different tiers. So technically we also need to do a group by for this. So underneath here, I'll add in revenue tier. Let's try to run this again. And bam. Now we got it, not too bad. Now, technically, I would like in the order, I'm a little nitpicky, I would like the order low, medium, high. So I'm gonna put number values out in the front of these in order for it to be able to actually order in the correct order. So I need to actually add that in underneath the category name, and we're gonna do in revenue tier. Run Control Enter. If we got a comma, run Control Enter. Okay, now we have it, and better order, high, medium, low, 1, 2, 3. And this is pretty neat because we're able to do multiple segmentation in order to analyze these different revenue tiers. And we actually visualize it. When we put it into something like 100% stacked column chart, we can see that we have the high, the light blue, whereas medium and then low, we're getting darker. something like that computer sector that we keep on talking about, they are very reliant on their revenue coming from those high ticket items, those that are greater than 75th percentile. Whereas something like games and toys are highly reliant on low and medium value items. So pretty interesting insight. One last technical note. For both the first and last problem, we used these 25th and 75th percentile across the entire range of categories. And similarly, for that first problem, we used the median value across all the different categories. Technically, this isn't necessarily the best practice you should do for this. If we went back to that first problem, you'd actually want to calculate the median for each of these different categories, and then from there actually segment it down and break it down further. But whenever we look at the query, it breaks down, it gets a lot more complex and isn't really what the focus is of this lesson, focusing on that adding multiple when conditions or using that and condition. But if you'd like to see the nitty-gritty technical details, they are in the notes. All right, you now have some practice problems for you to go through and get more familiar with using these multiple different conditions for segmentation. With that, we'll be moving into the next chapter on dates. And we're doing a lot of different functions with that. With that, see you in the next one. Welcome to this chapter on date calculations. And in this, we're going to be learning how to use different date and also time functions and keywords in order to analyze data. Now, in the first lesson, we're going to get an intro in how this is useful in performing time series analysis. Specifically, we're going to use things like date truncate and toCharacter in order to calculate things like the number of unique customers or net revenue per month. In the second lesson, we're going to fine-tune how we can extract out certain components out of the date and also use things like the current date or now in order to investigate certain time periods from when we're analyzing it. And in the final lesson, we'll cap it off with keywords like interval and functions like age in order to calculate things like average processing time and compare that to the number of orders we have. And this is all very important. And so Kelly and I included this in these beginning chapters because you're going to see as you go throughout the rest of the chapters, a lot of the concepts we're learning with how to manipulate dates are going to be used in those future chapters. Date and time data is everywhere you go. You can't get away from it. Now, I highly encourage you for any of these functions or operators. If you're curious of learning more, go into the source documentation, which provide the link over here, or maybe over here. So we're going to be using the date trunc function. So what does this do? Well, in date trunc, you provided a field that you want output from it, whether it's something like seconds, minutes, hours, days, weeks, whatnot, and you provide the source. Usually this is in the form of a date or time. So let's go over a simple example first. I'm opening up with a blank notebook. Here I just have a simple query where we're looking at the order date, because that's what we're going to be manipulating with this date trunc formula, from sales, and we only have 10 outputs. So I'll go ahead and Control Enter. Okay, this is good. Now, all these dates are the same, but I want to be able to see all the different dates. So a little trick you can do is I'm going to use order by and then use the function random. Now, whenever I run this, pressing Control Enter, I'm getting random dates right here. So we can better see if it's actually applying to a lot of different data. Anyway, let's get into that date trunc function. So typing this function right here, we can see that it also outputs in here, hey, we first need our date expression, and then we need our date part, which I just clicked to open up. We can also use this documentation to further investigate what is going on here. So pretty convenient of what's going on here. Okay, so we're going to first input in that date expression, and it's a string, so it needs to be in single quotes. I'm going to put in month. From there, we need to put in the date part, so I'll put in order date. And now we'll run this, pressing Control Enter, and we get, if we see these order dates, we can see that it's just the month. Now notice the data type of this. It's getting converted to a timestamp. And this is a little bit inconvenient and a little bit too verbose for me. So we can clean this up. Specifically, if you remember from a few lessons ago, we can use this double colon sign, which is the cast operator. And we can cast this instead of as a timestamp as a date. Running Control Enter. Now I just have it output as a date. Take it one step further and also just rename this as order month. And we're good to go. All right, so what are we actually trying to calculate in this exercise? This is the final table that we're aiming to get to. In it, we have the order month, which I just showed you how we did. And we want to get with this, we want to use group by to analyze the net revenue and also the total unique customers. So let's start with that query that we just previously built. We're going to add onto this by first calculating the net revenue. Remember, we use the sum function for this. And this is calculated by multiplying quantity times net price times exchange rate. And this is our net revenue. So I'll make sure that this is operating correctly. And silly me, we're doing an aggregation of sums, so we need to perform some sort of group by. So instead of this order by, I'll put in a group by. And specifically, we'll call out that we want to do it by the order month. I'll also go ahead and just remove out that order date so we don't have to add it to that group by. Run Control Enter. Okay, not bad. Getting net revenue per order month. We only have 10 results right here. I have it to limit 10. Mainly I do that when building queries so they operate more quickly. I'll take it off at the end. Next thing to get is total unique customers. So I'm gonna go ahead and add that in. We need to do a distinct count of the customer keys. So count and then distinct, specifying customer key. And then we'll assign the alias of total unique customers. Running this. Okay, we got total unique customers, net revenue, and order month. So exactly what we needed out of this. We can go ahead now, remove that limit 10 and press Control Enter. Bam. Now date trunc is really great, especially if you just want to specify one attribute you want to extract out of it. So just something like month as we did, you could either do quarter, year, decade, century, or even millennium. And so if I like to customize it more, I like to use the 2-character function. Specifically, you provide it something like a timestamp and then the text output, and it outputs it in that text format. Scrolling on down, we can see that it has a host of different options that we can use for this. You can specify a lot of things like hour of the day, year, even things like month. And the good thing about this is you can actually combine these together in a format or in an order that you want. So let's just show this simply by implementing in order date and formatting them as month and year. We'll go ahead and press Control Enter. And we have our random dates right here. Let's now add this new function in its own line. So enter toChar, and then the next thing is the actual field itself. And then next is what we want to output. So in the case that we want something like just the year only, I'm going to put it in single quotes and then go ahead and run it. And we can see, unlike the last one where we had to like cast it as a date and remove all the timestamp stuff, it just outputs what we need. And then if I wanted something else, say not only the year, but also the month, I could just put it in there. So double M in that case, running Control Enter. Now we have the month and year. So this table is super helpful in understanding what are the different formatting options that you have for this, what you can use. So back to the original example that we were working with, we can actually replace this entire line and use this 2-character function, specifying order date and then how we wanted it formatted. And of course, we'll give it that alias, similarly of order month, so it's performing the group by properly. I'll press Control Enter. And so let me forgot a comma after this. And so now I feel this output is a lot more readable regarding this order month, because that removes that day and we can actually see what it is for each of these months, the revenue and total customers. Now, because we aggregated this on a monthly basis, vice that daily basis that we were previously doing, we removed a lot of noise. And from this, we can see that in 2020, we had obviously some sort of worldwide event that caused an impact in the number of unique customers and also net revenue that we had. But it looks like as of 2022, these numbers have returned back to normal, except a slight dip in 2023, maybe something we'll have to investigate later. All right, it's your turn now to go and test these out. We have a few short practice problems so you get more familiar with this. In the next lesson, we're gonna be jumping into even more complex formulas, such as current date or even now. With that, see you there. In this lesson, we're gonna build further than we learned in the last lesson, specifically by understanding more about how we can actually filter dates and even do it dynamically. First, we're going to learn 2 more functions on how to format different dates. And for this, we're going to be diving into how we can analyze things like the net revenue for each year for every category. And then from there, we'll use things like current date and now to basically filter data by a certain time frame from this time period now. Pretty neat. All right, first of the 2 functions is date part. And this one extracts a specific component from a date or timestamp. As we can see, we have the date part function, unit, and then what is the source or column name. Host of different options. So with the sample query, we can look at things like the year, month, or date. Here we're using that date part function, specifying those different components, the applicable column, and we give it appropriate aliases. One thing to note with this, which is not necessarily my most favorite part, is that they come in with precision. So they have decimals after it. And I don't necessarily want this depending on what unit I'm working with. Because of that, I prefer to use something like extract. And it has a very similar format to datepart. It's actually based on datepart. And we can see as going through this, we can do things like day, decade, DAO, and whatnot. Basically, all the same things that we can use in datepart, we can use in extract. The syntax for this is slightly different though. In this case, we're going to use the unit, and instead of doing a string for it, we actually do an uppercase actual variable name, and then we say from the source, in our case, our column name. So this bottom query is using that extract, and we're going to do exactly the same thing that we did just above in that similar example, using datepart. We specify year, month, day, from order date, and provide it the appropriate alias for it. Let's go ahead and run this bad boy. And like I mentioned, I like this one a lot better, especially when dealing with things like year, months, or dates where I want integer digits for these values. So let's use this extract function in order to analyze the net revenue per order month. Now previously, right, we used this toChar or toCharacter function to actually analyze per order month what the net revenue is. Let's instead create columns for months and then also for years. So I'm going to go ahead and remove this portion right here and put in extract. It gives us a hint up here. We want to put in the part first. Well, we want the year. Next, we're going to use the keyword of from, and then the date expression. Specifically, we want to use order date. We'll give it the alias of order year. Next, we'll get into adding that month one. We'll write the extract formula, do it for month, from, and specify order date. For this, we'll give it the alias of order month. Now the group by for this, we're doing 2 columns now. So I'm going to want to actually do order year and order month. This looks good. Let's go ahead and run it. And not bad. It's all over the place. So I'm actually going to go ahead and change this to do an order by at the end of this so that we can get some semblance out of this data. And bam, this looks a lot better. And now we have this in different columns. So depending on how those that I give this data to, they can slice and dice it even more easily. All right, let's actually get into some new concepts and implement dynamic filtering by using things like the current date or the time now in order to filter back. Let's talk about current date first. So typing a simple select statement along with current date, it provides me the documentation for this. And it basically says, hey, it returns the current date as of the specified or default time zone. Parentheses are optional when called with no arguments. Basically, you can provide a time zone if you want. Anyway, running this, we can see we get the current date. I'm filming this. Apparently, I'm filming this on Valentine's Day. That reminds me I need to call my fiance and actually wish her happy Valentine's Day. So I'm glad I saw that. Anyway, that's current date. Let's go to the next one. And that one is using the function of now. Similarly, I can run a select statement with this. Just calling the function, make sure you do have an open and closing parentheses, and we run this. And we can see that it is Valentine's Day at 2:30 in the morning. Okay, actually not filming this at 2:30 in the morning. This is actually Greenwich Mean Time, which is over in England. So that's what time it is there. So that's why for the current date, it gives you the option to actually throw in a time zone in there to update it appropriately. So what are we going to be calculating? Well, the short answer is we're going to be looking at understanding what is the net revenue per category for those orders 5 years ago back from today. We're basically building this table. The important thing to understand is this is a dynamic filter, and these type of things are very important in understanding to do because sometimes you want to, or you'll have workflows set up that run queries automatically at midnight, and you don't want to be pulling in all the data. Maybe you only want the data for the last 5 years, and things like this are great for that. So let's start with our base query that we've seen time and time again. First, we're going to be extracting out the order date, the category name, and then perform a calculation for net revenue. We're going to be doing this from the sales table and left joining it with the product table on the product key, and And then because we're doing aggregation above for the net revenue, we need to actually group it by the order date and the category name. Pressing Control Enter, we got this. And it looks like these dates are unordered. So I'm gonna go ahead and throw in an order by, run this, and now we have the dates in order. So we only need do one more step, but I'm gonna break this step down because we wanna include only orders within the last 5 years. Basically, we shouldn't be seeing anything from 2015. I'm in 2024 as of filming this. So we're going to create a where filter in here to do this, but I wanna break it down slowly to show what's going on step by step. So I'm gonna insert in what components we're gonna use to filter within a where clause. We'll start simple first. We'll look at current date and see what it outputs to here. As expected, we get to see it's Valentine's Day. Now, in order to extract out these last 5 years, we need to get what is the year in the current date and also what is the year in the order date. So for this, we're going to use that extract command. We want from it the part, which is the year. And we'll do from, we'll keep it simple first with just the order date. I'll give it the alias of order year. Running this, see it's working just fine. We're getting that order year for all those different order dates. Next, let's extract out the year from the current date. So we'll just put in here that keyword of current date. And we'll say this the alias of current year. Run this. Okay, not bad. Now we want the year that we're going to be filtering by, right? We want it to be basically 5 years ago. So all we need to do is I'm going to copy this one. We're going to be getting rid of all these. But I want this one right here. And instead what we're going to do is we're going to do -5. And we'll set this one as -5. Clever, I know. Running Control Enter. We can see that the -5 is actually 5 behind this. So what we need to do in our where clause is combine these in a way to where it filters for that. So where clauses go underneath from or the left join. And for this, we want to make sure we want to see the order year. So I'm going to go ahead and copy this above, Control C, is greater than or equal to this -5 value that we did right here. And I'll go ahead and post that in here. Let's go ahead and run this, Control Enter, and bam. Now, it's a little bit hard to read, but we can see just looking at the order date column, these are the orders for the last 5 years. I'm gonna go ahead and remove these unnecessary values now. We don't need this anymore. That was just for building this. And we can see that we have this now. This query is built for the last 5 years. Now you may be like, Luke, it's Valentine's Day right now, but this is going back to January 1st, 2020. What if we want to be very precise about that? And I'll say, aha, to that, we'll answer in the next lesson. All right, you now have some practice problems to go through and get more familiar with using these different things and creating your own dynamic filters. In the next lesson, we're going to get into date differences, basically using functions like age to measure the time between different dates. With that, see you in the next one. In this third and final lesson on this chapter on date and time, functions and objects, we're going to be going into now understanding how to calculate intervals. In the first half, we're going to continue on from that problem from the last lesson. And instead of making really that verbose way of calculating the last 5 years, we're going to use the keyword of interval to write much more succinct queries and readable queries to understand what we want to get an interval of. In the second half, we're going to be going into a pretty interesting business problem of exploring average processing time. So in order to calculate this interval between the order date and also delivery date, which we know, we're going to use functions like age and also show it can be done with that previous function of extract. First, let's explore how to use this keyword of interval. Interval can represent a span of time, such as days, months, hours, minutes, decades, or even weeks. And we use this by using the interval keyword and then a value and unit. So let's test this bad boy out. I'm gonna run a simple select statement, specify the keyword of interval, and then let's do something like 5 centuries. With this, we can see that it gets the title of interval and it calculates it to be 182,500 days. Anyway, normal output for this is in days, whether you're using centuries or if you can use something like months, running Control Enter, comes out in days. So how can we use this in the query that we used in the last lesson to filter for orders within the last 5 years? I've simplified the query. Basically, we're pulling out the current date, order date from that sales table, and we use this formula of pulling the year out from order date and the year out from the current date and subtracting 5. Run this, we can see that the current date is Valentine's Day, and the order date is within that last 5 years. Now notice this, right? I called it out last time. This goes all the way back from January 1st, 2020. So technically this is slightly greater than 5 years. So let's write this query a lot more succinctly. I'm gonna go ahead and remove this portion right here. And for this, we wanna make sure that the order date that we're actually trying to filter for is greater than or equal to dates of 5 years ago. So we can use, once again, that current date, and we can subtract from it the interval of 5 years. Running this bad boy, we can see that this one now does the last 5 years as shown by the order date, and it's very specific, right? It gets all the way down to filtering it to February 14th, Valentine's Day in 2020. So getting into cleaning up that full query from last time, this is actually it right here. If we run it again, we can see that it does the current date, the order date, category name, and net revenue. So it breaks down by category the different net revenues. This one technically, remember, wasn't 5 years. So what we can do is go back and replace this portion right here with that newly formatted clause that we came up with. And then whenever we go ahead and run it, we can see that now we have it for the last 5 years. All right, before we get into age and also a review of that extract function, let's look at what we're actually trying to solve in this portion of the lesson. If you recall back, we have 2 columns, an order date and delivery date column. I forgot to put up a comma here, so it's not appearing. Anyway, now it is. So we have things like order date and delivery date. What we can do with this type of information is calculate how long, what is like an average processing time for a customer to receive an order. It's a very important metric whenever used in business analytics. So what we're gonna do by the end of this is show on a yearly basis, not only the net revenue, which is those blue bars, but also what is the average processing time for those years. And we find that it's going up. So what are we gonna be using for this? Well, we're gonna be using the age function. And with this, we provide 2, in this case, it's timestamps, we can provide dates, and it'll output an interval. Let's do a simple example first, running it just right inside of a select statement. We're gonna be using the age function, and then we're gonna provide it 2 dates. Now I have a couple of errors with this. I'll go ahead and run this first, pressing Control Enter. And we have this can't render age, and it says, hey, no function matches the given name and argument. Specifically, it says age, integer. I don't want to evaluate an integer, I want to evaluate as a date. The problem is with the date, we have to provide it as a string. So make sure you have single quotes around it. Running Control Enter, we have it. Now, if you notice from this, I did the 8th of January to the 14th of January, and it's saying it's -6 days. For the age function to get a positive value, you need to provide the end date, and then you need to provide the start date. So I'm gonna go ahead and place these in the correct order. Running this, get 6 days. Now let's say we wanna do some math with this. I have currently 6 days, and let's say we wanted to subtract, 5 days from this. If I put in here after this -5 and try to run this, I'm gonna get an error. Specifically, it's gonna have that the operator does not exist, interval minus integer. Right now, this is an interval, and we're trying to subtract an integer. We need to convert this portion to an interval. Integer. Need more coffee. Well, we can use the extract function. I'm gonna go ahead and remove this all, cutting it out. We're gonna use the extract, and we need the part, and then specify the from keyword, and then the date expression. For this, we're gonna specify day. It doesn't need to be in single quotes for this. It understands that keyword of day. I'm specify from, and then for the date expression, I'm gonna go ahead and paste in that age. Now running this, pressing Control Enter, we can see that we get that 6 from this, and I can do the -5 from this now, pressing Control Enter, we get 1. So let's get into calculating the average processing time by year, and we're gonna be doing this for the last 5 years, similar to this table. We'll also need to calculate the net revenue, but we're not gonna do that until the very end because it's gonna make our query a lot longer with actually joining in the table that has the revenue data. So let's start simple first, and let's just look at the order date and delivery date. And we're gonna be getting this from the sales table. Now let's put a new column in for the processing time. We'll throw in that age function. And remember, we need to put the end date first. So that would be the delivery date, followed by the start time or the order date. And we'll name this as processing time. This query is getting quite long, so I'm going to go ahead and throw in a limit of 10 in here just to start with. All right, running this, we can see we're getting basically 0 processing time. Everything's getting delivered on the same day that it's ordered. I want to see a little bit more different order, so I'm going to throw in an order by random and run this. And now we can get some actually that have some days in there to show that, okay, this is actually working. So let's start getting the average processing time and aggregating it based on year. Because of this, we need the year. For this, I'm going to use the date part function. And at the first argument, we need to specify what is we actually want. We want year, and we want that out of. We're going to go with the order date of when it actually started. We'll give this the alias of order year. Now, next thing we'll do is actually get into aggregating this age. But remember, we have this processing time is an interval of the data type interval. So 3 days, 0 days. It's not going to be able to actually average that. So we need to use that extract function first. And I need to specify the part from this. Specifically, it's the days, and specify that from keyword, and then age, delivery date, and order date. I'll then put a closing parentheses on this and then rename this alias to average processing time. Now we're doing an aggregation. So one, we're going to need to specify a group by, and then because of this, we don't need to have that order date and delivery date, because we'll have to aggregate by that. And so I'll remove this order by random, and we'll throw in a group by right here, specifying order year. Also, this won't have a lot of outputs. So I'm going to remove that limit statement, then running this. And silly me, I'm reading this here. The delivery date must appear in a group by clause or be used in an aggregate function. Basically, I forgot to use the actual function right here. Whoopsies. Throwing that in of average, and now running this, we are getting the average processing times. All right, we need to clean this up still. These years are out of order, and these amount of digits on here are just unreadable. So I'm going to throw in an order by clause underneath here, and we're going to order by the order year. Running this, we now have it in order. And now let's clean up this average processing time. I only really want 2 digits. And if you remember from the basics course, we went over the round function in there. And with the round function, you provide the value or column X. And then after that, N is the number of actual digits that you want, or decimal places after this. So if you don't use anything, it's 0 digits, but we want 2. So we'll go ahead and put 2 on there, run Control Enter. Bam, got average processing time over, well, we want to do the last 5 years. So from our previous example up above, I don't like typing code if I don't have to. I'm gonna go ahead and copy that where clause and then putting it underneath the from statement. Now running this, we have for the last years, the average processing time. All right, now just one last thing to do. We need to now add in that revenue based on each of those years. For this, we're gonna be using the sum function to sum it all up. And we're gonna be multiplying quantity times net price times exchange rate. And we'll give it the alias of net revenue. All right, let's go ahead and run this. Not too bad. Typically with these high of numbers, I don't care about these 2 decimal places. So I'm gonna use the round function again. And in this case, I'm not gonna specify an argument at all. Run this, and okay, it looks like it's given it 2 decimal places with just 0, 0. I wonder if I can just specify this. And looks like I can't specify 0. But instead what I can do is I could give it something like cast. And then for cast, I can specify that I want to cast it as an integer. Running Control Enter. Bam, now we have what I want. And then if we graph this, we can see that the average processing time over time has going up from around a little less than 1 up to 1.6. Even with the dip in revenue, or I think the number of orders, probably loosely correlated, we still saw the average processing time go up. So this is a good little data point to keep track of, and we can pass on. All right, it's your turn to go through. You have some practice problems to get more familiar with the extract, age, and also interval keywords and functions. And from there, we're going to be going into the next chapter after that on window functions. Pretty complex topics. I'm looking forward to get into it. See you there. All right, welcome to this chapter on window functions. This is probably the most requested topic for me to cover in this intermediate course. So I was super excited to get into this. Now we're going to break this chapter up into 5 lessons, starting with this lesson, focusing on the syntax of window functions, doing some simple examples and explain it to you. Then we'll start picking up the pace, looking at things like aggregation, ranking, lag lead, and then finally we'll close it off looking into how we can use things like frame clauses. But all of this doesn't matter unless you really understand what window functions are. So let's look at a simple example. So let's look at a query that's breaking down the net revenue by an order number. In it, I'm listing things like the customer key, and then the order key, and then the associated line number for that order, calculating the net revenue, and then getting it from sales. We're then ordering it by the customer key. So what's going on here? Okay, customer key 15 made only one purchase of over $2,000, but customer 180 did 3 separate purchases where 2 of these purchases were the same order, they just have different line items. So now let's say, based on all these individual orders, we wanted to find out, because we're going to do some deeper analysis, what is just the average order? Specifically, what is the average net revenue for an order? What I could do is run an aggregation function, removing all those other different columns, and just run it here and see that the average order value is 1,000. But I want it in this table, and I can't get that necessarily unless I actually get it in this type of format using this aggregation. But this is where window functions come in. Instead, all I have to do is just insert in our window function. Don't worry, we'll go about it over in a second. It's using the over function in this case. Go ahead and run it. And I have an error because I got a comma in here. And we can see that it's the same value as below of 1032, but it's now in our original table just like we want it. So we can do even more calculations with it. So why use window functions? They let you perform calculations across a set of tables related to the current row, like we just showed. And like we showed, they don't group the results into a single output row. This is very beneficial as we're going to demonstrate in some future exercises. So this is using it for things like running totals, ranks, or even averages. Anyway, let's get into the syntax. For this, we start by defining the window function, or what we want to do. If it's an aggregation, something like sum or count. If it's ranking, it's something like rank or dense rank. The next is over, and this defines the window for the function. Inside of it, we have the keyword of partition by. We'll get that in a second. Let's actually go back. So let's walk through that window function that we just saw without using partition by. And then I'm going to create a new line. And for this, the window function we're going to use for this is average, because we're calculating what is the average net revenue. From there, I'll put our variables in there of quantity, net price, and exchange rate. Then we'll put over, and it's very important after this that we include opening and closing parentheses, even if we're not going to put anything in there. And then I'm going to give it a very verbose title to make sure we understand what it means. The average net revenue of all orders. Going ahead and running this. We can saw similar to before, it's at 1,032. But now let's say we wanted to filter this type of window function further, maybe by something like the customer key. And this is where partition by comes into effect. It divides the results into partitions, or better said, divides it into separate groups without actually having to use such as a group by clause to do this. So going back to our previous example, I'm gonna go ahead and copy this all so that we can see it, add a comma, new line, and paste it in. And in this one, we're gonna define partition by customer key. And we'll say that this is the average net revenue of this customer. Let's go ahead and run it. And scrolling down, we can see for customer 15, it only had one order, so that's the average net revenue. Whereas customer 180 had multiple, and the average of that was 836. So let's just briefly explore the power of window functions. By looking at a simple example, I'm not gonna ask you to follow or understand the syntax because we're gonna get to it later on, but this is gonna demonstrate the features that we're gonna be getting to in this chapter. So here we are looking at things like the customer key, order date, and net revenue. I'm gonna go ahead and run this. So let's say for each of these customers, we wanted to rank their orders from highest to lowest based on net revenue. Well, I could use something like this window function that's using row number and some other stuff that we're gonna get to. And in this case, we can see that it actually calculates the rank for this. Specifically, it has the highest at rank number 1 and the lowest at 3 for 180. Now, let's take it to another level. We could do something like calculate the customer's running total. So in this one, we can see with 180 that has multiple orders, first it's at 525, and then it jumps up to 2,500. These orders are on the same day, so the running total is the same. We could also do things like get the customer total net revenue. And this one isn't really that impressive because, yeah, we can see that it gets the total. But personally, I like it because I can then use this to maybe calculate, hey, what percent is this order of the total net revenue of a customer? In that case, I can just add it in, doing the net revenue divided by the window function to figure this out. And so now, I condensed on the table, by the way. Now I can see what is the percent of the revenue for a customer. So this makes it even more unique of why window functions are so powerful. So let's actually get into applying those concepts. So where you can actually write those queries like I just ran through. What we're going to be finding is the percent daily revenue based on an order line item. To do this, we already know how to do net revenue. We'll need a window function to calculate daily net revenue, and then we'll calculate a percentage from that. So let's start building this query out. We'll list the order date, the order key, the line number, which an order or an order key could have multiple different shipments with it, so therefore it has different line numbers. And then finally, we'll just start with the net revenue. We'll get this from the sales table, and we're just going to limit it to the first 10. All right, so, and as mentioned, the line number, right, it just says 0, 1, 2, 3. The highest number in this is 6. I don't really like that these are two separate columns, so I'm actually going to combine it. I'm going to take the order key and multiply it times 10. So basically it adds a 0 to the end, and then from there, add in that line number. And then I'll give it the alias of order line number. We can see that what it looks like actually here, it accomplishes what we want. So I can go ahead and remove line order and order key. So the first thing we want to calculate in our final table is that daily net revenue. In order to do that, we need to use the sum function on our net revenue. And now we want to use over, and then inside of over, that partition by. Remember, we want the daily net revenue. So we're going to be putting the partition by of order date. And from there, we get that daily net revenue now. Now we want to calculate finally the percent that an order line item is of the daily net revenue. This one's going to be pretty simple as it's going to be a lot of different copy and paste. So first I'll drop in the net revenue. I'm going to multiply it times 100. So it gives us a bigger digit for that percentage. And then from there, we're going to divide by all of this window function right here, which I'm going to copy and paste into here. And we'll give it the alias percent daily revenue. Not too bad. It's all over the place. I want to actually see this ordered for this day to see what is the highest. So I'm going to put in an order by, specifying the order date, and then the percent daily revenue. But for this one, I want it in descending order. And bam, we get this final table showing this percent daily revenue based on the order. I went ahead and graphed it so we could compare the different order line items for that day. And we could see that some of the orders, I mean, these are taking up of 20% up to 10% of the entire daily net revenue. And conveniently up the top of the chart, but the total daily net revenue. So it's pretty convenient for window functions that we can get all this type of data into a single table, and it makes it a lot easier later on whenever we dive deeper into it and maybe visualize it. One minor note on this query, it is getting a little bit verbose in that a lot of this is repeating stuff that we could reuse. And that could be done using something like a CT or subquery. What I could do is actually just put it into its own subquery of the core items that we need from this. So the order date, order line item, net revenue, and daily net revenue. And then from there, put it into something like a subquery. So I'm gonna go ahead and tab this over. And so that way we can do a select star from, and then put this all within parentheses. And we'll give this the alias of revenue by day. So it still has the same output in below, but now instead of having to repeat all that different code here like I did to calculate the percentage, I just come up here and then insert a new row, specifying I want to do 100 times the net revenue divided by the daily net revenue, and give it the alias of percent daily revenue. Now running this, boom, this has everything that we have or want out of it. And in my mind, it's slightly easier to read and to get through when sharing it with others. So let's now get into performing a cohort analysis in this last example. And cohort analysis is going to be done a lot throughout this project because it's pretty popular in business analytics. Anyway, what the heck is this? Well, a cohort is a group of people or items sharing a common characteristic. And then the analysis of this examines the behaviors of this over time, specifically the behaviors of that group being a person or item. So what does this even look like? Well, for this example right here, this is what we're going to be doing in analyzing or putting people into cohorts based on the year of their first purchase. And then from there, calculating what portion of the revenue they are contributing to the net revenue. So down at the bottom is the purchase year, and then over on the y-axis is the net revenue. In 2015, where this is the data that starts, it starts in 2015, everybody contributing this is from cohort 2015. So that's all the net revenue. Then we get into 2016. We have their 2016 cohort, along with it's a small contribution from the 2015 cohort in 2016. We work our way all the way to 2019, and we can see once again that the cohort of that year is the largest contributor, whereas those from previous years are less of contributors. Now, it's important that you understand for this example that the cohort is based on the first year that you made a purchase. So what are we aiming to get out of this? Well, we want to have this final table where we have the cohort year, or the year of their first purchase, and then from there, the purchase year, or the apparent year of the net revenue, with the total revenue for that cohort. So we're going to start simple first with our first query, looking at using a window function to extract out the cohort year based on a customer. So we'll start with a select statement, specifying the customer key. We'll also do order date so we can see what's going on there. And we'll get this from the sales table. We're going to limit this to only 10 values. Also have a comma right here. We don't want that. Go and press Control Enter. And bam. Okay, so we're getting customer keys and order dates. I'm also going to go ahead and, just for good measure, I'm going to order by the customer key. So that way we can make sure that we're looking at this all appropriately. Specifically, if there's groupings, such as here's 180, I see them all together. So now let's use a window function to get our cohort year. We're going to start first by just getting what is the minimum date out of, or for a customer. So in the case of this 180, I would expect it to be this order in July. So we'll start this window function using the minimum of, specifically, order date. And we're going over, and then inside of parentheses, we want to put the partition by of the customer key. And I know it's a date right now, but we're going to just name this the alias cohort year because we know we're going to change it. Okay, press Control Enter. Okay, looking at 180, it is in fact that lowest date for order date as the cohort year. Now what we want to do is extract out that year from there. So I'm going to run that extract function on this, and we need to specify the part first. So that's going to be year and then from, and then everything after this is that date expression. So then I'll put a closing parentheses all the way in the end, run this. One thing real quick, I did show that how it was 2018, but now look at this. If we go to something like customer key 387, we can see that their first purchase was in 2018, but then later on in 2023, they still have that cohort year of 2018. So we know our formula is working. So let's go ahead and clean this query up because I don't need this order date at all for what we're doing it for. So I'm gonna run Control Enter. Now I'm noticing we have duplicates because customer key is appearing more than once. So what I can do is add a distinct statement right after this. And now when I do this, boom, I'm only getting distinct values for the customer keys and the cohort year. So this table is a lot more concise. We also don't need this limit 10 anymore. And technically we don't need an order by either. This is good start. So we figured out that cohort year for the customer. This is once again the final table we want to get to. Now what we need to do in order to basically add these additional two columns on of the purchase year and the net revenue is we need to calculate this, if you will, separately and join in that cohort year using something like a CTE. So let's put this all into a CTE that we can then join to that sales table to basically attach on for all these different customer keys, their associated cohort year. And then we can aggregate and find out what is that total revenue. So we use the with keyword, specifying this as the alias as yearly cohort. We'll use as and then an open parentheses. We'll tab this on over and then put a closing parentheses. And then I just want to make sure that this works properly. So I'm going to do a select star and do from that yearly cohort above and run this to make sure that it is outputting correctly. Yep, still the same table. Okay, now let's join this on to our sales table. For this, it's very important to get the correct join for this. Specifically, we're going to be connecting to the sales table, so I'll put that right here. And then for a join, we're going to be doing a left join. We're doing a left join because we want to make sure that we have and keep all of the different sales values from it. And then we're joining using yearly cohort, which has been distilled down to remove any duplicate data, so we're not creating duplicate rows. For each of these, I'm going to give them an alias, this one S and this one Y. And then as far as how we're going to join this, you'll be on the customer key from both of these tables. Let's go ahead and, well, let's actually do a limit 10 because there's a lot of data. All right, so just inspecting the table, we can see we have the customer key of 947009, and then it is joined on that customer key along with its associated cohort year. So just a reminder of what we need to get to now, we need to get the cohort year and then the purchase year or the year of the order date and aggregate all this to calculate what is the net revenue now. When we do this aggregation, we're not going to use a window function this time. We're going to use a group by on these different years. So let's clean up these columns that we're actually using. We're going to use that cohort year and then also the purchase year, which is based on order date. So we need to extract out the year from order date. And we'll define this as the purchase year. Let's just make sure this is correct before doing our aggregation next. Okay, good. We have all the order years and purchase years. Now we want to move into getting a sum of all the revenues. So we'll use the sum function, specifying the quantity times the net price times the exchange rate. And we'll give this the alias of net revenue. And so because of this, I'm going to be doing a group by specifically on that cohort year and also the purchase year, which we'll need to put the function in here. Going ahead and running this, we can see we have our results. And anytime you're finding or getting to your final results, you need to make sure that the numbers are making sense. Specifically, I know that the net revenue for 2015 was around $7 million. And I can see from this that for 2015, did I say 2017? In 2015. So for 2015 is around 7 million. And this checks out. Also, silly me, I could also use purchase year. In this case, doesn't necessarily have to be the function itself. All right, so we want all the values for this because we're almost there. I'm gonna go ahead and remove that limit 10, go ahead and run this. And bam, we have our final values where it shows based on a purchase year, how much a certain cohort contributed to the revenue for that year. And this is the ultimate visualization that we get to, and we can see that pretty interesting enough, the cohorts from previous years don't really contribute that much to the overall net revenue. So we have a little bit of a retention issue. All right, it's your turn now to go in and get more familiar with window functions by doing practice problems. In the next lesson, we'll be diving deeper into aggregate functions and basically fine-tuning our knowledge of how to use window functions. With that, see you there. Welcome to this lesson on aggregation functions using window functions. Anyway, last lesson we went through and started to apply aggregation techniques to window functions, but we're going to build slightly more further on this, covering 3 key concepts. So in the last lesson, we actually used the min aggregation function to analyze the impact on yearly cohorts on the total revenue as we went through the years. Well, in this one, we're going to do a simple analysis, basically reinforcing what we learned with cohorts, but this time using the count function in order to analyze the total number of unique customers and how they impact based on the cohort into future years. Next, we're going to move into using the average aggregation function. And for this, we're going to be focusing on the long-term value of a customer. Basically using window functions in order to calculate what is the total amount of revenue that a customer has contributed. And we'll not only be able to break it down on a customer by customer basis, but we'll also be able to analyze it from a cohort year perspective as well. And finally, we're going to wrap it up with some simple examples on understanding how to filter window functions, basically where you should be applying your where clause in order to filter a window function properly. All right, let's get into it. So for this example, we're going to be using count in order to aggregate our window function. The syntax is all the same, so major concepts remain all the same. Let's get into what we're going to be solving. For this, we're trying to find out the number of unique customers, which we're going to use the customer key for this, and find out based on their cohort or the first year that they bought an order, how they contribute to future years. This graph right now is showing the total number of unique customers every single year. And then from there, broken down by cohort. So we can see from 2019, we had those from 2015, 16, 17, so on. For the final output, we're going to be doing it very similar to last time, where we want a table of the cohort year and then the purchase year, and then the number of customers or the number of unique customers based on a cohort year and purchase year. Now you could start with the query from last lesson and modify it to fit your need for this, but I find this question is actually more simple than the last one, so we're going to start from scratch. Also, it's just good practice. So for this, we want to get not only the customer key, but also based on a customer, we want to get its cohort year or the first year it made an order, and then also a purchase year or when the year of a purchase was. We're going to be ultimately using that customer key to get the unique count. Anyway, let's start programming. Start with a select statement, adding in our customer key. Next, we want the cohort year. So similar to the last time, we first want to get that minimum order date for our window function. And then from there, we want to do it over the partition by customer key. I'm going to name this alias right now cohort year because we'll eventually get it into a year format. Right now, it's obviously just date. For this, we're going to be getting this from our sales table. Let's go ahead and run this just to see. Scrolling down to that 180 customer key, we can see that it is all from June. So this is looking good. Next thing we want to do is extract the year out of this. So we'll do an extract. We need the part, which is year, and then from, and then the date expression, which we're going to wrap all in parentheses. And then we'll put another clothing parentheses on there for the extract. Run Control Enter, and we have the years now. Next, let's get the purchase year. And we don't need to do a Windows function for this, right? We just need to extract the year from our order date. So I'll do an extract, the part is year, and then we'll do a from, and then the date expression is order date. We'll give this a name, purchase year, and go ahead and run it. Okay, overall looking good. Everything looks like it's calculating correctly. Now what we need to do is move into actually getting the count of the unique customers using that customer key. And you may falsely think that, this is actually wrong code right here, but you may falsely think that you could use a group by to do this. Specifically, we'd want to do something like count the different customer keys, or I should say count the distinct customer keys. And then from there, add a group by to do by cohort year and purchase year. However, when we ever go to run this, we get the following error message. Window functions are not allowed in a group by. Basically, we can't combine these window functions and group bys. So trying to use group by in order to calculate this and save some code, not going to work here. Just wanted to point that out. But what we can do is make this into a CTE and then use that CTE to run a window function on to get the customer key. So for this, to create our CTE, I'll give it the alias of yearly cohort, open parentheses, and put all of the syntax in there. Next, just to make sure that everything is working correctly, I'm just going to call a simple select star on from yearly cohort, run this, and it's still running properly. Okay, we're good to go. Let's refine this now. And remember, this is the final output that we want. We want cohort year, purchase year, and then number of customers. So let's work to build this table. For this, I'll remove the store, put in cohort year first, put in the purchase year, and then next, let's build the window function to go through and count the unique customer keys, but we don't want it just on one thing. We want it based on both the cohort year and the purchase year. So in this case, customer key 180 was a unique customer in 2018, which is also the cohort year. But then as a cohort year 2018 was a unique customer in also 2023. So for this, we'll first start by doing a count. And one thing I'm noting with this, right? This has some duplicate data. Remember, we want to get unique customers. So technically, I'd only want to see for 180, this 2018, but then also for this 180, this 2018 for the cohort year and 2023. I wouldn't want to see duplicates. So what I can do first is I can add a distinct up here onto this query, running Control Enter. And then it's not really showing because we removed the customer key. I'll just put it in for the time being. Running this again, we can now see that for customer key 180, now it's just those 2 entries. So for this, we're going to be doing a count of customer key, or you can do count star over, and then this is when we would get into our window function using partition by, both the purchase year and then also the cohort year. And we'll name this as num customers. So let's go ahead and run this. All right, not too bad. The one thing to note, right, is this has multiple different duplicate lines because we have all those customer keys in there. So once again, what we can do is we can just add a distinct right after the select statement. So that way we can get it filtered down to only unique values. And then from that, we can see that, okay, this is all unordered now. So now we need to actually do an order by. So we'll add an order by, doing by cohort year, and then purchase year. And scrolling down, we have what we want now. And I know based on previous calculations that we had in 2015, only 2,825 unique customers. So this validates or help understand that this data should be correct. So if we were to visualize it, this is what we get. And it comes out very similar to our total net revenue. So overall, not a lot of unique insights that I found from doing this compared to net revenue, but at least we explored it. Before moving on, I want to touch on a short example specifically around what we talked about just recently on this error message that we got when we ran this query where it said window functions are not allowed in group bys. Technically, this isn't entirely correct. As I'm going to show in a second, we'll be able to run window functions with group bys. But overall, I don't recommend using window functions and group bys within the same query, and we won't be doing it for the remainder of the course. So I want you to learn this major concept now. So let's look at this simple example. We're going through and we're going to collect the customer key, and then using a window function, we want to count how many orders that a customer has. And so we're going to partition it by the customer key, and this will be the total orders. I'll go ahead and just run this. And so we can see that customer key 15 has 1, 180 has 3 orders, so they have a total of 3 orders. Everything's working fine. But now let's say we want to calculate the net revenue, but this time we want to group this all up because I'm tired of all these separate rows. And so we're going to use a group by with this to find the net revenue. So I'll put in the average, and this will be of the quantity times net price times exchange rate, and I'll give it that alias of net revenue. We're doing an aggregation, so like usual, got to use a group by. And we'll do this of the customer key. Now, whenever we go to run this query, it is going to work. Notice, remember, 180 is that total of 3 orders. And I'm getting an error message because I'm silly and I didn't put a comma after this column. Go ahead and run this now. And magically, this query does work now, right? Because we have a group by with a Windows function in it. But now going to that customer 180, they only have a total of 1 order. So in fact, if you look at all of them, and I can move into this bigger table, all of the total orders for every single one of this column here is 1. So what's going on here? Well, what's happening is window functions in the process of running through this run after a group by. So what's happening is everything's getting grouped together and then the window function is running. This causes a major issue of conflicting aggregations. So if you're not getting an error message stopping you from this, you're probably not going to get the right results. There are better alternatives, which we're going to go over, and mainly that's using CTEs or subqueries and breaking up your queries to separate them. With our previous query, what happened was we ran our group by aggregation to find our net revenue, condensed all those customer keys down to 1 value. And then secondly, it finally ran that Windows function. So that's why it feels there's a 1 value for all these total orders because it only sees 1 after the group by. So let's fix this up so this actually works and see how we're going to be doing this. In this case, I would want to run the CTE first. So I'm going to get rid of this aggregation of this average. And we'll give this the alias of order value. Also, I'm going to be removing this group by because we're not doing that aggregation anymore. We'll then put this all into a CTE. So there's no aggregation inside of this one. We'll then just query this table, getting the customer key and total orders to make sure that it's aggregating properly. I'm going to go ahead and press Control Enter. And with this one, we can see that 180 has in fact 3. And now we can go through and actually do our aggregation with that CTE. Specifically, we would get the average order value and give the alias of net revenue, and then perform a group by on customer key and total orders. Going ahead and run this bad boy. We can see we have 180 with 3 orders and the correct value there. So it's working. So for the remainder of the course, you're going to see me anytime I need to do a new group by or a new window functions, I'm going to just create a new CTE and then do it there. All right, getting into that second exercise, we're going to be focusing on the average function and using this in our window functions. Overall, the syntax is the same, so nothing changes there, but we're going to introduce a new business concept. Specifically, this one of customer lifetime value. And as the name implies, it's the total revenue generated by a customer over their lifetime with that company. We're also going to explore some other concepts such as the average order value or the typical amount spent per transaction, but that's less of a focus for this, more of LTV. So for this, the main concept of concern is lifetime value, which we have the abbreviation of LTV. And it is the total revenue generated by a customer for a business over their entire relationship with that company. So what are we going to be ultimately calculating for this? Well, we want to find out based on a customer. So in this case, the x-axis is that customer ID. We can see what their total lifetime value is and even compare it, as with this dashed line, to the average lifetime value for that particular cohort. That calculation is a little bit more tricky to get to, but we're going to get to it. So the final table we're aiming to get to is this. Based on a particular customer key, we want to be able to extract out not only the cohort year, but also the customer lifetime value and what is the average lifetime value of that cohort so we can compare that to. Now, this type of analysis is really great because we could do something like target these high value LTV customers because they're more likely to make purchases. And that's typically what businesses do. They're not going after the lower numbers, they're going after the higher numbers. Enough yapping, let's actually get into it. And for this first query, we're just going to focus on 3 things. The first is getting that customer key. The next is we want that cohort year, which, as we've seen before, is extracting out using the year. Now, there is an aggregation function in this of the minimum order date. So we are going to need to do a group by after this. But anyway, next thing we want to get into is a sum of their total purchases. So I'll run a sum function, put in the quantity times net price times exchange rate, and then give this the alias of customer LTV. Specifically, we're summing up all of the revenue for that customer. So it is that. We're going to take this all from the sales table. And like I said, we need to do a group by, specifically by the customer key. Let's go ahead and run this. All right, not too bad. We have basically the first 3 columns of the 4 that we need for this. And speaking of that 4th column, that's what we want to get of the average customer lifetime value for a particular cohort. But remember, we learned previously, can't be inserting window functions in a group by. So I need to put this all into a CTE and then do the window function. We'll start with that with keyword, giving the alias of yearly cohort, and then signing it this as alias, obviously, putting it all within parentheses. Like usual, I want to double check my work, so I'm going to just do a select star from that yearly cohort, and everything's outputting like we saw it previously. Good to go so far. Inside of our main query, we want to have all the different columns, so I'm going to do a select star. It's only 3. Feel fine doing this. But next is where we actually want to do that window function using average. And for this, we're going to use that value of customer LTV over, in parentheses, going to do a partition by, and we want to do this by cohort year. We'll assign this the alias of average cohort LTV. Okay, let's go ahead and run this. Not too bad. One thing is I probably want this ordered in a particular order, specifically on the customer key and the cohort year. So I'm going to stick an order by in there and specify cohort year and customer year. And bam, this is the final table that we need for this. And this can tell us some different statistics that we can now use. Like I said, we could send this off to maybe something like the sales department or marketing department, and they could do targeted ads at these high value customers in order to have a potential or more of an impact on revenue. Now, I also graphed the average lifetime value for each of the cohorts. And as expected, it does decrease over time. That's expected because they have less time in the cycle than, say, somebody that 2016 or 2017. I guess the one thing to note is 2015 and 16 are less than 17. So the first few years we started off, we didn't do as well with customer retention and extracting value out of it. So pretty neat insight out of this. All right, last part in this lesson, and we're going to focus on two examples, very quick, in how to use where within a query to filter properly. And this is really important, especially for the practice problems we have for this, in order to understand that you're filtering properly. So let's start easy first. How can we filter before a window function? Well, we could use this where statement here, and it is going to apply before we actually invoked the window function itself. Let's actually test this with a simple example. So for this, I'm querying to get the customer key, and we've seen this window function before of extracting the minimum year to get that cohort year based on that customer year. We'll go ahead and run this. And there's trustee number 180. We see that it is in cohort year 2018. So we know the problem or the query worked out properly. So let's say we have a scenario where we only want to look at cohorts from 2020 onward. Basically, we don't want to put people in cohorts before 2020. We want to just analyze from 2020 onward. This is a great example of filtering before a Windows function. In this case, we can use the where, and we're going to specify that the order date is greater than or equal to January 1st, 2020. Now, let's see what happens with customer key 180. Okay, previously, it was bucketed into as its first order in 2018. But now, since we're saying, hey, don't pay attention to that anymore, I just want to focus from this point onward, it's getting reclassified as 2023. So that's how you filter before window functions. The where clause can be right there in the statement underneath the select, and it's going to get applied before the window function runs. Now contrast that with filtering after a window function. In this case, we need to do something like a CTE or subquery. We're going to do a CTE here. We would need to get that CTE and then from there, filter. So let's continue on with this last example to show when we might want to use this. So the first thing I'm going to do is I'm going to remove this where because we're not going to do anything with it. We're going to put this portion into a CTE. We'll give it the alias of cohort, and then I'll do an opening and closing parentheses to put it all within. Then we'll do a select star, and we'll do this from cohort. So now let's insert our where. And in this case, right, we want to filter after the Windows functions. So specifically, we want to, remember previously customer 180 was in that 2018 time as its cohort year. Let's say we just didn't even want to look at any of the cohorts if they were bucketed into that cohort. We don't want to even classify them at all after 2020. So for this, we want to specify where it's greater than or equal to, and the year in this case would be 2020. Now, what I would expect from this is that customer key, once again, is going to disappear. Also, this from is messed up right here. It's not, it's from cohort. Okay, let's go ahead and run this. And bam, we notice now that 180 is removed from this because of how we actually applied this after the window function to remove those cohort years from the original purchases. Anyway, wrapping your mind around how where functions are applied before or after window functions does require some practice. So we got some practice problems for you. Go through and test it out and get more familiar with it. All right, in the next lesson, we're going to be jumping into functions around ranking. And that one is pretty exciting, so we'll see you in there. All right, we're continuing on in this chapter of window functions, now focusing on how we can rank different values and use a certain order to rank them. For this, we're going to be covering three main types of ranking functions: row number, rank, and also dense rank. I'll be explaining the difference between all these. And we'll be doing this by ranking customers based on how many orders they've completed. So more orders they completed, higher the rank they are. But before we even get into any of those functions, we need to first understand how to use order by within a window function in order to get the correct ranking that we want. Now, previously with SQL, you've seen order by used typically after the from statement to actually order your values, but we can use it inside of the window function. And what this can do is order our values within a specific partition that we're running this window function on. And order by, as a reminder, always defaults to ascending, but you can specify descending. So what are we going to do in? Well, with the sales table, you've already seen the customer key, order dates, and net revenue. What we can do is get a running order count. And what this will do is based on an order, so in this case for 180, it has its first order in July. So we have our first order. And then in August, on the same day, we have 2 more orders. So then it bumps up to 3. Similarly for customer 387, they have 4 orders on their first day. And then the next day or the next time they complete an order, they bump it up to 5. So let's build something similar. I'm going to throw in a select statement along with customer key, order date, and then net revenue. We've seen this all before. This is going to be from our sales table. I'm going to go ahead and run this just to see what it's outputting. Okay, sweet, not bad. Let's now just get with this a count of the orders based on using a window function based on that customer key. So I'm gonna insert a count function and we'll just do it on count star. We're gonna do this over and then I'm gonna do a set of open parentheses. I'm actually going to indent this down to make this easier to read. And for this, we're gonna partition by customer key. We'll do by order by in a second. I wanna go ahead and actually see this first. Now, we've seen this before, but I want to call out some things. Specifically, notice that the customer keys are different from before, so it actually went through and ordered it with that partition by. Except it didn't order it by, or didn't order the order date because this one for 180 in June or July is after the August. Anyway, that's something to note for later. But we do find we get the correct calculations for this because 180 has 3 orders and we can see all of them here. So now let's insert in our order by. I'll put it right after the partition by. And specifically, we're going to be doing it by that order date. And this can control our row processing order. Let's go ahead and run this bad boy. And so inspecting this table, we can see now that not only the customer key is in order, the order date's in order. And whenever we go through the count itself for 180, it has 1. And then the next time in August, there's 2 more. So now it increases by 3. So our function's working. So for these aggregate functions like count, average, or whatnot, it's going to determine how values are accumulated row by row. Also, I realized I never gave this an alias, so I'm going to call it running order count. Anyway, let's now use one more aggregate function to demonstrate this further. Specifically, I want to do a running average of the net revenue. So basically, after the first order, I expect to be around 525. And then after these next 2 orders, I'd expect it to be an average of all 3 of these. And it's going to do this line by line. For this, I'm going to insert a new line. I'm actually going to just go ahead and copy a lot of this because the boilerplate code itself is going to be approximately the same. Instead of doing a count, we want to do an average. And specifically, we want to do it on that net revenue. So I'm going to copy that and then paste it into here. We're still going to be partitioning by the customer key and ordering it by the order date in order to carry out that row by row execution. And we're going to name this running average revenue. Okay, let's go ahead and run this. And now inspecting it, we can see that, yeah, for the first one, they only have 1 order. Next one of 180, the first order, the average is in fact the same as it is. But then when we moved into the next round of orders, it's averaged among all 3 of these. So for 180, at this point in their order history, the average order revenue is around $836. With that knowledge, let's actually get into our ranking function. Specifically, first, we're going to be focusing on row number and understand the importance of how it needs to interact with order by. Now in Postgres, they have quite a few different ranking window functions. But in this lesson, we're going to be focusing on these top 3 right here: row number, rank, and dense rank. For row number, this returns the number of the current row within its partition, counting from 1. So for this, let's just label the rows in our sales table with a row number. For this, we're going to select all the rows of the database, and we're going to say this is from the sales table. Since we're doing all the rows, I'm going to just limit this to the top 10. Run Control Enter. Okay, this is our values back. Let's now get into using this to assign a row number at the front of here. One quick note for this data frame that's appearing here is this is the index right here, but it's not necessarily callable, the 0, 1, 2, 3, 4, 5. So we really can't use that. That's why we actually have to generate this. Anyway, after the star, we're going to start a new line because I want all the actual columns to, or yeah, all the different columns to appear. For this, we're going to specify the row number and then run over. And I'm just going to do an open and closing parentheses. We're not going to use a group by just yet. I'm going to go ahead and run this. And if we scroll all the way over, we now have the row number right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as expected. And it looks like our data set is in order. Now, I don't really like where this row number is appearing. I actually want it at the front of the data set. And I'm also going to give it an alias of row num. Anyway, let's move it to the front. So important thing to note is, yes, this does provide the row numbering, but this actually does this in a, well, chaotic order, and it's not guaranteed that it is going to be assigned based on how the data set is in the system. So I don't recommend doing this. I always recommend anytime you're using any of these numbering functions to use an order by. So what is this order going to be based on? Well, every order has a unique order key and also line number. Additionally, with this, I'm going to also use that order date to make sure that we're maintaining in that date order. I'm not 100% sure if the order key may mix around in certain locations in time. So for this, I'm going to press enter, and now I can enter in my order by, and I'm just indenting this in to make it easier to read. We're doing an order by. We'll specify that order date first, and we'll just run it as is just to show this. It's still providing those row number in sequential order by order date. But like I said, we want to be very specific to make sure that it's doing it correctly. So what I'm going to do is also add in that order key and then that line number. Run Control Enter, and bam. So this is what we need in regards to row number. Let's now take this a step farther, combining it with partition by. Specifically, let's say that we want to start or have a number for like our daily order number. And so every new day, we want to start this over. Let's look first, what is it at on the 2nd of January 2015? And I'm going to do this by inserting a where statement. And this is saying, hey, filter this for where order date is greater than this. This is only done just to look at that on the next day, running Control Enter. And silly me, I already forgot what we learned in that filter lesson, right? Whenever we're doing the where right here underneath the window function, it actually will apply this filter data to there. And so in this case, it automatically did start numbering again at 1. But generally, if I didn't have that where statement, I wouldn't do it. Anyway, not necessary for you to actually follow along and do this code. I'm just doing this for demonstration purposes. I put all of our original query inside of a CTE called row numbering. Then I called it to look at the first 10 values in it. Anyway, with this, same queries below. Now I want to filter for the second, basically where order date is greater than the first, running this one. We can see that row numbering starts, at 26, 27, or whatever. We want to do a new window function in order to assign a new numbering each day. So let's go back to that original query that we have, remove that CT so we can make it easier actually to run through all this. For this, we now want to add a partition by right above the order by. And for this, we want that new numbering to start every single day. So we're going to give that the order date as the variable for this. Okay, going to go ahead and run this. And actually, we're not going to see any difference in what's displayed here. But we do see down here that in 420, that the numbers only go up to like 97. So it does look like it's working. What I'm going to do is I'm going to now just go ahead and copy this all, paste that into that CTE so we can demonstrate this again, and then run this. Remember previously, it was starting the numbering around number 24 or something, but now on the second, it is starting it at the first. So this is working. So let's now get into comparing the 3 major types of functions we're using for this: row number, rank, and dense rank. Note all of them provide big int or an integer value from this. They all have a different way of ranking depending on what your use case is. So let's look at a simple example for this. So let's say we went through and calculated how many orders each customer did. And this one up here, they've had a total of 31 orders. Well, we're going to go through and rank them using row number and then rank and dense rank, and then seeing how they actually differentiate from each other. For this, let's first just pull in the information we need using a simple select statement. We're going to use customer key, and then to count all the orders, we're just going to do a count star to basically count the line as an order. And we'll assign this as total orders. We'll get this from the sales table, and we did an aggregation method. So we'll need to do a group by of the customer key. So let's go ahead and check this bad boy out. And with this, we can see the different customers and then the orders. The total orders are all over the place. They're actually we need to order this, but we're going to be ordering it in our window function. So I don't want to necessarily do that until after our window function. Also, this is just too many values. I'm just going to do a limit 10 for the time being. All right, let's get into now building our window function first with row number to assign a row number based on what are the total number of orders they have. So for this, I'll start a new line. We'll insert our row number function. We'll do it over, and then inside of here, we don't need to do a partition by because, well, we've already grouped by our customer key to find out what the totals are. So all we need to do now is just put an order by in here. Specifically, we want to order it by that count star. And we'll give this the alias of total orders row num. Real original, I know. All right, let's go ahead and run this. All right, bam. What we have here is, well, not really what we want. So these all have total orders of 1, and it is providing a total orders row number 1, 2, all the way to 10. But I actually want to be ranked from highest to lowest. So as remember from the beginning, we can actually insert in a descending comment right in that order by. Now when we run it, we can see that we get this total orders row number, and we're starting at the highest of 31 all the way down. Notice with this, when we get to numbers like 26, 26, and 26 repeating, it does assign a number of 4, 5, and 6, but technically these are all tied ranks. And so that's why we need to learn other functions like rank. So I'm going to go ahead and we're going to insert another line in here. I'm going to copy this row number because a lot of this is just boilerplate that we can repeat. Instead of row number, I'm going to change this to rank. And then for this alias, instead of row num at the end, I'm going to change this to rank. Running this now. Okay, we got the total orders rank. And if you notice from this one, whenever we get here and we have repeating values of 26, this is going to assign it 4, 4, 4. So if we actually see then when we get to 25, it assigns it the number 7. So then we'll skip 5 and 6. And now you're probably like, well, Luke, what happens if I don't want to skip 5 and 6 in my ranking method and I just want to continue on ordering from there? Well, that's where dense rank comes in. So let's once again, I'm going to go ahead and start a new line, paste in our old code, change this one to dense rank, and then also update the alias to dense rank. Running this one, I'll put a comma at the end of this. Don't need to have it. Gonna run again. We now have this new one where, okay, we get here, we have the repeating 4s. And then when we get to the next one, it jumps or it stays consistent in number and jumps to 5. And then we have some similar numbers again of 24. And so these are all 6s. So when I need to order something or number something, it really depends on what is my criteria on whether I'm going to use something like row number, rank, or dense rank. That's why I've got some practice problems now for you to go through, get more familiar with these functions. In the next lesson, we're going to be getting into lag and lead, which we've been doing functions that really look at only the current row it's on, but we can actually use functions that look either before or after certain rows. Pretty powerful. All right, with that, see you in there. All right, welcome to this 4th of 5 lessons on window functions. And in this one, we're going to be getting into functions like lag and lead. These type of things in a window function allow us, instead of looking at the current row, to allow us to look at things like the row above it or the row below it. So we're going to be exploring these main functions. And we're going to be doing this first with a very simple example where we can go in and look at our 2023 monthly revenue and be able to evaluate our month-over-month growth. Because now we can look either before or after row and be able to calculate this. From there, we're going to shift into our final scenario, which is slightly more complex in order to analyze the growth of cohorts over the years and basically see how they change from year to year. So what functions are we going to be exploring for this? Well, there's generally about 5 different ones that you can use. Let's start with the easy ones first. we have first value, last value, and nth value. For first value, it returns a value evaluated at the row that is the first window or first row of that window frame. The last one does, obviously the last one. And then for nth value, you can specify an integer inside of there and it will return that row. Now for lag and lead, they're very similar in that this one you're providing either a row that is lagging or a row that is leading. But we're already getting too deep into it. We need to actually explore this with an example. So what I want to do is first we need to calculate this. We need to get in 2023, what is the monthly net revenue? And then we're going to be applying these functions in a window function in order to evaluate first, last, lag, lead, and try all these different ones out. So let's start simple with just building this query. So I'll start with the select statement. And the first column we want is the monthly variables. So I'm going to use the toChar function for this. I really like the output of this. It's a lot easier. We're going to run this on the order date. And I want it in this format. We'll give it the alias month. Next is we want the net revenue. So we need to use the sum function for this. As always, it's quantity times net price times exchange rate. We'll give it the alias net revenue. We're getting this all from the sales table. And we're doing an aggregation, so we need to do a group by. Specifically, we want to do the group by month. Let's go ahead and run this bad boy. Okay, first thing I'm noticing is it's returning it back, but it's ordered all over the place. So I'm going to insert an order by. We'll also do this by month. And we want to analyze this for just 2023. So I'm going to insert in a where, and we'll just do an extract to extract out the year and analyze for 2023. So with extract, we'll specify the part, from, and then order date. And we want this equal to 2023. It's a digit, so we have to put that in a string. And bam, we have what we need now. Now we can actually start getting into running all these lag, lead, and stuff functions. Now, because we're going to be running window functions on this, I'm going to put this all into a CTE. We'll use the with statement. We'll give it the alias of monthly revenue. And then I'll provide some open and closing parentheses. And then I'll do a select star from this CTE and make sure it still outputs. Yep, still good to go. So let's get into exploring these. We're going to start with the easy ones first. Like I said, a first value, last value, and nth value. So for this, I'm going to specify first value, and we need to put something in here. Specifically, we need to put the value expression that we want out of this. And in our case, it is net revenue, which is right here inside of our CTE. The next is an over, and then inside of here, we don't need to do a partition by because everything's already grouped, but we do need to do an order by. Specifically, what do you want us to choose the first value from? In our case, we want the first value based on the months, not on the value of net revenue. So I'm going to put month in here. And we'll give it the name or alias first month revenue. Going ahead and running this, we can see that we do in fact get that first month into all these different columns. Let's now look at last value. I just changed the function name and then also the alias, running this one. Now this one, unfortunately, whenever you read it, you find out, oh heck, this is not the last month's revenue for each of these. And that's because the actual syntax inside of here of the last value of how we need to order by needs to change. Specifically, I'm going to delete it and put this in here. And we need special conditions to use rows between unbound preceding and unbound following. When we look at it, we can see that it is actually the last month net revenue. Anyway, just wanted to demonstrate that because it takes a little bit more to fine tune this one. We haven't covered unbound preceding or unbound following. We're going to be covering that in the next lesson. So stay tuned for that one. All right, next up is nth value. I'm going to go ahead and copy this first value and then insert it down here underneath and then change the formula name of nth value. Also for this, we need to specify the integer expression for what number of rows after this to do. So right now we'll just do 3 rows down and we'll call this third month revenue. Okay, running this bad boy, we can see that we get the third month's revenue. Now we do have this non-value in here. Once again, if you want to fix this, which we're going to cover in the next lesson, we can insert this statement right here, right after this, running this. We now have the third month filled in for all this. Don't worry, those all make sense tomorrow. We'll cover all those, but at least you got the basics now. All right, let's wrap up the simple example with lag and lead. So for lag, we're going to be looking, it's going to be a lag, so it will be the previous month we're going to look for. This returns values evaluated at the row that is offset rows before the current row within the partition. If we want to, it's optional because it's here in square brackets, but we could put an offset integer, similar to what we did for the nth value, in order to offset that. We're not going to do an integer for these examples. We just want the previous, and then use previous to find the next months. So going back to our query, I removed some of the other ones because it's getting too much in there. We're going to specify this as lag with the parameter of net revenue. We're going to still order by month, and this will be the previous month revenue. Let's go ahead and run this. And inside of here, we can see, yep, this is in fact the previous month's revenue. This does take a parameter, like I said. You can do that offset. So if I wanted to do 2 in this case, run Control Enter. It's now offset by 2 values before it goes down. We're not using that for our case. We're just going to go, trying to calculate eventually month over month. So we're going to leave it at 1 and run this. Okay, let's now use lead. I'll specify the formula first. And instead of previous month, it is going to be next month. Go ahead and run this. And we can see that it is actually the next month's revenue for all of these. So you're probably like, Luke, what the heck does this even matter? Yeah, you can find this out, but how does this even help me as an analyst? Well, let's say that I wanted to find my month over month growth, which is pretty common in the finance industry for evaluating your performance. So here I have a chart that's showing basically our bar chart of the different revenue each month. And then the line chart is showing what's happening, what's the rate of revenue growth month over month. Here we can see that in May, we had a substantial increase in growth. And that's because we had a pretty low one in April. Anyway, it's a pretty big predictor in the business world. So let's get into calculating this. So in order to do this, we care about the previous month's revenue in order to calculate this. So we don't really need this lead function right here. I'm gonna go ahead and remove it. So what we need to do first, we'll just take net revenue and subtract it by this value right here to get basically our change every single time. And we'll give it the alias monthly revenue growth. Okay, now we can see from this that it is calculating that growth. An easy line to see is row 2. We went from the previous month at 4 million to that month of 2 million. So we lost 2 million. Yeah, calculations are doing well. Okay, we want a rate of change. Because of this, we need to actually divide this value of net revenue minus the previous month revenue. And we need to divide that by our original value, which is our previous month revenue. So I'm gonna go ahead and copy that again, paste that down here. Let's go ahead and run this. And bam, there we have it. We are now calculating that rate of change. And we can basically see that for in March, we had about a 50% reduction in revenue. Whereas in something like May, we had almost 150% rate of growth. Just to be clear, this is decimals, so this is the percent. If I wanted to, I could just do 100 times this value, and then we can see this percentage a little bit easier with this. So let's get into an example to show the benefit of these type of functions that can be used. And previously, in the second lessons of this chapter on aggregation, we went in and covered what was the average lifetime value based on your cohort. If you recall back, your cohort, you're assigned a cohort, or a customer's assigned a cohort based on the year of their first purchase. And we noticed this trend that following around 2016, we see the lifetime value drop during these, and that makes sense because their actual total lifetime is slightly shorter. But we did have this unexpected rise from 2015 to 2016. Anyway, what happens if we want to go through and actually analyze what are these different drops between each one of these LTVs? Well, we can use our lag function for this. Now, in order to do this, the table we need to start is this. We need the cohort year versus their average cohort lifetime value. Now, we basically calculated this back in lesson 2 of this chapter on aggregation. Here I have the formula here, and actually what we got to inside of the lesson was this final table, which consisted of one CT and then another formula underneath it. Anyway, I took it a step further inside the notes. So for those that have access to the notes, you can go right to it, and all you need to do is copy this. The other option, just pause your screen and copy this in. Also, this next example we're getting into isn't that long, so you can just watch along if you don't even want to do any of these. So we need to run window functions on this. after I've gone through and inspected this, it's a CTE and inside of another CTE, but then we have to do this select distinct because we have multiple different rows. So I'm actually gonna put this one also into a CTE. I'll give it the name of cohort final. I need to go ahead and put a closing parentheses on this and then do a select star from cohort final. Make sure everything's appearing just fine underneath here, and it is. Okay, now we can work from here to insert in, and we want to create our first column to look at what is the previous year's lifetime value. So for this, we're going to be using lag. I'll do a select star to basically show both those rows and then do a lag. And the value we want to put in here is what value we want actually to appear, and that is the average cohort lifetime value. We'll do over, and then inside parentheses, we're going to do an order by, and we're going to order by that cohort year. And we'll give it that alias of previous cohort lifetime value. And okay, we're seeing that it is in fact the previous cohort lifetime value. All right, final thing I want to do here is calculate that percent change, so that year over year change, or better yet, the year of the cohort over year of cohort change. For this, remember our ratios of final minus original over original. So I'm going to take that final value of average cohort lifetime value and then subtract our Windows function. So Command C this, Command V. And then from there, I want to divide this by the original. So once again, paste in that previous cohort LTV, and we'll give it the alias of lifetime value change. Okay, we're going to go ahead and enter this. Okay. It's not the correct value. I expect this to be more of a decimal number. I think this has to do with basically my order of operations here. I think I have that parentheses in the wrong place. I want to do the subtraction first, and then after that, the division. Okay, this is giving it to us. I want to actually see these as a percentage. So I'm going to put 100 at the front, multiply this, and bam, now we can see our lifetime value change year to year. As expected, we had a slight increase in 2016, and then from there, it went down. Now, if you actually go through and visualize this, looking at, this is the average cohort lifetime value in the bars, and then the actual rate of change, we can see that the rate of change actually is picking up. So although I would expect it to go down, I wouldn't expect it to go down at this high of a rate. So maybe something we need to dig into in a real life scenario if this was happening. All right, you got some practice problems to now go through to get more familiar with handling these type of functions and window functions. In the next and final lesson of this chapter, we're going to be going into further detail and syntax to understand to be able to use, like we demonstrated that last value function, how it wasn't working properly without further syntax specified to it. We're going to be going over that in there. All right, with that, I'll see you in the next one. Welcome to this fifth and final lesson on window functions, where we're going to be focusing on frame clauses. Now, up to this point with window functions, we've only really focused on two things of the window definition. That's the portion after the over. And that is looking at how we can use partition by and order by. But there's actually one more thing to cover with this, and that's the frame clause. This aspect helps control what amount of data we want to actually control putting inside of the Windows function. What do I mean by all this? Well, as we're going to be solving in this, say we have something like the monthly net revenue. This is from 2023. As you can see, it's highly volatile, going up in February, and then going back down, and then going back up. Well, this is where frame clauses come to the rescue. What we can do is look before and after certain rows, and in this case, average them. And so we could, in this case, perform a 3-month running average to basically smooth out our line. And this is very common in business analytics, especially with seasonal data that has these types of ups and downs. You want to remove all the noise and actually be able to look at it more clearly. So Postgres has some documentation that goes all into this, but it gets quite complex, so I simplified it in our notes. So this lesson is going to be focusing on using the frame clause of rows, basically looking at what rows we want to put inside of this window function. Now, as hinted to, this comes right after our order by, and we can either include something like the start frame, or we can use that between keyword to signify a start frame and then also an end frame. But what the heck are the start frame? What's this end frame? Well, there's 5 main things we could put inside of here, and as the majority of this lesson of what we're going to be getting into, we're going to be able to see how we can use current rows, preceding rows, and also following rows. Don't worry, we're going to break each one of these down, so you'll be more than familiar with it by the end of this. Now with Postgres, you can also specify, besides using row, you can also use things like range or groups. This I would classify into more of advanced SQL, so we're not going to be really covering it in this course. Additionally, I had ChatGPT make this fancy dancy table down here, and I want to just show it this. Range and groups also isn't supported in a lot of other popular databases, specifically MySQL and SQL Server. So I don't really want to waste your time if you don't have those type of keywords available to use. That's why we're going to focus on rows. Anyway, you need to learn anyway to be able to apply range and groups if you want to learn that later on. Now for this entire lesson, we're going to be analyzing our monthly net revenue similar to what we did in the last lesson, because as you remember, we had some unanswered questions on how to use some of those functions without what we're going to learn in here. We'll get to that by the end. Anyway, you should remember this query or have it in your system already, right? This goes through and gets not only the month, but also the net revenue for that month. Pulls it from the sales table, and it only extracts 2023. I just want to look at 1 year, so there's not a lot of data we're messed with. Since we're doing an aggregation function, we need a group by, and then finally need an OR by because it gets all out of whack. And you should see something like this, looking at our monthly net revenue. If we graphed it, it looks something like this that we saw at the beginning. Goes up in February, and then also has a strong dip down in April, then returns back to normal. We're going to be working towards getting a running average with this, but we first need to understand current row, which is the keyword of this one, before we move any further. So I want to run a window function on this query, so I'm going to put it into a CTE. We'll give it the alias monthly sales, and I'll put it into parentheses. We'll select both the month and also the net revenue, and pull this all from monthly sales. Let's go ahead and run this, and it's exactly the same thing that we saw before. Now we can actually run or use a window function here. Instead of on here, like we said before, can't be using window functions with a group by. We can, it's really complicated, we're not gonna do it. Anyway, we're gonna do the window function below. Specifically, all I wanna do is get the average net revenue for this month. So basically repeat that same value. So we'll start by calling average on net revenue. We'll go over, I'll start a new line and indent down. And then before we actually stick anything else, let's just look what it generates. It's going to generate the average across all 12 months. So we want to do this, or we want to order it by the month itself. So I'll do an order by and then specify month. Now running this query, we're still getting the average, but it's slightly different now. For January, it's still the same in that it's the January average. But if we look at something like February, it's getting the average based on January and February. For March, it's getting it based on January, February, March. Anyway, we want to control this average, so let's move forward. We're going to start by renaming this column. So I'll give it the alias of net revenue current because we're about to use current row. Now this has the following syntax of rows and then the start frame. We'll eventually get to this one of rows between, but we're just going to start simple with this one first. And then remember our start frame or end frame can be any one of the following. We're just starting first with just current rows where we then move into calculating the average. Or should I say the running average? All right, so I'm gonna insert in rows, and then from there, current row. Now this is selecting to run this window function on this current row. So there should be no difference between any of these. Promise you we'll see more of an impact in a little bit, but I do wanna demonstrate how you can also write this rows between, and we need to do our start frame, so current row, and our ending, and we'll do, once again, current row. As you would expect, it's only looking at the current one, so it's going to be the same across all of these. Let's get into our next keyword of looking at how we can use something like n precedings, looking at preceding rows or preceding values. This is going to be the final table that we get. In it, we still have our monthly and our net revenue. And what we're going to look at in this case is just one row back and the current row in order to get the average. Right here at the first one, we'd expect it to be the same as this one. But whenever we get to the second row right here, it's going to look at this current one and also the preceding one and get an average. So the average of 3.6 million and 4.4 million is around 4 million. And so for this, we're going to use inside of our start frame, we're going to use n preceding, specifying n as a number. So getting back to our query, right now we have in there to do rows between current row and current row. We want to go one row back and also look at our current row. So I'm going to remove this portion and we'll specify one preceding. Oh, not receding, but actually proceeding. Okay, let's go ahead and run this. And as we saw is that in that demo table, we're now taking the average of the current row and the previous row. We get 4 million in this case. So we take any number of values. Also, we could just make sure that this is actually working properly by putting a 0 instead in here instead of 1, which means the current row, and we're getting all the same values as before. But we're going to change that back to 1. Now I'm going to take a step further just for demonstration purposes. You don't have to do this portion. But I went through and we did one preceding. I wanted to see what it was going to look like for also doing 2 preceding and 3 preceding. And I got this fancy dancy table and from there plugged it into ChatGPT to actually visualize it. And what we can see from this is that with each preceding row that we include, so we include more to take an average of it, this line becomes smoother and smoother. It starts with a darker line with just core net revenue, and then gets lighter and lighter depending on the preceding amounts that we used. I know there's a lot of overlap here, so I also took it like this and I graphed each one of them individually, showing how over time it gets smoother, smoother, and smoother. So now you're probably like, Lou, is this what you do in a real world scenario? I'd say, well, not typically just the preceding, but I combine this with something like following. And so we'd use values before and after the current month and get something like a 3-month average, which let's do it now. So just as a reminder, it's going to be of the syntax and following where you can specify the number, and it gets that many number of rows after the current row. So back to our original query that we're working with, instead of doing one preceding and the current row, what I'm going to do is now change this to one preceding and one following. Running this query, we can see that all our values now, especially even that first month, is smoothed out because it's not only taking the current month, but the following month. Whereas something like June is taking not only May's month, but also July's month, and then averaging it together to get this value. This, I feel, is more representative of what I'd see in the business world. I went ahead and visualized it, and this shows how this actually smooths out our net revenue line by performing this 3-month average. Now you could take it up a notch and do something like a 5-month or even 7-month running average. But at that point, I think you're going to be removing a lot of key insights from this. So I'm going to stop right here at that. Our last 2 start frame and end frames to end with. And this is unbounded preceding and unbounded following. If you notice carefully, all they're really doing is replacing the n with unbounded. And this says, hey, we want to use all rows from the start or maybe all rows from the end. So let's actually just do just that in here. We're going to place one on these with both of unbounded. And what do you think is going to happen here? Well, if we use unbounded on both, it's taken the entire window function or window frame into the account for running this average. So we're basically getting the average of all of these 12 months. Now, typically when I'm seeing anything like unbounded used, I'm usually seeing it with something like current row. Running this, we can see that the first row is equal to basically itself. And then as it goes along, it's taken into account all the values behind it along with the current row. And it seems like the line is just getting smoother and smoother and smoother as it goes along. So where am I typically seeing these unbounded parameters being used? Well, if you remember from that last lesson, when we were looking at same chart of the monthly revenue, we were able to use like lag lead functions, specifically first value, last value, and nth value. Let's go ahead and run this. We saw that for our first value, it actually did give us the first value, but then the last value, it didn't work out properly. It just gave us what the current row. And then for the third most, or whenever we did nth value and specified 3, it gave non-values for the first 2, but then finally gave us the third value for everything else. Well, this is where unbounded comes in. So let's fix these functions to be able to do this. And then I'm gonna indent this down to make a new line to make this a little bit more readable. And then from there, I'm gonna insert in our frames clause, specifying that rows between, and then rows between unbounded preceding and unbounded following. Running this one now, whenever we look at that last month revenue, we can actually see that it actually does equal the last month. Basically, we had to open up what it was going to look at for that window function by using this frame clause. Similarly, we can do the same with that nth value. I'm going to go ahead and just copy and then paste that right into here. Now running this, and we can see that now that third month's rent is appearing in every single line, regardless if it's before or after. So bam, we've now covered all of the major aspects of using window functions. You now have some practice problems to go through and get more familiar with using these different frame clauses inside of window functions. And then in the next chapter, we're actually going to be getting into how you can install this database locally and run it locally so you can have a workflow that's actually workable. With that, see you in the next one. All right, welcome to the second half of this course. Don't know why I had to jump in like that. Wanted to have a dramatic entrance for some reason. Anyway, in this chapter, I'm going to be taking you through all the steps necessary in order to install Postgres locally onto your computer, get you set up with its editor of pgadmin, and then also get you set up with an even better editor of DBeaver. So let's break this down. In this lesson, we're going to be installing Postgres, or the database itself, locally onto your computer. We're going to be downloading it from the internet, and then it's going to install Postgres, but also pgadmin. Now, pgadmin, PG short for Postgres, is the editor used in order to interact with Postgres databases. So anytime you need to start or stop the database, or even if you want to run a query with it, we can do that with pgadmin, which we're going to demonstrate all during this lesson. Now, if you already have Postgres and pgadmin installed, you don't need to do it again. But in this lesson, after we do the install, we're going to go directly into actually loading the database, specifically our 𝗏𝗏𝗄𝗏 database that we've been using in those Jupyter notebooks. Once we get the database set up, we're going to do a quick walkthrough of the entire pgadmin UI so you become more familiar with it. Now, there's one major flaw with pgadmin, and that's it only connects to Postgres databases. And after this course, you may be proceeding on to learn other databases. Because of that, we're going to be installing in the second lesson DBeaver. Now, this is a database management tool. So you can not only connect to different databases, you can also run queries on it to see the output. We're going to be using the community edition of this, and it's free and open source and has everything we need to do to get started. This is the most popular database tool that I know of, so I'm super excited to use this. And everything that you learn for using DBeaver can also be applied with other databases, which DBeaver can connect to. One last note before we begin. Some of you may run into installation errors or other errors along the way. I highly encourage you to use something like ChatGPT to help you out. It's a lot quicker than trying to post a comment and hoping somebody else comes in to help you out. Now, let's say you can't figure it out, or you're on something like a Chromebook and can't install Postgres. In that case, you can continue to run all of the different queries in our SQL notebooks. They're going to work exactly the same and have the same output, but as far as interacting with the GUI and stuff like that, you're going to have to figure that all out yourself, because obviously it's going to be different than DBeaver. So first, we're going to navigate to the download page from Postgres. And from there, you're going to select your operating system that you're currently on. I'm on a Mac, so select that. We're going to be using the interactive installer by EDB. So we're going to select right here of download the installer, which everybody, regardless operating system, is going to get navigated to this page where you can then select your operating system once again and download it. For Mac or Windows, you're going to want to launch this installer. If it gets a warning message, it's okay, click open it. We're not going to walk through the actual setup wizard that it has included. For all this, we're going to leave all the defaults the same. Core things that we do want to make sure are installed, which are by default, are Postgres server and also pgadmin, which is the GUI interface. Next is the password, and I'm actually going to set this one to a really easy one of password. Now my database, I'm not going to have any confidential material on it, and this database that we're installing isn't secret at all, so I don't care if somebody else accesses it. But it doesn't really matter because it's local anyway, so other people can't necessarily get to it unless I have access to the internet. Anyway, that's a long story. Key thing, if you're only going to be doing this course with this, feel free to just set it to password. You should be okay, but if you're not, set it to something else and remember it. Keep the port number the same of 5432. It's common to Postgres databases. And we'll keep the default locale, and we'll go ahead with this. Setup's complete. I don't need to launch this stack builder at exit. I'm gonna go ahead and click finish. And I'm gonna verify this is now installed by going to my applications folder. Under Postgres 17, I have these different options of what's installed. We're gonna be opening up pgadmin. This is the GUI interface for interacting with our Postgres database. It'll start loading up. With this open, we have two main panes in here. We have our left-hand side pane, which is our Object Explorer, which shows all the different databases we're connected to. Right now it's asking me to connect to the server, specifically Postgres 17, which is the one we installed. So I'm gonna go ahead and put that password in of password. And I'm gonna click this of save password. So as we can see, Postgres 17 is a server. We have one server. And then from there, we have databases inside of that server. Right now, we only have this one standard database that comes in all Postgres servers called Postgres. We're not gonna touch this bad boy. I don't really care about it. But we can see that, hey, there's only one database in here. We also have options to adjust login or group roles, and then also table spaces. We're also not gonna be messing with any of this. This dashboard over here on the right-hand side, I find pretty useless. It just tells me when I have interactions inside of my server and when it's getting used. So now let's install the 𝗏𝗏𝗄𝗏 dataset locally. For this, we need the database file for it, which is right here at this 𝗏𝗏𝗄𝗏_100𝗀.SQL file. We'll go ahead and start downloading. You don't need to do this, but I went ahead and opened this file just to show you the contents. And in this, it walks through actually creating all the different tables that we need inside of our database, along with loading in all of our data into it. It's a pretty long file. So let's get this file into a database. And for this, we need a database for this. So we'll right-click databases, select create and database. We'll name this 𝗏𝗏𝗄𝗏_100𝗀. Keep all letters lowercase. The owner will be maintained as the super user of Postgres, so we can use that same password to access it. We don't need to change any of these other settings right here. They're all good enough. We'll go ahead and click save. Now we can see we have two databases underneath here, and it automatically dropped everything down underneath here. Now, if I go under schemas, and then it has a public schema, I can see underneath tables, if I click this to actually drop it down to see any tables, there's no tables inside of it. So this is where we need to actually load that SQL file into this database. First thing, you need to know the location of where it is. I recommend just put it on your desktop. We don't need it after it's done, so you can just delete it. Back inside of pgadmin, I'm gonna right-click that 𝗏𝗏𝗄𝗏_100𝗀 database, and I'm gonna go here to pSQL tool. This is effectively like using a terminal to interact with our database. I'm gonna start this command off with a / then I. This is gonna tell it to execute the script that we're about to insert into this. And so inside of single quotes, I'm gonna then put the file location. And I'm gonna insert that in of users Luke Bruce desktop, and then the SQL file itself. Make sure that it's exactly right. On a Mac, if you go to the file itself, click Option, and then right-click it, you'll get this option here of copy 𝗏𝗏𝗄𝗏, the SQL file as path name. On Windows, all you need to do is shift and right-click the file icon and select copy as path. Okay, we got it in. Gonna go ahead and press enter. It says that pgadmin would like to access my desktop. Yes, I wanna allow this. And it's going through here and actually creating all the different tables and altering them. And I can see from this that we've put in, it looks like 6 different tables, and it tells us all the different counts of the rows that we inserted into those tables. So I'm gonna come in here and go to tables and try to see it. There's no tables in here, but all I need to do is just right-click 𝗏𝗏𝗄𝗏, select refresh. So now it should have it. And we can see scrolling down the tables, we have 6 tables inside of here, which from this menu, I can actually dive into, in the case of sales, actually dive into the different columns and everything else that has associated with this. I can also just do a quick check of this by right-clicking something like the sales column, going to count rows, and it tells me at the bottom, there's over 199,000 rows in this sales table. But how can we actually query this database of 𝗏𝗏𝗀𝗀 𝗏𝗀𝗀𝗀? Well, first we need to make sure that it's actually selected and then come up here and select Query Tool. We can also see that they have a shortcut of Option-Shift-Q. It opens up in a new tab right here. I can see these other tabs here. If I don't want any of these other tabs, I can go ahead and select X and close it out. Up here at the top, it tells me which database I'm connected to. If I had any others, I could switch it right up here. We have our query window, which I'm going to put in a simple command to look at the sales table and the top 10 results. To run this, I'm going to come up here and select this play icon for execute script, or I can press F5. And all the results are displayed here below. I also have this scratch pad over here on the right-hand side. So if I don't have queries that I want to keep track of, I can just put it over on the right. Overall, I don't find myself using it that much. Other key features of this area are you could open a SQL file right inside this window, or if I wanted to save this, I could save the file. We also have options for explain, which we're going to go into more detail in some upcoming lessons. Now down here at the bottom, we don't only have the data output, but also any messages and notifications. Inside of data output, they actually have a few unique capabilities with this in that you can copy any of your different exports of data out of it if you want to put in ChatGPT or something. Let's say we have a more complex query that actually does some analysis, such as this one right here that looks at the total yearly net revenue. Well, we can not only save results to file, but also we can graph and visualize it right here. I select line chart, and then we want the year for the x-axis, and then the total year net revenue for that y-axis, and then select generate. And not too bad to actually get into visualizing queries pretty easily in this. Last thing to note with pgadmin is I can also do things like view the ERD, or the entity relationship diagram for the database by right-clicking it, select ERD for database. And with this is showing our sales table. I can scroll in through this and actually see the sales table along all the different keys and columns in it. And with this table, how it's connected to all these other different tables in it. So a great way to visualize your database and tables that you're working with. All right, we now have some practice problems for you to go through and get more familiar with this pgadmin GUI. Like I mentioned at the beginning, we will be transitioning next to DBeaver, but I do find myself from time to time having to jump in and use pgadmin. So it pays off in understanding the basics of this tool. That's why I got this practice problems. All right, with that, I'll see you in the next one. Welcome to this lesson on DBeaver. In this, we're going to be walking through setting up and getting DBeaver connected to our 𝗏𝗏𝗀𝗀 database. First thing we're going to do is going to download the community edition of DBeaver, which is free. Then from there, walk through the steps necessary in DBeaver to connect to our Postgres database. And then finally, once we have that set up, we're going to actually do a walkthrough of the DBeaver UI, understanding how we can run different scripts and how we can set up our project inside of it. All right, with that, let's get into it. All right, if you navigate over to dbeaver.io, this is the homepage of DBeaver Community. And this covers a few details about the tools. You can read further, specifically DBeaver Community, the edition we're downloading, connects to a variety of databases and has all these different editing and viewing options. It's by far, talking to all my data analyst friends and also looking at the research, it's the most popular database editor. So that's why we're using it. Now, DBeaver needs to make money like any community. So they also have a Pro edition. I'm gonna go ahead and click this, you don't need to. And so with that, they have a few different editions that you can get and use. Some get pretty pricey if you're a business. But as far as the basic SQL and coding that I run, I don't ever need the features that are inside the Lite, Enterprise, or Ultimate edition. I can get it all done with the Community edition. But if you become a power user, highly encourage you buy a subscription because you support building out DBeaver further. All right, cool story, Luke. Let's actually now get into downloading DBeaver. We'll click download. And then from there, you select what operating system you're on and install it. I'm going to be going through with Mac. Windows is going to be very similar, so I'm not going to cover them separately. After your installer file loads, you should click it and open it up. On Mac, it's pretty easy. All you have to do is drag the Beaver over into your applications folder. And now it's here. I'll go ahead and open it up. If it asks if you're comfortable with opening this app up, yeah, we know where we got it from. I'm going to open it. With DBeaver opened up and launched, you may notice first that mine may be dark and yours may be white. I have dark mode enabled on my Mac, so I guess it automatically picked it up. change the dark mode. Anyway, it says, hey, do you want to create a sample database? It can be used as an example to explore basic DBeaver features. We're not going to do that. We're going to just install the 𝗏𝗏𝗀𝗏 dataset, and then I'm going to take you through this. So it should have immediately popped open with this of a connect to database. And now we're going to get into installing the database. If this select database didn't pop up, that's okay. There's a few different ways you can get it up, and we need to go through it anyway. One other thing before that, it does have this pop-up that says, hey, do you want to share your data in order to improve performance? I'll leave it up to you on whether you want to do this or not. So to create a new database connection, you can either go up to the file menu and go to databases and select new connections, or you can just come right here to this fancy dancy icon and select new database connection. Now, this is one of the reasons why I recommend DBeaver so much, is because it connects to a host of different databases. And so that way you can connect all your different ones that you're working on as a data analyst. So in our case, our 𝗏𝗏𝗀𝗏 is a Postgres database. We'll select that. Now we need to go through and fill out the connection details. We're going to be connected by host, specifically our local host. So it's locally on your computer. The database name is not Postgres. It's the 𝗏𝗏𝗀𝗏𝗀𝗏. Make sure you spell it exactly the same as what's appearing in pgadmin. Next, we're going to move into the username, which we maintained it as Postgres, and then the password. If you named it like me, the password is just password, all lowercase. I'm going to leave save password enabled because I don't have to log it in every single time. From here, it's already picking up that we're using Postgres 17 and everything else looks good. Let's go ahead and test connection. In my case, it's saying that the Postgres driver files are not installed. We need to install them. Basically, like if you install a printer into your computer or attach a printer to your computer, you have to install driver files to attach to it. So similar here. Nothing wrong with this. We're going to go ahead and download. With that, we get our test results back and it says that we are connected. Now, if you have issues with that, one, check all those credentials, make sure they're correct. But two, what may happen to you is that your database may not be started. And so you may need to open pgadmin and actually open it all the way up to the 𝗏𝗏𝗀𝗏𝗏 dataset and make sure that it's actually running on your machine. Typically for both Mac and Windows, your Postgres databases should start when you restart your computer. So you shouldn't have to do this, but you may have unintentionally disabled this feature. And so you may have to restart it anytime you restart your computer. With all the credentials put in and the testing of the connection sat, we're going to go ahead and select Finish. So let's now walk through DBeaver and get into understanding the UI and also running a few different files. Okay, so we have this pane right here on the left-hand side, and that is our database navigator. Also, it holds our different information on our projects, which we'll get to projects in a minute. Anyway, this has all of our database information in it if we want to see it, specifically underneath Database Navigator. If for some reason this disappears, like I accidentally close out of it, you can go into the Windows menu item and from there, show the actual view of Database Navigator, pop right back up. So what's inside of here? Well, very much similar to what we saw in pgadmin. We can see all of our different databases, and here we have our 𝗏𝗏𝗀𝗏𝗏𝗀 database. We also have these folders on administer and system info. These are ones that I'm using less. I'm typically staying inside of here. Specifically inside this 𝗏𝗏𝗀𝗏𝗏𝗏, go into schemas under public, because it's the public schema we care about, and I can go into actually viewing all our different tables. If I drop something down like the sales table, I can see, if I wanted to, go into all the different columns in it, along with what is the data type of those columns. I can also see a host of other information like foreign keys and whatnot. Anyway, one thing that you may have noticed about this is that there are numbers over here on the left-hand side. These aren't the number of rows, but instead, if you hover over it, you can see that it tells you how much disk space that specific table takes up. So you can get a general idea of how big these tables are just on disk space alone. So I can see that sales and also the customer table specifically are pretty big. Relative, of course. This is actually a pretty small database. Now, what I like about tools like DBeaver is how easy it is to dive into these tables without having to write a SQL query. Specifically, if I wanted to see what was in the sales table, I can right-click it and then just go to View Table. Now this side is the database editor, and it actually has a tab view. It's like I could do something like this, open also the currency exchange, and it has multiple different tabs that I can cycle through. Now with this, I can view a bunch of different things underneath properties. I can look at all the different columns, foreign keys, constraints, whatnot. Next up is data. I can obviously look at the different columns inside of here and scroll through it a lot easier, similar to Excel spreadsheet. And then the other one is the ER diagram, or the ERD. And this shows how your tables are connected all together. I actually feel compared to pgadmin, this one is more realistic and shows how they're all connected. Whereas I don't know if you remembered from pgadmin, but they all like connected into a single line and went all over. It was a hot mess. So DBeaver does a little bit better at this. Anyway, the view that I'm typically looking at most is this data one right here. And I can look at it as a grid or also as a text. Text I don't find very useful at all, except if I need to copy and paste it. Grid is mostly where I'm staying. Now, this GUI in here has a lot of different options that you can use to interact with these tables and view them. Specifically, you could enter a SQL expression to filter it down. You could also actually put in custom filters in here to filter it down. Down at the bottom, we can do things like add rows, remove rows. Typically, I do this with SQL. I'm not going to mess with it here in DBeaver. You can also cycle through the different pages and whatnot. One that I do find useful, however, is this of export data. And anytime you have any of your data that you have and you want to get it out of here, you can put it into a variety of different sources. Typically, I'm doing something either of exporting it to a CSV or export it to SQL, which will make it into a SQL insert statement. All right, so enough of that. Let's actually get into setting up our project folder. I don't need these two tables open up. It's also asking me if I want to save these changes in the database. I didn't really change anything, or I didn't want to change anything, so I'm going to click no. So we're going to be creating a project folder. I'm going to click projects right here in order to be able to save our SQL files if we want to as we go along. Right now, we just have this general right here, which has bookmarks, dashboards, diagram strips. We can also see it right below here. I don't really care about the general one. I want to now create a project specific to this course that we're working on. So I'm going to come up to the top right here and select Create Project. And I'm going to call this Intermediate SQL Project. Real original, I know. With this project, I'm going to leave it to the default location, which is inside of the DBeaver folder. I could uncheck this and then change that to wherever I want it to be. Just so you're aware, I'm going to leave it in the default location. I don't want to add the project to a working set, so I'm going to go ahead and select Finish. So now I have this Intermediate SQL project and my general. My Intermediate SQL is my main project, or my active project, so I'm actually going to right-click it and say Set Active Project. And then it should shift to bolded. Additionally, if I go back up to Windows in the File menu and go over to Project Explorer, I can have that now appearing below. If you didn't close it out, it was general, it should have switched to that. Anyway, I like this type of view because now I can switch between them. But if you notice the database navigator, we now don't have our SQL database in there anymore. So what we can do is go back to projects, and it actually makes it pretty easy in here. Right here under general, I have the 𝗏𝗏𝗀𝗏, but what if I tried to click the connections of the intermediate SQL project? There's no database that it's talking about. So we loaded the database into general. We want it to move it over down here. And so bam, now when I open this project folder, which it's the default one in this case, now it's inside of here in the database navigator as well. So it's pretty neat of how I can keep this all grouped together in a single project. Now by default, there's 4 different folders in here. They all should be empty of bookmarks, dashboards, diagrams, and scripts. Bookmarks are just, as they imply, bookmarks. If you have something that you frequently go to, you can just put it there. In this case, let's say I frequently go to the sales table. I can stick it in bookmarks, and now it makes it super easy. Anytime I need to go to that, just click on it and bam, it appears right here. Next, we have dashboards and nothing in this, but you could create a new project dashboard. If you remember from pgadmin, they had actually a default dashboard that shows all the different sections, transactions, stuff like that. I'm not a database engineer. I don't really care about all that, so we're not using that. Next are diagrams. If I wanted to, I could create a new ERD. I could call it 𝗏𝗏𝗀𝗏𝗏 ERD. Now this does have our 5 core tables in here, but also it has a host of other different tables that just come natively inside of a Postgres database whenever you install it. So they're all going to be there if you make it this way. You can filter down. We're not going to go into that. All right, the last thing is scripts. How the heck do we create a new SQL script? Well, you can do this from SQL Editor in the menu, or just come up to the top here and select Open SQL Script. Now there's a few different options that popped up here since we've done this. First, it tells us what is the active database, and it tells us what is the active database schema. So this is especially important when you're working with multiple databases to make sure that you're running the queries on the correct database. Now notice whenever we open this up inside of here, the script itself, we also have a new script underneath here. I'm gonna go ahead and minimize these. We don't need this. Anyway, we have script inside of here. If I wanted to, I can right click it and go to something like rename, and then we can name it appropriately. Like this is just a test script, and I'll make sure that's a SQL file, press OK, and it's since been renamed. So let's run our first SQL query. We're just gonna make a simple statement of we wanna select all columns from the sales table, and we want to limit this to 10 results. If you notice this, I was typing in all caps as I was going along, and then it made it lowercase after. We're gonna fix that in a little bit. Anyway, if I want to run this single query on a Mac, I'm gonna press Command Enter. On Windows, I'm gonna press Control Enter. Also, if you forget, you can just scroll over these icons and click it, and it also gives you what the shortcut is. Now, similar to what we saw before with how we can view different tables and outputs, I'm gonna have a tab here, and then underneath this, I can actually explore it in different ways with text or grid. I can also cycle through it if I want to, export the data. So a lot of different options to manipulate this and dive into all of it. Let's run a slightly more complex query to just demonstrate the power of this. I'm gonna make this into a CTE, and then we're gonna run a query on that CTE. So I'll enter this down, put in a with keyword. We'll call this sales copy because that's what it's gonna be. Give it the alias of as, and then open parentheses. Now I need to clean this up. I like indentations and things like that. I can actually highlight this all, right click it, and then go into format, and I have this option for format SQL. On a Mac, this shortcut is Control-Shift-F, so I can actually just do that instead of doing Control-Shift-F, and it makes it slightly more readable, although it didn't indent it in. Anyway, as always with any CTE, I'm gonna go down here and do select and star, and then we're gonna be doing this from the sales copy table above. Now, if you notice this, it automatically gave me this error message saying, hey, sales copy is not located above. And actually, if I even tried to run this with this by pressing Command Enter, it tells me sales copy doesn't exist, but I can clearly see that it's up here. That's because DBeaver automatically treats any blank spaces or blank rows as a end line delimiter. Basically, it treats it as like a semicolon at the end. So what we need to do is subtract that out of there. And I'm still getting an error message. I don't know why I am, but oh, it's running now and it cleared. Okay, I just had to run it once. Anyway, I don't like those two things right now. I don't like how it's automatically making everything lowercase, and I don't like that it automatically gives me this error message when there's just a space in there. So we need to change some settings before I want to proceed on. If you're on a Mac, you're just going to select DBeaver up in the menu and select Preferences. On a Windows, I think you're going to select File. After you select Settings, this Preferences window will open up. And this allows us to go in and actually control things inside of the editor itself. I want to control things in the SQL editor. Specifically for the formatting, right now the keyword case is set to default, which is lowercase. I want it to be upper, so I'm going to change it to that. You can also control your indent size down to like 2. I like bigger indents, so I'm gonna do 4. Also, if you noticed previously, it wasn't indenting in those things that are in parentheses. I like that. So whenever I click this, it does indent it in. So I'm gonna have that selected as well. Last thing to update is under SQL processing, and moving this over. In this, we have blank line is statement delimiter. Always. We remember sometimes we may have blank lines in there. I don't really like this setting, so I'm going to change this to never. You can also change to smart, but I'm not guaranteeing it. Okay, we're going to do apply and close. Now I'm going to select all of this, press Control-Shift-F, and it formats it exactly like alike. So basically it changed all those keywords to uppercase and indented it in like alike. Not too bad. Now that was just one query. I could put a semicolon in here, and then let's say I wanted to do another query on top of this. I can keep it in the same script. Some things I didn't call it before, but anytime we're typing any words, you're gonna have this autocomplete, and it also tells you what is going on there. Similarly, if I'm doing something like a function, count in this case, it tells me, hey, it's a built-in function in the database, I can use this. And then after I insert something like from, it automatically knows, hey, he probably wants to put in a table. So I could put something like customer in here. Now I have multiple scripts inside of here. So what I could do is, if I just want to enter this script, I'm gonna go ahead and close this out down below. If I just want to do that script right there, I'm gonna press Command Enter, and it's only gonna run the one script, tells me there's 104,000 rows. Now the other thing I could do, let's say I wanna run all of these scripts. They have this icon right here for execute SQL script. For me, it's the shortcut of Option X. On Windows, I believe it's Alt X. I can go ahead and, well, we're gonna close out of this first. I'm gonna select here and press Option X, and it automatically opens up each of these in different tabs. Now, one thing to note is like, okay, how do I keep track of what are all these different queries that are ran right here? Well, you can put a brief comment up at the top using 2 dashes. And we'll call this one sales copy. And then the one at the bottom, we'll call this customer count. Now running this again, pressing Option X, it prompts me, hey, there are 3 unpinned results tabs. Do you want to close these tabs before executing the new query? I want to do this all the time. If I'm running a new query, I just want to see the new results. So I'm going to say, hey, don't ask me again. And I'm going to say, yes, I do want these closed. And that didn't work because I actually told you wrong. You need to actually specify that this is a title. So you specify title, colon, and then whatever it needs to continue on after that for what the title is. I'm gonna do that for both of these, press Option X, and now both of these are named both below. This is very convenient when you have multiple queries and you're gonna have obviously multiple different tabs. Also, there is this one of the statistics tab, basically just tells you the statistics that it ran 2 queries, how long it took, and whatnot. So now with this test script that we've created, if I wanted to, I can see that it's not saved because it has an asterisk. I can go into File and select Save, or press Command S or Control S. And the asterisk went away, and now I can close it. And if I ever wanted to go back to that certain script, I can just pop it up here and run it as necessary. Bam! So now hopefully you're following along and you went through and installed DBeaver, because you need to do that unless you plan on using Jupyter Notebooks or Colab to run the future queries. Anyway, we now have some practice problems for you to go through and get even more familiar with DBeaver, with all these different settings, and actually getting familiar with running SQL queries. With that, we'll be jumping into the next chapter on building views. So see you there. Welcome to this chapter on views. Now, views only takes up really a small portion of this. The majority of this chapter is going to be an intro to the project using views. Now, in this, we're going to be going through 3 lessons. In this lesson, specifically for this video, it's going to be an intro to views, how to create views, how to delete them, how to manage them, and why they're so important. In the second lesson, we're going to be using that view that we're creating in this lesson in order to analyze it further and answer one of our second questions in our project. Now, our project in total has 3 questions, which I'm going to showcase here what we're going to be doing in a little bit. And you may be like, Luke, what happened to question 1? Well, question 1, we actually answered, or started to answer it earlier in the lesson. We're just going to be building on it further in some future lessons. Don't worry, I'll be getting you up to speed. Okay, and then the third lesson that we're going to be getting to in this is actually installing VSCode, which is a code editor that makes it super easy for us to build up our portfolio project and then share it onto the internet. Now, before we get into views, I want to just showcase what we're going to be building in this project. Specifically, we're going to be sharing this to your GitHub profile, and it's going to detail everything that you've done. Now, if you're not familiar with GitHub, this is a location that you can store and also share or collaborate on files. Here in this menu area, this shows all the different files in this repo. As we can see, we have some SQL files and then a README, which I'll discuss more in a little bit. And then we have like something like this, which is an images folder. If I click on it, I can see that they have something like image inside of it. Anyway, getting to that README. The README on the front page of a project is going to be displayed right below it. So here I can go through and actually document all the different analysis that I've done. So if I have some employer interested in different analyses that I've done, they can come to my GitHub and view all that here. And now you may be like, Luke, why the heck do I need to install VSCode? You already have me installed DBeaver. What the heck am I doing with this? Well, VSCode, if you've taken my basic course, you know it's really powerful, not only in writing SQL queries, but also in other coding projects, like using Python or whatnot. Anyway, what the special use case in this project is actually building our README. Here, I've typed out all the different portions of the README. And if we actually view it here, I can see it all dressed up on the right-hand side, how it's going to appear on something like GitHub. Unfortunately, DBeaver doesn't have these capabilities, along with the fact that I can also go through and push this and put this onto GitHub right here from this GUI. So loads of benefit. Those that have come from a basic SQL course, you've used VS Code, you're familiar with it, there's not going to be a lot of stuff new that we covered here. You'll probably be able to even skip this lesson on VS Code. So let's get into views. Well, first of all, what the heck is a view? It's a virtual table that allows us to show the results of a stored query in it. For example, we're going to be going through in our next example and creating a view you can find underneath the views folder underneath the public schema. And we're going to create this one called cohort analysis. Whenever I click on it, it's that virtual table. So this is has all the different results for a certain query. Specifically, I can go here under properties and look under source and actually see what was the SQL query taken to actually generate this virtual table. And so with this virtual table, in this case it's called cohort analysis, I can open up a script. I'll go ahead and clear all this out and say I want to select all the rows from the name of the view. Cohort analysis is even appearing right here, telling me that it's a view. When I run it, I get all the results of it below. Now, views are super important and are necessary to level up your SQL skills. They allow you to, or basically prevent you from having to go through and write the same query over time and time again. Because you know what happens whenever you have to write the same query over time and time again? You're eventually going to make a mistake. With a centralized view, this prevents that and also ensures that if you have this dedicated view, that any other queries that depend on that view will get updated if for some reason you have to update that view. Anyway, I'm getting ahead of myself. What's the syntax for this? All it is we need to use the keywords create view, give it an alias, and then provide all of our different SQL that we had below it to actually go into that view. So let's go in to create our first view. I'm actually going to go ahead and delete this view that we're going to create because you don't have it yet. For this, just open up a blank script. In this, we're going to do a simple query that allows us to get the daily revenue. For this, we're going to use the order date, and then also we're going to use the sum of quantity times net price times exchange rate and give it that alias of net revenue. This is from the sales table, and we need to perform a group by since we did that aggregation. All right, let's go ahead and run this bad boy. And looks like it's done all correctly. One thing to note, I didn't filter this or put this in any order. One thing to note is you can actually do that in here. I can just click one of these filters and say, hey, order by, we'll say in descending order. And it shows me, okay, we start in April 2024 and go backwards with the total revenue. Pretty neat. All right, so this is the view that we want to create. So let's create it using that syntax. Specifically, I specify create view, give it the name of daily revenue, and then just use as. Don't need to put this in parentheses. I'm gonna go ahead and run this, pressing Command Enter. And you should get something like this at the bottom telling me that the query is in fact finished. Now, if I go to views, there's nothing there. What I need to do is I need to actually refresh it. You could do this by right-clicking and clicking refresh, or you see the shortcut right here of F5. I'm just gonna do F5. So now in this case, that daily revenue is there. I can double click on it, open it up. It has a few different tabs underneath it. Like I said, the properties underneath it. So we can see something like the source, which gives us that query that we needed to create the view. So we don't need to save our query separately. It's right there. It also shows our data. And then finally, our ERD. In this case, it doesn't really connect to anything else. It's just its own table. Bam, that's it. Now, if I want to access this view, all I have to do is just do select star and specify I want this from daily revenue. And since I've put that semicolon in the last one, it's only going to run this one. When I run Command Enter. Now all the results are appearing below. Okay, let's say I'm done with this view or I don't need this view anymore. There's a couple ways I can get rid of it. I can right click it and just come down here to delete. It's going to then prompt me, are you sure you want to delete this view of daily revenue? And it asks, do I want to cascade delete? Basically, if there's other views based on those views, it's going to delete all of those as well. So you need to decide whether that's applicable or not, and then click yes or no or not. We're not going to actually delete it via that method. And I'm just going to confirm it's still there by refreshing this and showing that it is in fact still there. Instead, what we can do, once again, I put a semicolon, I can do something like drop view as a keyword, and then specify that view of daily revenue. Okay, let's go ahead and run this, pressing Command Enter. It tells me underneath it was completed pretty quickly. And coming over here, pressing F5, we can see that view is no longer there. Very important note is that deleting views is permanent. You can't recover it once you do that. So make sure you really want to, in fact, delete that view. Now that we got the basics of views, let's actually get into creating the view needed to answer a few of the different questions we're going to be answering in our project. Once again, a reminder, we're only going to be answering 3 questions for our project. And we'll be working on that second problem in the next lesson. Anyway, you haven't created this yet, but this is what we're going to be getting to eventually. And like I said, we're going to have our view in here, our different SQL files to answer our 3 questions, and then our README. This create view is what we're going to start working on in this lesson. We're not going to necessarily finish it in this lesson. We're going to finish it in the text cleanup lesson, but we're going to get a little bit of a start. So what the heck does this view actually provide us that we're actually going to use? So we're going to be diving into shortly a more advanced cohort analysis than what we've done previously. And we need a table, a view, if you will, to help us out and speed up that analysis. Specifically, this table is going to be basically broken down and aggregated to provide us key things about a customer, specifically when were their orders, how many orders they had, when was their first purchase date, what cohort they fall into, and then additionally some customer information from the customer table. This is going to be super helpful, especially for something like total net revenue, which does that quantity times net price times exchange rate. It's just already there. I don't have to worry about the calculation. Everything's there. So let's just start building this view. And we're going to be doing this by just checking out our query. We're going to start with the sales table only, bringing in the information we need. First, I'll do a select statement. We're going to do select star for right now. And then we're going to be coming from sales. Now we're actually going to be doing multiple tables in this. So I need to go ahead now and I'm just going to add this alias of S. I can also press tab and it adds that. And then running this, we can start picking out things that I want out of this with this actual table below. I know I want the customer key along with the order date. As always, I want that total net revenue. So I'm going to be doing quantity times net price times exchange rate and giving it the alias of total net revenue. We're going to do one more thing also to get a count of the number of orders. And we'll do this off of the order key. Now, because we do that aggregation, we got to do a group by. And I'm lazy. I'm just going to go ahead and copy this up layer and place it below. All right, let's go ahead and run this. Looks like I got a typo over here. Look at this syntax highlighting, helping out to figure that out. Running it now. Bam, we got our results that we want below. Everything looks like it's aggregating correctly. Now with this table, I also want things like the first purchase date and the cohort year. This is going to take window functions we're going to do. Remember, I don't want to put that in a group by, so we're going to need to create a CTE and then do it. Anyway, what I'm trying to get at is instead, I'm going to move over here to the customer information and we're going to extract some key customer information to put into our source table. So we need that from our customer table. Because of that, I'm going to do a left join, which allows us to keep all that information from the sales table and thus attach any related things from our customer table attached to it. I'm going to give the customer alias of C, and we're going to link this on the customer keys of both tables. I'm going to just run this to make sure we have no issues. Okay, it's running just fine. So what information do we want to add on? I'm going to do a C.star so we can add all of it on. Then we're going to actually refine it down. And it's telling me I need the C.customer key in the group by. We won't have to keep this, but this will just help clear up this error that I'm getting from using that. Let's try that again. All right, so now scrolling over, we can see that we start to have the customer information in here. So I want things like the country full, the customer's age, the customer's given name, and then also their surname. And that should be it. Now we need to put this all in the group by because remember we're doing an aggregation right here. So I'm going to come down here and actually put that underneath here. Clean this all up, and then we don't need this customer key anymore, I don't believe. So I'm going to remove that. Now let's try to run this query, make sure it goes, and everything looks good. We have all those different columns in it. Okay, now what we need to do is extract out for all these different customers here, what is their cohort year or the year of their first purchase. So what I'm going to do is put this all into a CTE. I'm going to indent this over and then also space it down so we can put that with. And I'm going to give it the alias of customer revenue, assign it as, do an opening parentheses, and then finally a closing parentheses. Then to make sure that this is all correct, I'm just going to do a select star from our customer revenue. Running this, we can see that, okay, it is providing the exact same information that we had before. We're on a good path. Now we need to do window functions in order to basically use that order date to get what is the minimum order date for a customer in order to assign that cohort year. So for this, I want everything from our customer view table. I'm actually going to give it the alias of CR, and I'm going to do CR.star. And then I want to get that minimum order date. So we're going to do minimum, specifying our order date. There's a window function, so we're going to do over. And then we want to partition it by the customer key. So like 180 here, we want to look at that and see what is the minimum of this. And then we're going to give it an alias of first purchase date. Okay, let's just go ahead and run this to see how it's doing. And we can see, so something like rows 2 and 3, we should see for, I got to expand this out. We should see the minimum order date is 2018 in this case, so also it's 2023. So the cohort year for this, or the minimum purchase date, should be 2018, which it is. Now we can go ahead and build another column for cohort year. And all of this is going to be is just a copy, if you will, but we're going to be using extract. And then with that, we're going to just be copying the contents above of that minimum order date, pasting it in here, and then giving it the alias of cohort year. Let's go ahead and run this. Rushing too fast, I realized, okay, I have to extract something from that window function, right? I have to extract year from the Windows function. So now let's try to run this. We can now see that for customer 180 in rows 2 and 3, it is in fact the cohort year of 2018. This is good. So now let's create this into a view that we can then reuse. I'm gonna go ahead and enter a line down here. We're gonna use these keywords of create view. We're gonna name this cohort analysis. And then once again, we'll use that as. We don't need to put it all in parentheses though. Okay, let's go ahead and run this, pressing Command Enter. And it ran in super fast. The view is, if it's not appearing, remember we need to run F5, and now it's appearing underneath here. Shows all of our different columns in here on the ER diagram, also on the data tab. So now with this analysis, it makes it super simple. What I can do is just create a new, well, I need a new script. So I'm gonna say a new script here. Let's say I wanted to analyze something like the total revenue per cohort. It's super simple now to do with this view. I specify obviously that cohort year, the sum of our total net revenue, and then we want to do this from our actual view, which is our cohort analysis. We did an aggregation, so we need to do a group by, specifically on that cohort year. Running this, we can see our different results. I didn't do an order by, I'll just actually use this in order in descending order. And so now in a super simple query, I can get that at a lightning speed because I don't have to do all that other analysis that I did before in that view because it's already captured. Before we wrapped up this lesson, this is a future Luke, as you can tell I'm in a different flannel. We made a little bit of a mistake in our view, specifically with naming a column that with the number of orders. I didn't give it an alias. What do I mean by this? Okay. Going into cohort analysis, anytime I want to use it, I'm going to press F5 to just make sure that it's fully up to date. And if we go into the data, we can see that everything looks like it's fine, except here for this column, this is the number of orders, but we left it unfortunately as count. And that's not a descriptive name. We really need to change that to a more descriptive name. And so this problem actually comes up quite frequently. So this is actually a good use case to go through. Anyways, remember under properties and underneath source, we can see all the different code. Now, unfortunately, with this command right here, create or replace view, previously we just saw create view. Create or replace allows us to replace it if it already exists. Now, unfortunately, I can't come through here and update count here as num orders because that's what the alias I want it to be. And then this count down here as num orders. And then if I wanted to run this, if I clicked save down here, it allows me to say, hey, do you want to execute this? It says cannot change the view column count to num orders. Instead, you should use something like alter view or rename column to change the name of the view instead. Now, alter view is a great thing to know of and what it can do. You can go through and add additional columns, remove columns, and in our case, rename columns. So we're just going to use this syntax to rename it, but that's only going to be a partial solution. We'll see. So we'll use the keyword of alter view. We'll name the view itself of cohort analysis, and then we'll use rename column. Also, they have the syntax highlighting saying that it's wrong because the table reference expected. Don't worry about this. It's actually a false warning. It's not correct. And so what column do we want to rename? We want to rename that count. And what do we want to rename it to is num orders. Now going ahead and run this, Command Enter, looks like it ran fine. When we come back over here, we can see that it has a star next to cohort analysis. That means it updated. So we need to press function F5. We need to select inside the database navigator, press function F5 to make sure that it updates. And I would actually recommend just closing out of the old one because we've changed some properties in it if you didn't do it already. And so we don't want to mess with this. We want to see what the newest one looks like. So it says, hey, do you want these changes to persist in the database? No, I don't want them to. So clicking cohort analysis again to get the newest up to date, we can see that, okay, it didn't change count up here, but it did change it down here to give it the alias as num orders. And I'm a perfectionist, and also this is just good practice in general. I want to change it in both locations. In order to do that, we actually need to drop this view, like dropping a table, and then create this view again. So what I'm going to do is just copy all of this code. We don't need this alter view script anymore. I'm going to go ahead and paste that in here. Remember, we want num orders right here. And then down here, since we're actually using it, we can actually just remove it. Now, before we run this create or replace view, we need to actually drop this view. This one's simply written drop view. And then we list the view name of cohort analysis. I'll put a semicolon after this, and then I just want to execute this entire script right here. So I'm going to press Option X. And it said, hey, it ran those 2 queries and it got done with it. Once again, I'm going to close out of cohort analysis, just make sure we have this. Select inside of here, press function F5, and open up cohort analysis, looking inside of our source. And we can see that it updated num orders in both locations. So crisis averted with getting that column up to date and keeping our query concise. All right, now we have a few examples for you to go through and get more familiar with creating views. We'll be using some of the previous examples that we've done in previous lessons in order to build views with, so you can reuse them. In the next lesson, we're going to be building further on this view that we just built in order to answer that second question in our project to further analyze the cohorts. All right, with that, I'll see you there. Welcome to the second lesson, and in this one, we're going to be diving into a question for our project. Specifically, how do customers in a particular group generate revenue? Regarding that particular group, we've broken it into groups before. Doing cohort analysis is what we're going to continue on from this. Now, spoiler alert, for this analysis, we're going to be looking at the different cohort years and at the customer level, seeing how they spend money, specifically seeing how they spend over time, if you will. Generally, it's good practice to have customers spend more because it means more money. And so we would expect that over time, a company would learn and be able to extract more value out of customers. Unfortunately, we find out just the opposite. So let's quickly re-examine what we've previously done on cohort analysis. I'm not going to walk through this entire query. We did this inside of our window functions chapter. And with the results of this query, we were able to plot out and see what is the impact of a cohort on future years' total revenue. So as expected, net revenue is going up and there's contributions to these net revenues every year from previous years. Specifically, members of previous year's cohorts, because your cohort year is based on your first year purchase. So honestly, this didn't really uncover a lot for us, as it tell us really that much. We went even further and also did an analysis looking at the number of total customers. And from this, we saw that it went up as well. Once again, not a lot of insights from this. So what do we need to do? Well, using our previous view that we created in the last lesson, we're now going to take that a step further. And we're going to analyze for the total revenue and the total customers, but then finally get what is each individual customer's revenue, well, on average at least. So let's jump into building this query. For this, we're going to be using that cohort analysis. I can dig into it and see that it contains all the same values that we did in the last lesson. But from this, I want to get, based on the cohort year, what are the total number of customers using that customer key, and then also that total net revenue for that cohort. So for this, I'm going to start a new script, and I'm going to go ahead and fill in the from, specifically from cohort analysis. And I like to do this mainly because when I go to fill it in, if I do something like cohort year, which is what we want, one, I can see that this column does in fact exist, and also it does the correct syntax highlighting as I go along. Now with this, we want to get the total customers per year. So we're going to do a distinct count. So I need to do count or distinct inside of count, specifically on that customer key. We'll give this the alias total customers. Now we need the sum of the total revenue. So inside of our sum function, I'll use that total net revenue, and we'll give it the alias of just total revenue. All right, we did an aggregation function, so we need to do a group by on that cohort year. Okay, let's go ahead and run this and just see what we have. So we get back those total customers and then the total revenue. Now let's look at this visually, because I think it's important to understand why we're actually taking this a step further, diving down to that customer level to analyze this. Well, here I've plotted it where the bars are the revenue. So you see it on the left-hand side, and then the line is the count of the total customers, which is over on the right-hand side. As expected, you can see that these lines basically correlate, well, to an extent, to the size of the bars themselves. So simply put, mo customers equals mo revenue, which that's nothing new here, and that's not really any new insights that you'd go to your boss and tell them. We actually need to dive deeper into finding out some key characteristics about the customers to actually give them insights of what their spending habits may be like. So let's get this customer revenue. All we're going to do is take our total revenue up here and divide it by the total customers itself, and then we'll give this the alias of customer revenue. I'll go along and run this query, and now we have the customer revenue on the cohort year. Just a shout out to that views table. Look how simple this query is now that we have the data in that view that makes this super quick to actually do this. Anyway, back to actually exploring this customer revenue over time. We can see that it's basically dropping over time. Let's look at it visually. And with ChatGPT plotting this, I have it showing that over time, these customers spend quite a bit, I'll be honest. They're at around $3,000 per customer, but then it starts to go down. This is a exponential trend line that I had ChatGPT put on there. Anyway, this is concerning that customer revenue, or the per cohort year, their revenue is dropping year after year. I would expect, like I mentioned at the beginning, that either remains the same or goes up over time. That's not necessarily a good thing for this. Now, I will say this. Remember that older cohorts, so we'll say in this case, cohort 2016, they have all these years to contribute to their cohort. So you could be part of cohort 2016 and also buy something in 2024. And so I would expect in general that earlier cohorts would have a higher customer revenue. So we need to adjust our query to account for this. But you may be like, how the heck do we do this? Do we use some sort of window function and limit the time of each of the cohorts? And what is that? Is it like 1 day or 1 year that they're in their cohort that you allow it to attribute to the customer or to the revenue for that cohort? Well, I actually did some further analysis on this. You don't need to actually run this query. And what does it show? Well, we're not going to walk through step by step all the parts of the query because that's not important. The main thing is what it provides out of it. And that's that what I have it plotting, or what I had it do, is go out and calculate what contributes to the total revenue based on the days since this first purchase. So in total, about $127 million were spent on day 0, i.e. the day of the first purchase. And then after that, it dropped significantly to like 31,000, 51,000 and whatnot. Anyway, with this total revenue, I went and took it a step further and put it into a percentage. And we can see that it goes from 61% to less than 1%. I also plotted it for more of those visual type. And so what we can extract out of this is that in general, or on average, a customer spends, for the total revenue that it spends about 60% of it on the first day, and then minimal after that. So what we'll do is go back in and adjust our query to take account for this. And for a cohort year, we'll only look at the revenue for that cohort year if the purchase was completed on their first day, and we won't take into account anything else because the majority of purchases are done on the first day. So how can we do this? Well, conveniently, in that view that we created, we have not only the order date, but also the first purchase date. So we can use those two dates and match up where they're equal to each other to only get those purchases. So I'll put a where statement in, and we'll set the order date equal to the first purchase date. And that's really all we have to do for this. Now pressing Command Enter, we have some updated results, and it looks like our customer revenue dropped a little slightly. And plotting it, we can see, yeah, it drops down slightly below 3,000, although it was before around 3,000. Anyway, the main thing here is now whenever I have this exponential trend line, which I thought that you thought like with removing those previous years that had more spending, actually it's more pronounced that the future years, such as 2022 and 2023, spend even less. So this is a pretty big breakthrough that we've come to basically uncover in this, and could lead to, especially at the trend that we're going at right now, this could have serious implications on the business and would be a great insight to bring up to our superiors or to our stakeholders. So that's the end of what we're doing for answering this question on analyzing customer groups, as I feel like we've found a pretty significant insight with that. What we're going to be doing in the practice problems is actually going in and doing an analysis of the revenue and the total customer count, but looking at it over time on a monthly basis to get to find out why do we have certain years lower than others, and to uncover other insights that I'll detail more in the beginning of the next video. After you get done with those practice problems, we'll be jumping into installing VS Code, which we're going to be using to document the insights for our project. Specifically, in the next lesson, we're going to be documenting what we learned from this question specifically. With that, see you there. Welcome to this last lesson as we're going through this chapter on an intro into our project. Specifically for this, we're going to be going through and setting up VS Code. Now, as a refresher on why we're doing this and not using something like DBeaver, DBeaver is great at actually going through, writing SQL queries, analyzing them, and improving them. But when it comes to actually sharing it and collaborating with others, using things like GitHub or even documentation tools like Markdowns, it gets quite hard. So for both my workflow and Kelly, we like to use this in cooperation with VS Code. And this code editor is going to allow us to do two major things for this. The first is we'll be able to build a README or a Markdown file that will document all of the different analysis that we've done whenever we want to go and share this. And the second, it makes it super easy to push this up to GitHub and share it with others to see the work from our README or Markdown file. Now, if you take my basic SQL tutorial, you'd probably have VS Code, so you could skip that portion of the lesson, but we will be going on to how to actually build out that README specifically for question 2, which we answered in the last lesson. But before we jump into that, we're going to quickly go over the analysis you did in the practice problems that we uncovered even further insights. In the last lesson, we went through and evaluated how do different customer groups generate revenue. Specifically, we broke it down by cohort year, and we found out what is the average customer revenue per cohort year. At this macro level, we were able to see some call out specifically that there's a general trend going down per each customer revenue, which is not good. And so as our practice problem assigned, you went further into analyzing why do we have these dips? Was there something deeper going on in the data set besides just customers spending less? So to catch people up that didn't do the practice problem, we went through and analyzed customer revenue and total amount of customers on a monthly basis. We got this final table, which has that total revenue, total customers, and then the customer revenue. Let's start with the customer revenue first, because we've just been talking about that. As we saw in that last lesson, we saw that it's slowly going down over time. So analyzing it at the monthly basis, not really helping out that much. Now, if we look at something like the total revenue and the total customers, and we plot this, we get something like this, where the blue bars are the monthly revenue and the line chart here is the total number of customers. So looking at general trends overall, if we were actually plot a line of best fit, we would say, or we would think that our revenue is going up over time, or our net revenue is, with the exception of a pretty big dip down in 2020, probably due to some sort of pandemic that happened during that time period. And then it rose after that. And then it was slightly less down in 2023. Anyway, the major insights that I think are applicable to us from that last analysis is, if you actually look at it, how we said previously, more customers equals more revenue, it does match up. But then when we get to 2022 and 2023, we can actually see that there's pretty large gaps in between here. There's a lot of customers, but the revenue is not matching, which helps us explain even further what's going on in this graph. Basically, yeah, we're getting higher number of customers, but customers are spending less. Anyway, pretty interesting insight on this. Let's get into installing VS Code. If you navigate over to the link on the screen, you'll get directed to the download page for Visual Studio Code. More recently, Microsoft has been advertising this with GitHub Copilot. So it has this, hey, it's redefined with AI, and they're really pushing that. We're not going to go too much into AI features. We're just going to be downloading this code editor. You should download some sort of file, click it, get it launching. And in the case of Mac, it unzips this file and it's automatically the Visual Studio Code app, which I can just take and drag and put into my application folder. So it's in a much safer or secure location. If you're on a Windows machine, it's going to walk you through an installer, so quite a bit more steps, but it'll actually direct you on where you could actually put this VS Code and if you want an icon. Anyway, regardless, you get a system message asking if you want to install this app that's installed from the internet. Yeah, you're fine with it, open it. Upon launch, you'll get this welcome message that will actually guide you through a step-by-step process that if you want to do, you can do, but we'll be covering all the key features you need to know for this, so don't feel like you have to do this. So let's briefly explore Visual Studio Code before we actually get into installing or setting up our projects folder that we're working with. Over here on the left-hand side is our activity bar, and whenever we press our activity bar, a sidebar slides in or out depending on if we want it there. This first one's an Explore. We don't have a folder open yet. I'm just going to open a dummy folder. You don't have to need to do this. And anytime you're opening any of these, it asks if you want to trust the authors. I'm opening from my own computer. I trust myself. I think so, at least. Anyway, this basically shows a file breakdown of what's inside of this folder. And then folders themselves have these carets that you can drop down or open not if you want to see inside of it. If I actually want to see these file locations, you can just right-click it. And then on Mac, it's Reveal in Finder. On Windows, it's going to be Reveal in File Explorer. Anyway, you can see that the structure of this is the same as what we're seeing over here in that File Explorer. All right, other things in the activity bar, we have a search functionality. So if I want to search SQL, all the different occurrences will pop up here, and I can go to it, and it will take me right to it. Next is on source control, which controls how we're going to get this onto GitHub. We'll be covering more of this and interactions with GitHub near the last chapter or in the last chapter, so don't worry about this too much. Oh, and I guess what I forgot to mention previously whenever this popped up, over in this right-hand side, so if I'm to close this sidebar right here, this is our code editor itself. So if we actually open back up, and open that second query, I'm going to close this now. We can see, I'm going to actually expand this by pressing Command plus or Control plus on a Windows. We can see that we have that SQL query right inside there. And if I needed to add anything, like I did want to use an alias right here, I could just type it in. And then now we're noticing that up here in the top, there's this white dot appearing. That means we have changes this, is not saved. You can just save it by pressing Command S or Control S. Now, what we're going to be doing later on is actually going into the README and building this README out. And what I really like about VS Code is, as you can see, we have all this fancy dancy markdown language typed into here. And if I wanted to see what it actually looks like with the README selected, I could select this right here, and it allows me to preview the README with all the different images and whatnot right next to it as I'm scrolling through. So one of the main benefits why we're using VS Code. All right, I'm gonna go ahead and close all this out. Also gonna zoom back out so we can see everything. Okay, last two things, they have a debug, run and debug section. We're not gonna be using that. And then finally, extensions. It's really popular if you're using this for a particular programming language like Python or whatnot to have the appropriate extension installed. So in this case, you install Python to use Python. We're not gonna be running SQL from VS Code. We did that back in the basics course. So overall, there's not a lot of extensions or really any that I think you need to install for this. If you do want to install one just to see what it's like, I recommend this one on Code Spell Checker. When I click it, it opens right up next door. And if I want to install it, I just click install. It asks if I trust this publisher. Yes, I do. And now I have this code checker inside of here. So if I actually went back to that SQL file we had previously, it will now go through and flag some of these keywords that don't have an underscore, and it calls it an unknown word. You can actually go through and try to do a quick fix with it. But those are the column values that came with the database, so we're not going to change them at all. Mainly, I find it useful for if, say, I need to create a new alias and I'm going through it, and I'm wanting to sum something like total customers and I assign the alias. If I were to assign an alias with misspelling in it, like this, when butchering customers, it's actually going to call it out, and so I know that I misspelled it there. Anyway, that is extensions. No, I don't want to save any of this. The other two things in the activity bar to be aware of are your account right here, and then any settings. Specifically, what I find myself gravitating towards using a lot is this command palette, which has the shortcut of Command-Shift-P or Control-Shift-P. That's the one shortcut for VS Code I would highly recommend having memorized. When I do this, this search bar comes up at the top, and then I can search any type of settings I want to change in VS Code. So say I want to change maybe the color theme of this. I would type in something like color. Oh, I can see that I have preferences, color themes, and then it allows me to go through a menu and select a host of different options in here. The last thing to note is the status bar down at the bottom. We won't be using it too much. Like in our case, right now I'm zoomed in and I could go back and reset it. It'll also have information down like the left-hand corner for using Git, and then if there's any issues going along with it. Let's now get into setting our projects folder up that we're going to be eventually pushing to GitHub. We're going to be setting it up, building out our README, and also adding all those SQL files or the last SQL file from the last lesson. For this, we want to open a folder that has our project in it, but we need to create a folder, if you will. Now, back in DBeaver, if you remember, we created a project folder already, and it has bookmarks, dashboard, diagram, and even all of our scripts in it. I'm not about reinventing the wheel. I think we should just use this project right here as our project folder itself. So we can do this a couple different ways. I want to find the location of this, so I'm going to right-click it, and I'm going to say, hey, show resources in Explorer. Now this is the projects folder. I'm actually going to back out just one location so that we can see. Okay, so this is the folder itself of this intermediate SQL project along with those folders underneath it. I want the file path location to this. Specifically, I want to go to this folder location when we go to open this in VS Code. So I'm going to open up a folder in VS Code. On Macs, unfortunately, the folder location that this is within is hidden. So I'm going to hit a shortcut of Command-Shift-, and I know in my home folder of Luke Barousse that it's in the library folder. And then from there, I can navigate to the DBeaver specific folder. Going into my workspace, I then see the project itself, and then I can open it. It's going to ask if you trust the authors of this file in this folder. I do. I'm also going to just enable this to trust the files in all folders within here. So now we have inside of our Explorer right here, we have a few different folders, if you will. I'll be honest, we're not going to use many of these at all, actually. One thing to call out is you may visually only see the bookmarks, diagram, and scripts, but then we also have these other, they're called dot files. And once again, if I press Command-Shift-period on this, we can see these dot files. They're actually just hidden files. I'm going to maintain them hidden by pressing Command-Shift-dot. Anyway, key thing here is those folders and files aren't important. Along with, we can be selective on what we actually put into GitHub. So we will need to be, because we don't really want to put these up there anyway. Anyway, let's make our first file. We come up here to the top and we select New File. I'm gonna give this the name of 2_. I like to do 2 to basically designate, hey, this is the second question, and call this cohort analysis.sql. And as you notice, as soon as I name that SQL file, I got this new icon right there that shows me it's a SQL file. When I press enter, it automatically opens in the text editor to the other hand side. What I can do is now copy that query that we did previously, and then inside of VS Code, paste it all in. I have this white dot saying that it's not saved, so I can press Command S or Control S, and it's now saved in there. So I'm gonna go ahead and just close this all out. One thing to note, inside of DBeaver, underneath that projects folder itself, we're not seeing any of the different files pop up like we just created that SQL file. That's because we haven't refreshed it. If I actually right-click, select refresh, the query now will appear inside of this project folder. If you're clicking refresh and it's not refreshing or showing that, I actually had to just restart DBeaver to get this to work. So yeah, just word of warning. Anyway, this SQL file is now here, and so I'm actually going to close out this script and this one. So if I wanted to, I don't necessarily have to go back into VS Code if I really want to edit it. I could edit it from right here. Say in this case, I call this CA. And then I save this, pressing Command S. Whenever I come back in here and actually check this SQL file, I can see that the alias got added. I don't want it. I'm going to add Command S. So let's get into building our README file. As a reminder, that's going to be basically the front page of our project, detailing all the different analysis we did, breaking down each of the 3 questions that we've gone through or will go through. Now, key things to note for GitHub, we want this file to be called readme.md. And that's because GitHub will specifically pick up on this naming convention and then display this below here. So we'll get into creating a file. I'll call it readme in all caps locks. Then this icon changes to that readme icon. And for the file, it's a markdown file. So I'm going to give it MD. And then go ahead and press enter, and it's open up right next to it. First thing I'm gonna do is just start by giving it a title. Remember, we can do different headings depending on how many hashtags we have. I'm gonna give it this one of Intermediate SQL Sales Analysis. But what the heck does this actually look like? We can click this icon right here for it to appear right on that right-hand side. So as we go through and type different things, we can see how it is actually formatted as we go through this. Now, what sections are we going to be putting into this? Well, really, it's up to you. You don't have to follow all or even any of the things that I'm going to put into here. But I'm going to recommend these major sections. First, we're going to have a short little overview. Then from there, we'll get into our 3 business questions, just giving the short description. And then from there, getting into the analysis approach, breaking down each one of those. We're going to be doing question 2 on the cohort analysis, and I'm going to walk you through that shortly. Now, below these 3 questions in the analysis approach, I only included one example right here. We're going to have our ending, which has things like our strategic recommendations, what we've got out of this, and any technical details of what we actually used to build this. So let's start going through and filling this in. We're going to start with business questions here. I'm going to put 1, 2, and then 3. For the second question, we did a cohort analysis. And with it, we were asking, how do different customer groups generate revenue? Now, I'm not really liking how this is formatted, so I'm gonna use some extra markdown in here, putting double asterisks before and after cohort analysis, and then it like bolds it, makes it stand out more. So now let's go into filling in the analysis approach, that second question. I'm gonna go ahead and just copy this one right here, paste it below, and we're gonna start going 2. For this, I'm gonna title this section Cohort Analysis. Next, we need to put in an analysis approach that we actually used here. So I put some short bullet points in here of how we track revenue and customer counts per cohort. What is a cohort? Is that we're grouping it by year of first purchase, and we analyze customer retention at the cohort level. The next thing I'd like to include is the query itself. Now you can go ahead, instead of doing a link, we're gonna go over links shortly. You could put in a code block. So I'm gonna just do 3 backticks in this case. You can find it up here, top of your keyboard. Anyway, I could just copy this query right here and then put it into our README, and it's displayed right here. I could also format it as SQL by putting SQL after those ticks, and then it's getting color coded like this. Oh, this is all smushed. I'll be honest, I'm a fan of DRY, or do not repeat yourself. We already have this code somewhere, so I'm actually not gonna put that right here. Instead, what I wanna do is put a link to this SQL file. And we can do this by putting square brackets, and in square brackets is what the text is gonna be. I'm just gonna name it, the name of that file. And then in parentheses is the actual file location. On a Mac, I'm gonna press backslash. I think in Windows, you can press /. And then all the different things that I have access to are gonna appear right here. I'm gonna select that first one of the SQL file. And then, yeah, now over here on the right-hand side, I can see whenever I click it, oh, the file itself actually pops up, so I know the link is working properly. And these links are also gonna work on GitHub when we get there. All right, next section I have are on visualizations. And that's if you've generated any images. You don't have to do this per se, but in my case, I really like doing this. So what I'm gonna do is I'm gonna come over here and I'm gonna create a new folder and call it images. I like to organize all my images in one location. So I'm gonna take that image, it's on my desktop, I'm gonna drag it over into the folder itself. It's right here. Conveniently, it's just named image. I'm actually gonna change that by right-clicking it and selecting rename and call it this of 2_cohort_analysis. Okay, now going back into the README itself, the image name is just the alt text you can put with it. Mainly, we need to be more pertinent about what the actual image name is. Once again, I'm gonna slash backslash, and then from there, I wanna go into the images folder, and I want to select 2-cohort analysis. Oh, it's popping up right next to it. No, I'm good. After this, we're going to dive into key findings, and I'm going to summarize this, calling it the main points that revenue per customer shows an alarming decreasing trend over time. I call out specifically the 2022 and further years are just declining over time, although net revenue is increasing, is likely due to a larger customer base, which we found out when we did deeper analysis. And this finally brings us into the final section of what are the business insights. And so for this, I have the following, that the value extracted from customers is decreasing over time and needs further investigation. We need to find out what is the root cause of this. In 2023, we also saw a drop in the number of customers. And so we also saw a drop in revenue. Because of these 2 facts alone, the company is facing a potential, or actually what we saw in 2023 is seeing a revenue decline. So overall, this is a good step in the right direction on what we need to recommend on where we need to go. All right, it's your turn to now go through and build out that README document, and hopefully you've been following along with installing VSCode and whatnot. We do have a few practice problems for you to go through and get more familiar with VSCode if you want that practice, along with we're gonna have that template for you available in order to build out this question number 2. All right, in the next chapter, we're gonna be getting into data cleaning, my favorite part of data analysis. So I'll see you there. Welcome to this chapter on data cleaning. And in this, we have 3 lessons we're gonna be covering for this. In the first 2, we're gonna be covering some core concepts you need to know about data cleaning. Specifically, this lesson, we'll be going over conditional expressions for handling nulls, things like coalesce and null if. In the next lesson, we're going to be going over strings, because from time to time, you're going to be dealing with strings and you'll need to clean them up and maybe put them together or even separate them. At the end of that lesson, we'll be applying all the concepts we've learned in order to further refine our view on cohort analysis. Finally, in the 3rd lesson of this chapter, we're going to be getting into answering question 1 from our project, which focuses on customer segmentation. Now, our project consists of 3 questions. And in the previous chapter, we focused on that 2nd question on cohort analysis. In this one, we're going to be using customer segmentation in order to find out who are our most valuable customers. And we're not only going to be using that cleaned up view of cohort analysis to help answer this, but also some functions we learned earlier on statistics. So we're going to focus on two functions for this lesson. And you may be like, Luke, how the heck did you pick that out? Well, if we go into the Postgres documentation underneath the SQL language, we can see that underneath the functions and operators, there's a host of different ones that we've covered. If you've covered along since the basics course, we've covered and touched on a lot of these. And we actually have covered on conditional expressions. Navigating under this, we can see that for Postgres, there's 4 main types. And the main one is case, which we covered back in basics. But there's 2 more that we need to cover around coalesce and null if. Now, Postgres has this one on greatest and least. These functions have different capabilities depending on which database you're working in. Also, Kelly and I don't really use this as much, so we're not covering greatest and least. Anyway, let's get into how we can actually use coalesce and null if in a very simple example. You don't have to follow along with this. I'm just doing this for demo purposes. So the easy way to demonstrate this is with a fake table I'm creating here. I'm calling this a data jobs table. It has 3 columns in it. Technically 4, I guess, if you count the ID. And what does it contain? Well, let's just run this query to actually see. We get this table, and in it we have things like a job title, a column on whether is it a real job, and then a final column on salary. Notice inside of here that there's some null values in here. We're going to be using coalesce and null if in order to clean these values up depending on what we want. So let's say for this column on is real job, we wanted to fill in null values. Specifically, let's just assume that the database administrator assumed that all null values were no, but we needed to make it no. Well, we can use the coalesce function. And in this, it returns the first non-null value from a list of expressions. Right now, we're just going to use 1 expression. We'll move on to 2 after this. But we can provide a default value in this case of no. And ultimately, in our case, this is going to be used to replace a null value with a default value. So here is a query that returns back our original table. Let's modify this to fill in null with no. So I call that coalesce function. For expression 1, I leave it as the column of is real job. And then for the default value, or the last one, we're just going to put in no. Let's go ahead and run this bad boy. Oops, forgot to put a comma. Run it again. Okay, we can see now we have this column called coalesce after the function, and it's filled in yes, no, kinda. A better practice would be to actually assign this an alias when done, so that way we can actually see it. And bam, we have the updated column title. Now, what's going on here with that coalesce function where we have this second expression? Well, let's say we wanted to fill in this null value for salary, but we didn't want to use a default value. We wanted to just fill it in with, if it's null, maybe just put in something like the job title. Specifically, depending on where it matches up, you would fill it in for the appropriate row that it comes from. Let me demonstrate it. Okay, so we're going to use that coalesce function again. We're going to leave salary in there. And then for the second column, we're going to specify a job title. I'm going to leave the default value blank for right now. Finally, I'll give it an alias of salary, pressing Command Enter. Now, whenever I run this, I'm going to make this a little bit bigger. It says error, coalesce types integer and character varying cannot be matched. The problem is salary is an integer and job title is a string. So anytime you're using this to have a column replace the other, they have to be the same data type. In this case, we'd have to cast salary as a text or varchar in order for it to match that same one that has job titles. Now, when I go ahead and run this, it actually works below. And we have, in fact, filled in the appropriate column from that job title into salary. You could put a default value in here. I'll just name it default value. But in our case, when running it, not going to come up. So let's reset this back so we can get into null if. Now with our original table back, say we had a scenario where we knew certain values weren't correct or we didn't want them in there and we wanted to make them into a null. And like in this column of is real job, kinda isn't really an answer. Maybe we want to now make this into something like null. Now with null if, this returns null if 2 expressions are equal, otherwise returns the first expression. And this one's even more simple in that it can have either expression 1 or expression 2, where they can be either columns or single values. Let's jump into it. So let's say we wanted to replace this kinda with null. We call our null if function. 𝗖𝑺_real_job would be expression 1, and then expression 2 would be that kinda. As usual, I'm going to give this the alias of 𝗖𝑺_real_job. Okay, let's go ahead and run this. Okay, we in fact replace that kinda with null. Now you don't also have to just do a default value. I could do, like I said, an expression, so I could do another column. So in this case, I could do salary. Once again, I got an error message and it revolves around having a mismatch between the data types. I can just fix this by casting salary as a text, running Command Enter, and bam. Anyway, the point null if, right? None of these, comparing these as it goes through, none of these match. So it doesn't convert any of the values to null. This value was always null. Anyway, let's jump into some real world practice problems. Now, previously, whenever we've been doing any of our analysis, all of our customer keys have conveniently always had some sort of purchase associated with it. What we're going to demonstrate is that all the customers in that customer table don't necessarily have an associated purchase with it. And whenever we merge them together, they can actually have non-values or none values or null values. Now, if we were to run an average to find out what is the average net revenue per customer, whenever we just have these non-values, they're not going to be counted. But say we do want to count them because, hey, they are customers and we want them to be 0 instead. That's going to affect the average overall. And we'll actually get to demonstrating how much it's going to change the average revenue per customer. Quite a bit. Now let's get into combining our customer keys with net revenue to show those customers that don't have any purchases. Previously, we've gone through and in our sales table, got the customer key, got the net revenue by multiplying quantity times net price times exchange rate. Then obviously we're doing a aggregation. And so we need to group by customer key. Now running this, we have net revenue for all these different values in here. If I try to filter to find any net revenues that are null, if I go to run this, we'll see that down below, there's no values in there. So we hadn't been seeing this previously. But what we can do is with all of these revenues that we have right here, we could merge this onto our customers table, and then this will expose customers that don't have a net revenue. So what I'm going to do is convert this into a CTE, use a with statement, calls this sales data, and then assign it in parentheses. As always, I like to make sure that this works, so I'm just going to select star from sales data and go ahead and run this. Yep, working below. Now what we want to do is, I'm actually going to go into 𝗏𝗏𝗄𝑗, is take that customer table that we have here and merge onto it that sales table. So we're going to make the customer table our A table and then sales table our B table. So what we want to do is using our customer table, use a left join to join on our sales table. So I'll move the sales data down. We'll say that this is going to be the left join and we'll give it the alias of S for the sales data. And then for the from, we're going to be doing from customer with the alias of C. Let's go ahead and just run this to see if it's working. And I got this error message saying syntax error at end of input. Basically, I didn't say where or on what we're going to actually merge on. Specifically, when we merge on the customer key of both of these different tables. Okay, let's try to run this now. All right, we have the customer keys and all the information from the customers table. We don't need all this information per se. We just want to make sure we have all the customer keys along with all the different net revenues. And as you can see, there are now null values in here because there's customers that don't have net revenue. So let's modify what we're actually bringing in here. We're bringing in from the customer table, the customer key, and then from that sales data CTE above, we're bringing in net revenue, running this. Boom, simplified version of actually being able to view this. So first, let's fill in these null values with a 0 just to demonstrate it in a new column. We're going to call that coalesce function, running that on net revenue. And we want to place those nulls with a 0. Running Command Enter, bam, we got this over here. So not bad. Now what we want to do is to show the difference between these, we're going to run an average on only net revenue and a average on the net revenue with zeros filled in. So basically all customers. I'm going to remove that customer key so that way we don't have to we want to do an average on all of that. So I'll call the average function on that first column and an average on that other second column for 0 filled in for the null values. Running this, we can see that the averages are quite different, right? So the first one is around 4,000 and the second one is less than 2,000. Now these names for columns aren't that descriptive. So I'm going to name the first one as spending customers average net revenue because they've spent money. So that's only the customers that we use for this. And the next one is all customers average net revenue. Now running it, more descriptive titles for this and viewing it visually, we can see that when we look at all customers, the average net revenue is actually less. Now this was mainly done for demonstration purposes because there may be situations where you do want to consider all customers. In our case, we are going to just consider only the spending customers in our analysis and not necessarily all customers. So that's coalesce. We're not going to do a real world example of nullif because it's going to be frankly very similar, except opposite, if you will. But what I have are practice problems for you to go through now and get familiar with both of these options. In the next lesson, we're going to be jumping into understanding how and all the different functions for formatting strings. So with that, see you there. And in this lesson, we're going to be going over further on data cleanup, specifically around strings, how to format them. We're going to be covering 4 key functions that I find myself using from time to time. And then from there, going into modifying our view that we created on cohort analysis. Specifically, we have columns on a first name and last name. We're going to combine it into one. Let's get into it. Now, in the last section, we were looking at function operators, specifically going down here. We were looking at conditional expressions. In this one, we're going to be going back up into this section on string functions and operators. Now inside of here, there's a host of different functions and operators that we can use on strings. And the first one we're going to be jumping into is this one here on lower, how to convert something to lowercase. Now with any of these functions, they're going to take string values. So in that case, I'm going to do that lower function and I'm just going to put a string in there and we'll just put my name in all uppercase. We'll go ahead and run this. We can see it outputs it below in all lowercase. If we have lower, we probably also have something like upper. Running this, we can see that it's all upper. This would usually be in the case that you have some lowercase values in there and it would raise it all up if there were some lowercase values in there. The next is the trim function. We're focused on the one up here. This one down here is a non-standard syntax, so we're not going to use it. And from this, it relieves the longest string containing only characters. And by default, it's a space. Let's actually just look at this real quick to understand what's going on. So in the case of our example, if we're using this trim, right now, whenever I run this, Command Enter, there's no really change in this whatsoever. Now, let's say that there was a space at the beginning and we'll do a space at the end. Running Command Enter, you can see that there's no spaces when if we were to just run it without this trim function, I'm gonna go ahead and actually just remove this, running Command Enter, we can see that it does in fact enter spaces in there even when I check it. So using this function is very important, especially whenever you're working with databases with very dirty data and you need to remove any different spaces. Now let's say that we had some symbols in there, like we had dirty data and we had some symbols surrounding this that we wanted to actually remove. In this case, I have 2 ampersands around each. Whenever I run this, Command Enter, we can see we have this, but we want to remove that from here. Well, going back to this definition of it, we can specify whether we want to trim based on the leading, trailing, or both, being the front or the back of a string. And by default, it does both is the default. Then we can specify the character text, which is what we want to remove, and then from the string text. So inside of here, I could do something like both. I want to remove that ampersand sign, and I'll remove it from this. Let's go ahead and run this. And it removes both those ampersands on the front and the back. Also, I notice that my E is missing in here. Now going ahead and run it. Boom. Now that's what we have. So what we're going to be cleaning up with this view? Well, if we open it back up, go into cohort analysis, we can see underneath that data tab, we specifically want to focus on this, that given name and surname, which would be like last name and first name. Anyway, we want to combine these into just one column. We don't need them to be separated for our analysis. Now, because of this, we're going to have to actually update our view for what we have currently. Now, with this, we're going to be basically removing 2 columns and then adding a new column. So because of this, we can't necessarily just run create or replace view since we're altering columns. We need to run like alter view. But that's even going to get complicated. I'm going to recommend we just start over with this query and drop this view. So I'm going to go ahead and copy this, Command C. And then in here, I'm going to go ahead and paste it. Now remember, we want to combine our given name and surname. I'm actually going to just run this query to show what's going on here. Press Command Enter. I have this as in front of here. That doesn't need to be in front of here. So I'll move that up top, run it again. Okay, we have all of it, as we saw before, the given name and surname. So we want to combine these two. Going back to the documentation on string functions operators, scroll on down until we get to other string function operators. They have on here the concat function. This concatenates the text representations of all the arguments. Null arguments are ignored. So for given name and surname, what we can use is this with the concat function. Specifically, I'll type out concat, open and closing parentheses around here. So we have the given name and surname, and we'll name this as the clean name. Okay, let's go ahead and run this. And now we can see the names are now combined. Okay, not too bad. Now, one thing to note is, well, we need spaces in here. And sometimes I find, especially with text columns, there may be extra spaces in here. So one, let's just add that space that I'm talking about. I'll do a single quote space, single quote, and then comma, run Command Enter. And now we can see that there's a space in between here. But like I said, sometimes the names may have spaces around them. So just as good measure, I'm going to put trim around both the given name and around the surname. Okay, running this, pressing Command Enter. We now have all the values cleaned up in here, and we did some protection. So now we need to actually update this cohort analysis, where if we went to look at it, remember if we just tried to run this right now, so create or replace view as the cohort analysis, pressing Command Enter, I'm not going to get it because of the column issues that we addressed before. So we need to actually just drop this database or drop this view first. So we're going to call that drop view on cohort analysis and then run everything underneath it. I'm going to run this all by pressing Option X. And it looks like 2 queries are done. As always, I'm going to just close out of this to make sure I have the most up-to-date one. Click inside of here, press F5 to refresh, and open up cohort analysis. Scrolling all over, we can see we have now that clean named inside of here. So our view is good to go now for the project. All right, you got some practice problems now. Go through and get more familiar with these text formatting functions. In the next lesson, we're going to be jumping to another question for a project on customer segmentation. Looking forward to it. See you there. Welcome to this third and final lesson in this chapter on data cleaning. And for this, we're going to be focusing on question 1 for a project. Specifically, this is going to build further on analysis we actually did earlier with segmenting customers, and so discussions on customer segmentation. Specifically, we're trying to find out who are our most valuable customers. For this, we're going to be breaking up our customer into tiers using percentiles into high value, mid value, and low value customers. Now, this is a very typical business process that you would find yourself doing in order to target certain customers and then distribute marketing that fits their need. And so shout out to Kelly for coming up with this example, because I feel it's a really good demonstration of what you find yourself doing as a data analyst. As always, I like to start with what is the final data set we'll be getting for this. And so we'll be calculating, or actually finding out based on customer key and that clean name that we did in this chapter, to determine what is their total LTV, lifetime value, or their, if you will, net revenue. And then based on these values, we're going to use percentiles to categorize customers in either to low value, mid value, or high value. We'll also take this calculation a step further and also dive into analyzing, not only just having those names, that way marketing can target these customers, but also actually understand these values, such as what are the percentages of these different segments, how much are contributing, and whatnot. So let's start a new SQL script where we're documenting this analysis. Similar before, we had our own script for SQL here. I'll go ahead and we'll start a new SQL script. And then I'm gonna go up here and then rename this. We'll name this to _customer segmentation .SQL. Okay, this should be good. All right, now one thing to note, this is gonna be inside of our scripts folder, but we don't necessarily want it here. If I right click this and then go into show resources in Explorer, underneath scripts, I can see it's right here and I actually want it higher up. So I'm gonna move it out. If you're on Windows, you do something similar with your File Explorer. And then down here, it's not actually showing up. I can press Function F5 and that SQL script disappeared, but now I'm actually seeing this one and also README's popping up now. I guess I didn't refresh as well. Anyway, I can now open this back up. This is what the SQL file is we wanna work with. So first 3 columns of interest that we want to get into here. So we want that customer key. We also want that cleaned name. And then from there, we want the revenue for each of these customers or that total lifetime value. So we use a sum of total net revenue and we'll assign this as total LTV. Just as a reminder, going back to that cohort analysis, we could have multiple entries in here, like 180 did multiple purchases on different days and we had that in a total net revenue. So that's why we're renaming this new column total LTV, because now with 180, we'll have the total lifetime value. We want this from our view of that cohort analysis, and we're doing a aggregation. So we need to do a group by using the customer key and then also clean name. So let's go ahead and run this and see what we have. I have no active connection. So if there's a reminder, if you aren't connected, reconnect to your database. And I just need to reselect it up here. Now everything's looking good. Let's try to run this again. All right, bam, this is what we want. Clean name, customer key, and then the total LTV for each of these. I can even do the order by descending, or actually I want to do order by ascending and see that, hey, okay, 180 is now combined into one, looking good. Now that we have this total LTV, we can now bucket these customers into high value, low value, and what's the other one? Mid value. Now we're going to be doing this on percentiles using the 25th percentile and 75th percentile. So because we're using or running a percentile on this aggregation right here, I'm going to put this into a CTE. We'll call this customer LTV and we'll put this in parentheses. From there on this CTE, we're going to run that percentile continuous function. Remember, we're doing the 25th and the 75th percentile. Basically everything between the 25th and 75th percentile is our mid-level. So I'll do 0.25, and then we'll do the nomenclature of within group, because we want to group it by a certain thing. And we need to order the LTV or the total LTV column to make sure we're pulling out the correct LTV as we go through and sort this. And then we'll give this the alias of just LTV 25th percentile. Let's go ahead and just make sure this is right. So I'm going to do a from the customer LTV. Pressing Command Enter. Boom. Okay. 25th percentile is at 843. I did this already. I know that this is actually correct. So let's now get the 75th percentile. I'm going to go ahead and just copy this all because it's just going to take some changing to do to it. And then putting it inside of here, changing that 2 in multiple locations to a 7. And then running this bad boy. Boom. So just so you understand what's going on here, those that spend around $843 are at the 25th percentile. And so if you spend less than this, you're less than the 25th percentile. Whereas the 75th percentile, those are spending around $5,500. If you spend more than this, you're greater than the 75th percentile. These will be our high value customers, and those less than 25 will be our low value. Now what we can do is, let's just go back and I'm going to run just this query up here. Now what we can do, because we have those percentiles, we can use this basically customer LTV CTE, and we're going to convert this percentiles one into a CTE as well. We can categorize or bucket them using a case when statement of whether they're high value or low value or mid value. So we're going to be making this into a CTE. I'm going to tab this over, put a comma, and we're going to name this customer segments. And then once again, opening and closing parentheses. So that way this is in a CTE. From this, we're going to select, and I want all the customers from customer LTV. So I'm going to do we're going to give it the alias of C. So I'm going to do C.star. And I'm going to go ahead and just put this down here of from customer LTV. And like I said, that's going to be of the alias C. And then it'll clear that little syntax error. Let's actually just make sure that everything's appearing right down here. I have a comma after this, so I need to remove that. It's appearing down here. Now we need to go through and now make that case when to basically bucket all of these into their different tiers. I'm gonna move this down some so it stops cutting it off. Okay, we're gonna do a case and then we'll do when. And the first one I wanna categorize is everything less than 25% as low value. So when total LTV is less than this LTV 25 percentile, which I'm realizing now we haven't imported in. Now we don't necessarily need to do a join with this. What I can do is a comma, because we don't need to join it to the data. I can just list it of customer segments and give it the alias of CS. So now it's available. We can say cs.ltv 25th percentile. Then we want to assign it the low value. We're going to do one TAC low value. We stick a 1, 2, 3 at the front just to make it easier if we want to ever sort it. If you just do low value only and then try to like sort by the name alphabetically, it like throws a fit. Mainly meaning you can't sort it like that. Anyway, let's go into the next one. And I'm just going to copy this because a lot of this can be repetitive. And for this one, we want to get everything that's mid value. So everything that is less than or equal to the 75th percentile. So that mid range is going to encapsulate everything that's equal to the 25th percentile up to the 75th percentile and equal to it. And then I'll change this to 2 mid value. Now, since we got everything underneath the 75th percentile, we can now categorize everything else as high value. All right, let's go ahead. I'm gonna remove this space here. Let's go ahead and run this and fingers crossed. I see my issue. I have a syntax error at or near when, and that's because I don't have a comma after here. Also, I never gave this alias or this case statement a name. Specifically, we want to name this customer segment. All right, let's go ahead and run this bad boy. Okay, it's working. Now, let's make sure that these are categorizing correctly. If we remember previously, I'm actually going to just select this one time and press Command Enter. Oh, and I realize now it's not going to let me do it like this, unfortunately. I'm going to just copy this, go into a new script because I want to actually show this. Then paste this bad boy in and run this. And I'm silly, I need the other CTE. Anyway, you don't have to do this. The main purpose of this is just to see what these numbers are. Remember, it was 843 for the 25th percentile and 5,500 for the 75th percentile. Now, running this complete one, are these numbers making sense? Yeah, because 5,500 should be the high value. It's greater than that for the second entry. And then looking at these fall in between. Yeah, it looks overall, let's look for a low value. Okay, we got a low value down here of $203 falling in. Okay, data looks like it's calculating correctly. All right, so this table right here would be great to now export and send to our business colleagues to basically find those people that we want to target. I don't know why this window is so wide like this, but on Mac, let me know if you're having these same problems. It shouldn't be this big. Anyway, I'm not going to do this right now. But this would be great to send to business colleagues and for them to actually now send targeted campaigns to these individual items depending on what our strategy is and how they are segmented. But let's dive a little bit further first to analyze how much do these different customer segments, how much are they contributing? What is their customer revenue? And also not only what is individual on average customer spending, but also what is their total revenue? So what I'll do is I'll now convert this into a CTE as well. CTEs on CTEs and on CTEs. I'll give this the name of segment values and then once again, open and closing parentheses. With this, we're going to just go first and get the customer segments, and mainly that customer segment column, and we're just going to get this first from that new CTE of segment values. Okay, let's make sure that this is just working correctly. And we can see it's doing this all down here. So the first thing we're gonna do is get a sum of all the different revenues. So we'll run sum on total LTV, and we'll name this conveniently total LTV. Because we're doing a summation, we also need to do a group by on that customer segment. All right, we'll go ahead and run this. All right, not too bad. So this is telling us the total amounts. And our high value is at 135 million, whereas our low value customers have only contributed 4 million. If we plotted this on a pie chart to see how much they actually contribute apart, I only recommend pie charts if it's 3 or less values. we can see that low value is, oh my gosh, we got to do something here and target these low value customers better. So this is great analysis that we found out of this. Mid value is around 33%, which you'd expect it to be about a third. And then the high value is almost 2/3. So that's pretty high, really high for high value. So based on just this little data piece alone, this is evidence enough that we need to do some different marketing strategies, especially with our low value customers. Now, because we put those numbers in the front of this customer segment, if we wanted to, we could also do an order by, and we could do that on customer segment, and we could put it in descending order. Running this, we're now getting this high value up top, mid value, low value. So that's why we put those numbers in the front for those columns so we can sort it more easily. Anyway, let's calculate a couple other things. Mainly, I want to find out what are the number of customers in each one of these segments. So that way we can then go through and find out what is the basically average LTV or lifetime value for a customer in a certain segment. So getting the count first, we're going to be using the customer key for this. We'll assign this as customer count, running this. We got the counts, and as expected, 1 and 3 should be equal because there's 25% in this, 25% in that. And then this one right here should equal the basically double of these because it's the 50th, it's 50 percentile or 50% in between. So now that we have this total LTV and this customer count, we can divide these to get the average customer value. So I'm just going to take this and then divide it by this value right here. And this will be our average LTV. Bam. All right. Now I'm going to close out this right here. So this is pretty interesting. Our high value customers are submitting on average around $11,000, whereas our low value are only around $350. Pretty substantive. Probably why those low values only contribute around 2 or 3% of that total revenue. Now there's a host of different marketing strategies you could go about doing this. You can feel free to pause the screen and look into each one of these of what you could go for doing. This isn't necessarily a master class on marketing strategies. It's on data analytics. We're not going to spend too much time on this, but I did want you to understand what are some different capabilities we can do with this powerful data. Now there's no practice problems for this lesson, but I do expect you to go through and update your project README. Specifically, I added a little description of what we're doing for all the different segments. I added a link to our SQL script along with that visualization that I showed you earlier, breaking down those things because that was the key insight we got from this. I broke down the statistics, talking about the high value, mid value, and low value segments, how much they contribute of each, and what their contribution of revenue is, and the big disparity there. And then I wrapped it up with business insights. What could we potentially do to target high value, mid value, and low value customers? All right, it's your turn now to go through and update all that. We're jumping into the next chapter in query optimization, where we'll not only go with query optimization, but also answering our third and final project question. See you there. Welcome to this chapter on query optimization. For this, we have 3 lessons we're going to be going to. The first 2 are going to be focused on understanding how to use the explain keyword along with some query optimization basics. The second one's going to jump into more intermediate and advanced ones. And then finally, in the third lesson, we're going to wrap it all up with our final problem for our project. Now in this video and the next one, we're going to be going over query optimization techniques. And I have a list here of beginner, intermediate, and advanced techniques. You should be familiar already with the beginner ones, but we will do a refresh during this video. And then in the next one, in the next lesson, we'll be jumping into that intermediate and advanced. And this will all be done while using explain and analyze to break each one of these down. Now for the third lesson, it's conveniently on the third question or the last question in our project. Specifically, we're going to be doing retention analysis, analyzing who hasn't purchased recently. We're going to get a visualization similar to this, and wherever we break it down by the different cohorts years and see how many customers are active and how many are churned or didn't purchase something recently. This is a super common business concept to understand. And coincidentally, Kelly was just telling me that she actually was implementing it in her job today. So let's get into breaking this down. We're going to be using these keywords of explain and explain analyze. For each of these, they just go at the beginning of a SQL command, whether what you're using. But what's the difference between these two? Well, explain demonstrates the execution plan without actually executing it, whereas explain analyze basically means like it's going to analyze it, and it actually does execute it so we understand what the execution times are. So say we have this simple query of select star from sales. I could use explain at the beginning of this, running Command Enter, and it's going to tell me the query plan. I'll break this down in a second. Now we also could use something like explain analyze, right? And remember, this one is one row. When I run explain analyze, we have two more rows. Mainly, this one has the execution time. It has, well, not only the planning time, but also execution time. So you may be like, Luke, when the heck would I use explain? And when would I use explain analyze? Like, why would I want this if this doesn't even tell me the execution time? Well, let's say you're working with an extremely large database, like millions or even billions of rows. It could be extremely cumbersome to run this query and cost a lot of money, not only time, but also money. So there may be cases that we would only want to use explain. But since this database we're working with is so small, we're going to always be running explain analyze with all the queries we do. That way we can also see the execution time. So let's break this down on what this is actually providing. So this first row here says that it does a seq scan, which means it does a sequential scan, basically going row by row by row. And it specifies that it's doing this on the sales. Then from there, we have three variables inside of parentheses here. Cost is just an arbitrary unit, and that's just assigned by Postgres. If you want to be real about it, it's just made up. But quantity-wise, it remains consistent. The one thing to remember is that these numbers, just because say you have a cost of 500 and then another one you have a cost of 1,000, the query is not going to necessarily take double the time. It's just going to take longer. Anyway, with this cost, you can see it has the syntax of this starting value, then this ... and then the next value after this. This is the start cost, and then this is the final cost. So ultimately, this query costs, in this case, that is shown in demo, 18.5. Next are the rows, and so that's the estimated number of rows. And then finally, the width is basically still that row size, but what it is in bytes. Going back to our original query, we can see that we have a final cost of 4,500. There's almost 200,000 rows, and the width is 68 bytes. Ultimately, this query took 30 milliseconds to run, and the planning time, or what it was going to do whenever it was planning on how to execute this query, took less than a millisecond. Now, all the times with dealing with all of this are going to be in milliseconds. So you may be like, Luke, what does this even matter? Like, we're talking about 30, like half a second. Well, once again, this is going to come into play whenever you're dealing with databases that are millions and billions of rows. Those milliseconds aren't going to be that anymore, and I've had queries run as long as an hour. So query optimization is a must for you to understand. Now, expand this out, we can actually see there's some other things as well to cover here. Specifically, going along with that execution time, we have the actual time, the rows, and then loops. Rows remain the same in this case. Loops is a more complicated topic and really relies on if we're basically performing some sort of recurrent loops, especially whenever we do joins. We're not going to worry about that too much. But what I do want to focus on is this actual time right here. And this tells us that, hey, we started this query at 0.017 milliseconds and it ended at 14.8 milliseconds. And then the time after this of the execution was the time it took to display it and do all that. Now, it's important to understand that with explain, whenever I run this one, it does not have that extra parameter over there as well. I didn't have it pulled out at the moment. But we still have that same thing of cost, rows, and width. Okay, so let's build on this further by calculating the net revenue per customer and seeing how this query plan changes. For this, we'll say we need that customer key, and then like usual, we're going to be doing a sum. And this will be summing up the quantity times net price times the exchange rate, and we'll give it the alias of net revenue. Okay, let's go ahead and run this bad boy. And I got ahead of myself. We got to do a group by anytime we do an aggregation. So I'll be specifying that customer key and then running this. Okay, now with this, what's going on here is there's actually two steps here. Each of the steps are denoted by this, basically this arrow right here. So this right here is a step, And then this up here, these 3 rows are now a step. The first step, it's sort of counterintuitive, but that first step is that sequential scan on sales. It's the most indented one in the fact that we're doing the scan on the sales table, getting all the rows we needed of 199,000. And we can see that that took 9 milliseconds to do. Then the next step goes into here, performing the hash aggregate. Basically, it does a hashing system in order to perform the aggregation. We're not going to go into hashing right now. The important thing is to understand that we are doing a sum function, which is an aggregation. It tells us it takes from 54 to 56 milliseconds, so about 2 milliseconds to do this. And this is done on only 49,000 rows. And that's because that group by or that customer key condenses it down the amount of rows. Under this, it has other information like group key, and then also how much memory was used. Ultimately, this query ended up taking slightly longer than we did previously. Now we're up to 57 milliseconds total. I'm going to add just one more thing to this, and let's add a filter to it. And we'll say we want orders only from 2024. So we'll say that it's greater than or equal to 2024, January 1st. Okay, let's go ahead and run this. And we got an error for this. Why did we get an error right here? Well, it's because I have it out of order. And that's because even in the execution aspect, we're going to filter our sales table by that in 2024 and then perform our group by and aggregation. And we can actually prove this by our execution plan in the fact that in our first step right here, our sequential scan, it actually goes through and filters by those dates that are in 2024. Then after this, after we filter it for 2024, we can see that we have down to 10,000 rows. Then it sends it into our aggregate to do the group by and our sum. And this takes 27 to 28. So this is even less than a millisecond. And ultimately, because now we do this where clause, we have a much shorter execution time. So not only are we learning about how to read query optimization, we're understanding why do we have the order of these keywords such as where and group by. Anyway, it's important to note that we've been using explain and explain analyze, but over here on DBeaver, they have an explain execution plan. Now, if I try to run this with this explain analyze up here and click this and click OK, it's going to give me an error because we already have explain in there. So it's important that you select what you want to use and then use the explain execution plan or the shortcut of Command-Shift-E. Now this is going to pop up and asking what you want to do. If you don't want to do the explain analyze, you want to leave that unclicked. I usually just maintain all of these clicked, including the analyze, and then from here, click OK. This I find is slightly less descriptive, but it is more ordered in the information that it provides. It's still in that same order of sequential scan as the first step, and then the aggregate is next, starting at the bottom and going up. But as far as the times and the costs, they're actually more in a readable format than that execution plan. Anyway, this is available if you want to use that way. We're going to continue to use explain and analyze throughout the remaining of this video and the next video because I find that most useful. Last thing to note is if you encounter any keywords you don't know, the best thing to do is just go ahead and copy this all and go into your favorite chatbot, just paste it in and have it go through and actually explain what's going on here step by step by step. So in the remainder of this video, we're going to be going over some beginner optimization techniques that we've touched on briefly throughout this course, but actually using explain, analyze to prove why you should be doing these. In the next lesson, we're going to go into more intermediate and also briefly cover some advanced techniques in order to further level up your optimization skills. For this one on basics, we're going to be covering 3 ones, and we're going to be going over examples on the first 2 on why we use select star, why we use limit. And then for the third one, we're just going to just briefly discuss of using where instead of having. We'll start with the easiest one to actually prove it's efficient, and that's using limit. If I just run select star from sales on the entire sales table, running Command Enter, it's taking around 18 seconds. And what you will notice for this, I'm going to run this a few times, the time actually jumps around. So on average, it looks like it's around, around 24 or so. Anyway, I have this in a not optimized SQL query. I want to come over here to the optimized query so we can compare them before and after. And we'll put a limit statement. We'll just say we want 10. And this bad boy, we get it in 0.03 milliseconds. Run this a few times. Yeah, it's maintaining pretty consistent around 0.03 compared to our previous of almost 21. So this is your actual proof that those limit statements are very helpful in minimizing the amount of data and saving you time. Next is on select star. You've heard me time and time again saying, hey, I don't recommend using select star to select all the columns of the table. So let's try to optimize this. And you know what? I'm just going to list one column and that's it, customer key. Whenever I run this, we can see, actually I need to run it a few times. We can see that it's over 30 seconds, whereas the not optimized one, whenever I'm running this one, it's less than 30 seconds. What the heck's going on here? Well, in some cases like this one, Postgres makes it super efficient for them to retrieve data using this select star nomenclature. And so, yeah, it is more efficient in some cases to use select star. But I'm still sticking with it in the fact that I do recommend, especially when you get into bigger databases, millions and billions a row, I would still stick with only listing one or however many columns you need for your analysis and not using select star. Now, the last one to look at is using where instead of having. And unfortunately, you may not always have control over just easily switching from where instead of having. So let's say we have this query here where we're actually getting the customer keys along with all their net revenue for it. Now, if we wanted to filter this data based on the net revenue and maybe get some that are higher than or less than a certain value, we would use a having clause. In this case, we can say, hey, we want that having greater than 100 or greater than 1,000. And if we remember from our order of operations that we first do that sequential scan, so we get all 199,000 rows. Then when we're doing the aggregate, we then are doing the filter in this step with that 199,000 rows. Now, moving back to that original query to demonstrate this now with a where clause, unfortunately, the having benefit is using it in aggregation. But we may have a case where, okay, we can alter this instead to have it to where we want to get customer keys that are, we'll say, less than 100. So not using that aggregation, but more based on a customer key. Anyway, with this one, the main point is that the filtering is done in that sequential scan out in the beginning. And as we can see from this, because it limits with how many rows are done, our execution time is a lot shorter. Now you may be like, Luke, you're using where with a customer key of less than 100, and you're using having using the aggregation that we did of greater than 1,000. Yes, I know these aren't necessarily comparable, but there may be a situation where, yeah, you know you want these net revenues a certain value, and thus you want maybe the order keys of a certain thing, and you could then filter instead by the certain order key values, or specifically not order keys, sorry, customer keys. Mainly what I'm getting at is if you have a choice that you could potentially modify it to do where instead, you need to take advantage of it. All right, you now have some practice problems to go through and get more familiar with using explain, analyze, the explain feature inside of DBeaver, along with testing out some of those basic techniques that we just went over. The next lesson, we're gonna be going over some intermediate and also advanced techniques along with a real world practice problem. All right, with that, see you there. Welcome to this lesson on optimization techniques. We're going to be starting by jumping back up where we picked off last and jumping into intermediate techniques. We'll also briefly cover advanced techniques, but overall they're going to be outside the scope of this course, and you'll see why. Then at the end of this, we're going to be going into optimizing our query that we built in the last chapter on data cleaning. Basically applying all these techniques we've learned into how we can make a query run faster. So what are we going to be covering for these intermediate techniques? Well, we have 4 ones to cover, but the first one we've really been covering in the last lesson and in this lesson of using query execution plans, basically using that analyze. Basically using things like explain, analyze, or even DBeaver's built-in options. Now we're going to be going over 3 other scenarios besides this on minimizing group by, reducing joins when possible, and optimizing order bys. So let's say we have this query here where we're going through and getting things like the customer key, order date, order key, line number, and then also getting an aggregation of the net revenue, which I need to add an alias of net revenue. Okay, let's go ahead and run this just to see what's going on. Anyway, we can see from this that, well, it's 2 main steps of doing a sequential scan and then actually aggregating with our group by. But our execution time, even running this a few times, is pretty high up there. I mean, sometimes getting as much as 100 milliseconds. Once again, we're dealing with milliseconds, but if you have databases that have millions and billions of rows, this can easily turn from milliseconds to seconds. As soon as those queries get longer than something like 1 or 2 seconds, they get annoying AF. Anyway, with this query itself, I'm just going to select it and run it. We may not necessarily need to find out every individual line number. And so if we were to go ahead and remove something like line number in our case, I'm going to go ahead and move it over to this optimize area and then take it out here along with taking it out here and then running this. Oops, got a little bit of typo. Try again. Okay, we can see that now we have a much lower execution time here at 67 seconds, but consistently less than 100. That was just by removing 1 group by. So an important concept to understand, is it really necessary to do all those group bys? They can get costly over time. And in this case, we're almost saving half the time, if you will, just by removing 1 group by. Next concept to get into is minimizing the number and also types of joins, if you will, on when we're doing a query. In this case, let's say we're pulling in multiple tables into our sales table. We're also pulling our customer, product, and date table. I'll go ahead and just run just the query itself. And we can see we have, a lot of information in here. Now running this full query to actually run the explain analyze, we can see that this query takes over 100 seconds. Running this query a few times, we can see it runs around 80 milliseconds. Anyway, pretty intensive. Anyway, if we go back to that original query in this case, we can see that we're pulling in the year from the date table. What happens if we remove this inner join and just add it in a way to extract out the year out of the order date? So I'm gonna go ahead and just copy this all, paste this into the optimized. I went ahead and already moved the inner join down here, and then we're gonna just write an extract function using year from s.orderDate, and we'll give this the alias of year. Okay, and we can clearly see whenever we run this, this is providing us the exact same information of that year. Running the query completely now, I need to move it up some. Running this one, we can see, well, it looks like it's maintained around 70. So the other one, I already forgot what it was running around. It's running around 80 or so, 80 or 90. So this one is, almost we're getting a 10% gain or increase in performance just by removing an inner join and instead doing a function instead. Now it's also important to note that it's not just the number of joins, but also the type of joins. And we'll get into that with the practice problem coming up in a little bit. Last major concept to cover is optimizing your order bys. Sometimes order bys are not something you can just negate, but if you can, they will save you some times. Specifically here, well, let's just go ahead and print out this query, pressing Command Enter. I'm getting the customer key, order date, order key, and net revenue. And in our order by, we can see we order by our net revenue first, followed by customer key, then the order date, and then the order key. Rarely do I find ordering by all columns is really necessary. Anyway, there's a few different ways we can optimize our order by. The first one, the easiest, is just limiting the number of columns in order by. The second is avoid sorting on computed columns or function calls. The third, probably the most intuitive, is place the most selective columns first in the order by. Basically, if it's doing something that's going to filter out other rows, you'd want to use this one first. And then finally, use index columns for sorting to leverage existing database indexes. Unfortunately, we don't have control over indexing. Usually a database administrator does. But if you did, you'd want to use it in that case. Anyway, let's go with one of the recommendations of removing function calls. So we're going to go ahead. We have explain analyze up at the top. I'm going to run it. And I'm seeing it around 90 milliseconds or so. Now I'm going to take this exact query, put it over here, and we're going to remove that, well, the net revenue, the aggregation up here or on the sum. Let's go ahead and run this. And this one I'm seeing a lot less, usually around the 70 to 80 millisecond range. So we just cut off about 10 to 20% doing that alone. Now, maybe we find out even more that we can remove the order by. Let's say we want to just remove all the way to the customer key itself and then run it. In this case, I'm not finding that much of a difference, even seeing it get as high as 90. So I'm not finding that this one is as great as the aggregation. But overall, we can see that it does have an appreciable impact compared to our not optimized query. So let's get into optimizing our view that we've previously worked with, and that was with cohort analysis. We can go into it under databases, right? Underneath our data set, underneath schema public, and then our views ourselves, that cohort analysis. Now we can actually look at the query itself going under source, and we have it all here. I'm actually going to go ahead and just copy this bad boy and put it into this script here on not optimized. I don't want to actually create or replace any view, so I'm going to actually remove this and instead put up at the top of explain analyze. So I'm not liking how this is formatted, so I'm going to highlight it all, go to format and go to format SQL. And it's going to break everything out more of like how I like it. Now let's go ahead and run this explain analyze on here to see what we're working with for our current execution time. And I have a typo because I didn't get rid of this as in the front of here. Going to go ahead and run it again. Okay, boom. We have this all, and wow, there's a pretty hefty query plan. And we can see this is some of our highest execution times that we've seen so far, around 200 milliseconds to get this bad boy done. It looks like it has a total of 1, 2, 3, 4, 5, 6 different steps. And that looks about right with the CTs and all the different group bys we have in here. Now, recalling back to what we just previously covered of how we can improve a query, just looking at this, we can see that the CTE, well, it has a bunch of group bys, also has a join, so that may be able to be optimized. And then we look down here to this bottom one, this bottom or the main query itself, and there's not a lot of different techniques that I feel I can put into this, as this is just doing a simple select and then from. So primarily, we're going to be focusing on inside of this CT of customer revenue. And the first one we're going to focus on is the join. Now, previously, we discussed about minimizing joins, but actually, which is also just important, is understanding when you should be using what type of join. Now, a lot of our course and the previous course used either left joins or inner joins. With left joins, they're specifically used in the case of, for table A, you want to keep all values in it. And if there were maybe some null values that matched up with from the B table for the A table, you would want those null values to fill in for A, so that way we didn't remove any of the A. Well, if we knew what we were matching on had all contents from both the A table and the B table, thus there are no nulls, inner join is slightly more efficient to use because we no longer have to do this null check before actually joining. So what I'm going to do is I'm going to copy this query and put it over into the optimize section. And I'm going to change this here from left to inner. The first thing I want to show though is the actual query itself, the output, pressing Command Enter. What I can do down here is I want to see the total row count, so I can click this. Okay, that's around 83,099. If I go back to our one with a left join, I hope that whenever we run this query, I'm going to select it all. And then press Command Enter. We can see for this one, the row count is 83,099. So the same. So they're still doing the same thing where this one has a left join and this one has an inner join. So now the question is the explain analyze, whenever we run this on the not optimize and on the optimize, is it going to be quicker? Well, for the not optimized or with that left join, it's around 200 milliseconds. And that of our optimize is, well, around the same thing, around 200 milliseconds. So although it didn't work in this case to further optimize our query and just works out to basically break even, There are cases where using an inner join instead of left join, when appropriate, can save you potential time in your query execution. All right, so we talked about joins. The other last thing that we can do in order to optimize this query has to do with this group by. Look at this, we have a bunch of group bys. And when we actually look at it based on what we're aggregating by, we're having a lot of repeating values in country full, age, given name, and surname. What do I mean by this? Well, let's actually look at the query itself. For customer, say 180, yes, the order date's going to change. Yes, the total net revenue, number of orders. But as far as things like their country full, the age, their clean name, their first purchase date, or even the cohort year, that's not going to change. So why are we doing a group by on things that aren't going to necessarily change? We really care about just grouping it by the customer key and then also the order date. So what we can do for this is, like we said, we want to minimize those group bys, but this query is not going to work. If we go to run it right now, it's not going to work anymore. What we can do is we can do an aggregation function with this. We just need the max value from each of these, or you could do min, whatever not. It's very popular just to do max. And I'm doing this for age, the given name, and then the surname. With this, it's also important that you give it back its alias. So I'll be giving it for country full, age, given name, and also surname. So first, let's go ahead and just run this query and make sure that it's working properly. Scrolling over here, we can see that everything's remained the same for the country full, the age, and then also the given name or that final clean name that we got to. I think I called out first purchase year and cohort year when I first talked about this. They didn't have anything to do with the group by. They're done lower below. Anyway, let's go ahead now and run this query, see how long it takes. And with this one, we can actually see that we've now got the execution time down to 160 milliseconds, where previously it was around that 200 milliseconds. So now that we have this optimized query that's taking less time, we can go ahead and update our view. And we'll be using that create or replace view cohort analysis as. So we're not changing any columns with this. So technically this should work without doing a drop. I'll go ahead and run this. It's now telling me that it's changing data type. So in fact, we do need to delete it or drop the view first of cohort analysis. We're going to now just go ahead and execute the entire SQL script. So it ran both the queries. Come over here, press F5 to make sure that we have it refresh, open up cohort analysis. And I can see that we have those max values and we've minimized that group by along with changing our join. And it looks like it actually saved it to a simpler join now that we were using that inner join to just join alone, which that's the default. So makes sense. Now, the last thing to cover are these advanced optimization techniques. We're not going to be walking through any of these, but they are ones that you should be aware of. Specifically, they have these three major ones of using proper data types, so basically not referencing integers or numbers over something like a string, using indexing in order to speed up your queries, so basically relying on certain columns with indexes built in to sort them more quickly. And then for large tables, you can have partitioning built into them to improve their performance. Now, all three of these are controlled by database administrators. Specifically, they control the data types, they control whether columns have indexes, and they control how data is partitioned. So we're not going to go into this because it's going to be really specific on whether your database administrator has done this. Now, if you ever run into a situation where you're finding queries are running excessively long and you've plugged into ChatGPT and you can't find any results except for this around indexing or partitioning or data types, this is when you're going to have to go to your database administrator and ask them to make changes to your table so that you can get more efficient queries. Hopefully you have a good database administrator. I have in the past and been able to go directly to them and get what I needed out of it and save me a lot of time in the long run. All right, you have some practice problems to now go through and get more familiar with those intermediate techniques in optimizing your query, along with using explain and analyze again. All right, with that, I'll see you in the next one where we're getting into our third and final problem in this project. See you there. Welcome to this last lesson in the chapter. And for this, we're going to be tackling our third and final question, looking into performing retention analysis. Specifically, we're going to be looking at who hasn't purchased recently. We're going to use terms such as active and churned customers. We're going to look at it totally overall, and then from there actually break it down into the different cohort years to see how it's actually trending over the years as we have these different cohorts. So we're trying to identify which customers haven't purchased recently. And the technical business terms for this would be we're trying to identify active versus churned customers. For us, active will be those that have made purchases within the last 6 months, whereas churned are those that haven't made a purchase in over 6 months. Now, 6 months isn't necessarily something you're always going to use as the hard and fast to delineate between active and churned. It's really going to depend on your industry and maybe even other factors. As a general rule of thumb, I have these 4 different areas, and Contazo falls into an e-commerce, and typically we'd see them use a 6 to 12 month period since last purchase for this. Whereas something like a mobile app is going to be much more quicker with turnover, so they're going to have a 7 to 30 day since last session to identify active versus churned customers. And now you may be wondering why the heck this even matters. Well, we can send off this data that we end up calculating on finding out if a customer is active or churned. And we can do specific targeting, marketing campaigns in order to get them to re-engage. Also, when we look at this holistically towards the end to get these like percentages for cohorts and stuff, we can understand maybe the effectiveness of previous campaigns that we've used in maintaining activeness and preventing churn. Overall, this deals with tracking our customer retention and also engagement, which is necessary because we know we have customers that have bought from us before and they're likely to do it again. So we need to take use of that. So what are we going to be working towards? Well, we want to basically build this table here, which is going to have information like our customer key and our clean name, along with calculating things like when was their last purchase date, and ultimately was this in the last 6 months, and then classifying this as either churned or active. To make this easier, we're going to be using the view that we've been using of cohort analysis because this has all the information that we need from it in order to extract out this information. Now, like our last 2 problems, I want to be working in a script that we're going to be saving as our final script to upload into our project we put onto GitHub. Right now we have our 1 and also question 2. What I'm going to go ahead is go to VSCode, and then inside of here, I want to create a 3rd file. I'm going to name this retention analysis. Remember, there's a SQL file, so I need to do .sql and then click enter. We're not going to edit it inside of here. I just want to actually create it. And then now going back inside of DBeaver and clicking inside of here, I'm going to run F5 to refresh it. And we now have our SQL file right here that we're going to be working in. Now, what are we going to be querying? Well, let's go back to that cohort analysis and open it up. Things we definitely want are the customer key. We have this clean name that we saw. Additionally, we're going to be using that order date. And we can also use the first purchase date, which will be used for some filtering that I'll explain later. So let's start defining all this. We'll start with the select statement. We'll define that customer key, the clean name, the order date, and that first purchase date. And we want this all from cohort analysis. Okay, let's go ahead and run this. Looks like I don't have any active connections, so we'll update it real quick to select the right data source and run. All right, so now we want to get, we'll target specifically this customer 180 right here. We have these 2 purchases. We already have a column for the first purchase date, but really we want to know when was their last purchase made in order to understand if they bought it within that 6-month period. So we need a way to go through and basically identify in a numerical way what is the most recent purchase. And we can do this using row number and partitioning. So right after order date, I'll enter inside of here and we'll use row number. We want to do a partition, so we use the keyword over. Then we put inside the parentheses the partition by, and specifically we want to partition it by that customer key. And then we don't want it assigning just numbers willy-nilly. We want to actually specify it depending on the order date. So we'll do an order by, specifying order date, and we'll name this as row number, which you'll typically see this written as RN. Okay, let's go ahead and run this. And not bad. Now looking at customer 180 again, we can see that we have the most recent purchase is actually number 2. So it goes 1, 2. We actually want it opposite of this. So like their most recent purchase is numbered number 1. So I can change this order by to descending. Run this again, pressing Command Enter, and now we have it in that manner, and it does order it. We can also double check on some other ones here at 387. Everything's looking good. So not looking bad. We're almost to what we need out of this. Mainly, I don't need any more duplicate entries. I just want to get the most recent purchase out of here. And that can be done by basically filtering for row number equal to 1. So what I'm going to do is put this all into a CTE and then pull out what I actually need. So I'm going to tab that over and we'll give this the name of customer last purchase. Put it all within opening and closing parentheses. And then from here do a select statement. We want that customer key, clean name, order date, and we're getting this from the customer last purchase. Remember, we want to filter this right where that row number is equal to 1. Go ahead and run this. Have a little typo in here, put something I didn't need to. Go ahead and rerun it. All right, looking good. Now, order date, technically now, this order date is, it is an order date, but it's actually now the last purchase date. So I'm actually gonna rename this with an alias of last purchase date. Looking good. We now need to get into classifying each one of these customers as whether they're active or churned. Now I need to show you something real quick. So I'm actually going to do underneath this another query. We're just going to look real quick at the order date column, and that's from the sales table. I'm going to go ahead and just run just this query. Then I'm going to filter this in descending order. And so what we can see is actually the most recent date, this data ends on the 20th of April on 2024. Now I can actually just query this by doing a max of the order date, run Control Enter, and it's still that 420. So why am I telling you this? Well, as of filming this, it is March of 2025. So we're almost a year ahead. Anyway, if we went back from my time now, 6 months, none of the customers, there's not any data in the system within that 6-month period. And so we'd have like a 0% we would have a 0% active rate. So the point is we have to do this from our last data point of 6 months past this 420 or 6 months before 420. So what we're going to do is this. We want to now, actually, let's go back and run up this query. We want to now categorize these using a case statement, looking back, seeing if they're within 6 months of April 20th, 2024, and if that case classified as active, otherwise classified as churned. So in our main query down at the bottom, I'm going to go ahead and put a case in, and then we'll do a when. And then we want to use this column. We know it's called order date. When order date is less than 2024 of April 20th, and specifically minus 6 months. So within 6 months of that period. So we're going to do an interval specifying 6 months. In this case, we want to classify it then as churned. So better said, going back or doing this actual calculation right here, if there are any purchases before October 20th, 2023, we're going to classify them as churned. Else, we're going to mark them as active. And then we're going to end this case statement. Also, I want to give it an alias of customer status. Okay, let's go ahead and check this out. I'm going to remove this extra line right here and now run Command Enter. Okay, we got this error message right here, invalid input syntax for type interval. Specifically right now for this, we're trying to do a comparison for order date, basically 10/20 of 2023. This sees this as a string. We need to actually cast this as a date using this operator. Go ahead and run Command Enter. And now it is working. Now we have this extra column and we can go through and actually double check it. We can see here November 2023 is active. December 2023 active. And looks like it's matching up pretty well. Now there's one other thing or one minor detail that we need to actually filter correctly for to make sure we're getting the right calculation. I'm gonna go ahead and filter this data to show what I mean. All right, this is it. Anyway, these are the last purchase dates. And actually, this isn't actually showing what I want to show. We want to show first purchase date. I'm going to show it right next to this. So I'm going to call it first purchase date right here. Remember, we have it up in the CTE up above, so I can just call it right here. And whenever I run this, it's now here. Let me actually now filter it by this. Okay, this is what I'm trying to show. Their first purchase date was, or these customers, however it's shown, was firstly on April 20th, and there is active. So if we keep scrolling back, all of these for a number period are active. And so they haven't been a customer really for 6 months yet. So they've never even qualified to become churned. I would argue that this would cause a bias to increase our numbers, especially in 2024, for making it look like all of our customers are actually active. And that's what will happen. In 2024, if I scroll all the way through here and we get to the beginning of the year, all of these customers in 2024 will remain active. When I run a percentage on this, it's going to say 100% active in 2024, which is completely useless. We need to actually go back and remove everybody until 10/20 because that's when it keeps on being active. But then here, this is when we actually start getting churn customers because we actually get customers that have been part of the system for greater than 6 months. So all I'm going to do is we're going to modify this query here, add an end, and we want this for first purchase date, basically all of this to categorize that a period of October 20th, 2023. I'm going to paste it right here. Now let's go ahead and run this. And I'm once again going to filter by that first purchase date. And we don't have a first purchase date now until after October or before October 20th, when we actually start having churned and active customers. So we're going to have a lot better description or actually key statistics that actually match up with the data. Now we have this cleaned up. We actually don't need this first purchase date anymore. That's not something that marketing may necessarily need. We now have that final table that I was getting at that we needed to get with customer key, clean name, when was their last purchase date, and whether they are active or churned. One minor note on this query. I am not a fan of hard coding values into a query. Because say we got a data dump and we get more recent data files, this number may change in the system. Instead, we could use something like a subquery. So I'm going to put this all within parentheses. And then I'm going to just take this, Command exit, and I'm going to place it right here. And then also right here. Okay. And then now whenever we run this, we have exactly the same results that we had previously. And this is much cleaner. So that way, if those dates ever do change or we get new data into the system, it will automatically update. So we have the data or the table we need for marketing. But now I want to take it a step further and actually perform an analysis on this. And one, we're going to look at just holistically overall, what is the active and churned rate for everybody. And then we'll finally break it down by cohort year to see how the cohorts are trending over time. So let's just get a percentage for the active and then the churned. I'm going to make this now into another CTE. I love me some CTEs. And we'll call this one churned customers. I'll put that into open and closing parentheses. Then for this, we're just going to start simple first. I just want the customer status. And I want a count of these on active versus churned for each. So I'm just going to do a simple count. And we'll do this of the customer keys itself. And we'll name this as num customers. We're getting that from that churned customer CTE. And we did an aggregation. So we also need to do a group by on customer status. Okay, let's go ahead and run this. All right, so not bad. Looking like we have around 4,400 active and 4,200 churned. I prefer percentages, so we're going to move forward to calculating that. One thing real quick, we don't need to necessarily run distinct on this. If I ran Command Enter, still going to be the same values. And that's because in here, we ended up filtering down to only where row number equals 1. So there should be technically only one customer key. So I think that's just a little unnecessary. We're not going to include it. So now we need to get basically another column, if you will, of total customers. I want to basically add these together. Should be around like 46,800. But if you see here, we're doing group by. Well, we can actually use window functions to expand bigger because window functions are done after the aggregation. So what we can do is we can use this, once again, this count here to get the counts of these keys, but then we want to do a sum of this using a window function. And we're going to do this over, but we're not going to partition by anything because we want to do all of this. And we're going to name this as total customers. Okay, let's go ahead and run this. All right, and we have, I was a little off on the math. That's actually 46,913. Now we need to have both of these, right? If I just did sum and tried to run this, we'd get an error, along with if I just ran count, we'd also get an error. We have to do the count of them, and then we want to do a sum of this to do all of this in order for it to work. So now what we can do is we can divide these two values to get our percentage. So I'll take this first value here, paste it down right here. We're going to divide by the total customers, which is this, Command C, Command V, and we'll name this as status percentage. Okay, let's go ahead and run this. And not too bad. Numbers, there's a lot of numbers here, so I could just do a round function around all of this, and I only really care about 2 decimal places. We'll go ahead and do this. And now it's down to 9% and 91%, which, comparing this to the industry, I'm using something like Perplexity, which is a chatbot that searches the internet to get some values. Anyway, I asked it, what's a typical churn rate in the e-commerce company? And it says, hey, a churn rate of under 5% is considered good. However, the average churn rate for the e-commerce industry is around 22%. So this one's our company is a lot lower than industry standards. All right, let's just take this one more step further. And now we're going to be finding out what is this active versus churned rate for our cohort years and see how it progresses over the years. Now, all we need for this is, well, we need to add another column on cohort year. But the problem is we actually need to import it higher up. Specifically, it's inside of our cohort analysis. If I actually look inside of here, you can see cohort year is there. So after that first purchase date, I'm going to add in cohort year. And then in our second subquery, I'm also going to add it in here. Now, because we added these extra parameters up here, we needed to add it into our group by to make sure that it's working just fine. Specifically, I'm going to add in cohort year. And I actually want cohort year before this. Okay, let's go ahead and just run this. This isn't going to be the correct calculations just yet. And so we do have that cohort year inside of here. We have that active versus churned. As we can see, we have our number of customers, but our total customers are 46,000 the entire time. Basically, this is all of our total customers. And then this is driving our percentages down. So for 2015, we have 1% and 6%. Together, these two rows should equal 100%. The problem is we're dividing this 237 by 46,000. We don't want their total customers per se. We want to be the total customers of 2015. So conveniently, all we have to do is inside of our window functions, we just have to add in a partition by, and we want to do it by cohort year. So we add in cohort year. Go ahead and run Command Enter. And I need to learn how to spell partition. Okay, we got good syntax highlighting now. All right, and I'm seeing this. It looks like it adds up to the correct amounts. All right, looking good. I'm actually going to take this partition by and also throw it into our status percentage below, so we have the correct status percentage calculated. And now, whenever I add up these two values, it will equal 100% for all of these. And as we can see, it goes from around 8% up to, in more recent years, up to 10%. Graphing it visually, we can also see this trend that it's slowly going up over the time from that 8% up to even 10%. All right, so only one thing left to do now is update our README. We already have our third SQL file in there. And actually I need to make sure that it's saved. So I'm gonna Command S it. And now when I go inside of here, I can see that, okay, we have our entire SQL file. Next thing is our README. I'm gonna close out of this and make this more viewable. So what did I add to the README? First, I attached the README, which is linked, apparently not correctly. And it looks like I spelled analysis wrong, so always double check your spelling. Anyway, when updating it, now whenever I click on this, it actually directs right to it. So it's always good to go through and actually click any different hyperlinks or links that you attach with this. Next thing I went in to do is attach a visualization. This one I had generated by ChatGPT, just copied and pasted it in, and it puts that graph in that we previously had. From there, I moved into the key findings, talking about how our churn rate stabilized around 90% for the last 2 to 3 years, and then stating the fact of that retention rates are consistently low, 8 to 10%, way less than what the industry normal is. And then finally cap it off with that newer cohorts are showing similar churn trajectories, and basically we need to take action now to start improving these churn rates. So what can we do with this data? Well, we can work in the future to basically target those within the first year or two to improve that active rate from churned. We can also combine this with other analysis and re-engage not only our churned customers, but also our high value churn customers, so we can be really specific with our targeting. Taking this a step further, we could use this analysis in predicting future churn rates and how a customer may act. That goes more into data science and machine learning. We're not going to go into that, but it is something that we could take away from this analysis. Now that we have our third and final question done, we now need to get into finalizing our README, packaging it all up and putting it on GitHub, and then finally sharing on LinkedIn, which conveniently we'll be doing in the next chapter. With that, I'll see you there, and we don't have any more practice problems for the remainder of this course. So congratulations to everybody that's been doing those practice problems. With that, see you in the next one. Welcome to this final chapter where we're now going to go into sharing our project. And first of all, I want to congratulate you for making it this far and getting through this entire project. It's been quite an accomplishment thus far. Now, this chapter only has 2 short lessons. The first lesson, which is this one right here, is going to be about how we can create our GitHub repo. And then our next lesson will be in actually sharing this GitHub repo onto a platform like LinkedIn. So dialing into this lesson, we're going to be focusing on 2 core technologies that you may or may not be familiar with. The first is Git. Git is a version control system, similar to like track changes in Microsoft Word. Anyway, it tracks our changes and you can install it on your computer and use it to track changes within files. We'll go more into depth of this as we go through this video. But we're going to be using Git to create a repo or repository, and we're going to be pushing it into GitHub. GitHub is an online platform that allows you to share remote repositories. And remote being you can access it from anywhere. And what's great about this is it allows us to then share our project. So what are the steps we're going to be going through in this video? Well, first thing we need to do is actually clean up that README. After that, we're going to do a deeper dive. If you're unfamiliar with repos, Git, and GitHub, we'll do an explanation of all of this. Thirdly, we'll move into installing Git on your computer and getting this repo set up for those then to put onto GitHub. And then in the fourth and final one, will be sync between the two, and I'll show you how you can manage it. So if you've been keeping up with your README so far with all of the different analysis that we've done since the beginning, there's not a lot that we need to do to update this. Specifically, we need to fill in an overview, business questions, and then finally, any strategic recommendations we have from this. For the overview, I just have this one sentence of, hey, it's analysis of customer behavior, retention, and lifetime value for an e-commerce company to improve customer retention and maximize revenue. For 3 questions, we bucket them into these 3 that we've gone into in inordinate detail in each one of these. Not going to rehash it. Feel free to pause this video now, copy whatever you want off of it. After this, you should have that analysis approach that we've gone through after each one of the questions and actually updated it to include everything we need. And then finally, our strategic recommendations. I went through and bucketed these based on our 3 different questions, and I've outlined a lot of the key tactics that we can take away from it within those questions. So I'm not going to rehash it here again, but I highly encourage you to brainstorm and think through what are some strategic recommendations that you would take, and then from there, put it into this section. Final and last sections on technical details, I just have information on what technologies were used so people are aware that yes, I used Postgres for this and I used ChatGPT for the visualizations. So this is looking good. I'm gonna go ahead and press Command S or Control S to save it. And now we can get into our next steps of initializing a repo or publishing to GitHub. But I want to just cover some background knowledge first. So the first concept to understand is what is a repository, or as I'll call it going forward, a repo. This is a personal library for your project. It basically allows you to keep, manage, and record every change to all of your different files within it. Like I hinted to before, it's like track changes in Excel, except we're using a version control system like Git in order to manage these changes, and thus we can go and revisit previous editions of it if we need to. Now, in order to create this repo, we need to use a technology like Git. Git is a free and open source distributed version control system. And it's designed everything from small to large projects. I use it all the time for my version control. We'll be installing it here in a second. So what exactly is going on and how is this becoming a Git repository? Well, here is the files that Kelly and I are working together to build this course, and it has all our different lesson plans in it. We actually used Git for the version control for building this course. Anyway, on the surface, we can see that it just has some folders and some files in there, nothing special. But whenever I go to unhide the hidden files on a Mac, I can do that by pressing Command-Shift-. It shows that there is other files in here, specifically this Git folder or .git folder. Dot being at the front means that the file is hidden. That's why you can't see it. That's why I had to hide it. Anyway, this tracks all the different changes inside of here of what's going on inside of my project. We don't even need to attach that or touch it in order to make any adjustments. It does it automatically as we go through and make changes and update the Git. But I just wanted to show it so you understand what is going on there. I'm actually gonna go back and hide it. So now that we understand that Git is the version control system and is what is used to create a repository, we understand that there are actually two types of main repositories. One is a local repository and the second is a remote repository. Local is as suggested, it's local. It's stored on your computer. What I just showed you right here is in fact my local repository. Because it's local, you don't need any internet connection. It's super fast and you can do this, and it's very common to do this for your initial development. Now, remote repositories are stored on a server. They obviously, because they're on a server and not local, you need internet. But because they're now in a remote location, they allow you to collaborate with others. So once again, I have that local repository here, but also that same repo is on GitHub, and this is a remote repository, and GitHub allows me to work with Kelly as a contributor for us to work back and forth on different files. So frankly, it's more than just a version control system. It's also great at collaborating with others. Anyway, this is now bringing us into GitHub, which is one of the most popular tools for using Git. Specifically, it allows you to store those Git repos here and then share them with the world. So by the end of this video, we'll be probably publishing your project to GitHub so you can make it publicly accessible. So if it's not clear, Git is the version control system. It maintains that local repo, and it also has some different command line tools. We can actually type into it. We're not going to go into that in the video. That's out of scope, and it's open source and free. So that's why we're using it. GitHub hosts these repositories. It's located via web browser interface, and we can access it remotely so that way we can also collaborate with others. Let's now get into actually setting up this repo and sharing it with the world. We're going to go through 4 different steps. First, we need to install Git if you don't have it. Second, we need to create the repo within our project folder. Third, we need to set up a GitHub profile if you don't have one already. And then finally, the 4th step, we're going to actually share it to GitHub. So let's see if we have Git before installing it. I'm going to open a terminal. That's going to be what you're using on a Mac, and on Windows, you should have the terminal available, or you can open up a command prompt. Inside of here, all I'm going to type is git and then -- version and click enter. In my case, I do have it installed, so it's going to say what the version is. I don't need to install it on the machine. Now, if it's not installed, you're likely to get an error message, and next we can now go through actually installing it. So navigate to git.scm.com And from there, you're going to download for your appropriate operating system. For Windows machines, you're just going to be going through the setup for this. Most modern computers are 64-bit, so you should be fine with installing this. If you have a newer computer, anyway, it's going to walk you through a GUI. Just leave all the default values the same and click OK all the way through. For Mac, they have a couple of different options for you to install, and all of them are through that command line or that terminal. My recommended option is through Homebrew. And if you don't have Homebrew, not a big deal. You go to this link up here, and all you have to do to install Homebrew is just copy this entire code here and then paste it in and actually run it. I'm not going to run it because I have Homebrew installed. Then after it's installed, all you need to do is copy this command of brew install git and execute that in the terminal, and you'll have git installed. Now, once you have it installed, you need to verify is it in fact installed. All we have to do is run git attack version, and it should output the version there. Now, some of y'all may get an error when running this. It's going to say something like this: please tell me who you are. And it gives you the instructions. Run this git config message in order to provide your email and your name. All you got to do is copy it and then paste it into your terminal. You need to actually go through though now and actually update things like your name to what actually your name is, along with that email address above. And then all you got to do is press enter. You're done. Now we need to move on to the next steps of creating our repo, creating our profile, and sharing to GitHub. Conveniently, these steps, specifically steps 2 and 4, can actually be done together. If I navigate to VS Code, specifically you go to this source control tab right here, they have 2 options inside of your project itself. You can either initialize the repository or publish to GitHub, but publish to GitHub actually initializes the repository and then publishes to GitHub. The important thing though is you need a GitHub profile before you click this. So if you navigate over to github.com, on the homepage right there, it has a sign up for you to enter your email in and then go through the sign up process to create a GitHub account. Once you have that account all set up, then we can proceed forward. So now I can go back into VS Code. And in here, remember, I'm going to do publish to GitHub because it's also going to initialize our repository at the same time. I'm going to click publish to GitHub. It's going to prompt me that, hey, the extension GitHub wants to sign in using GitHub. I want to allow this. I select my account that I want it to be associated with, and then I'm navigated back to VS Code. It asks me this first: do I want to create a private or public repository? I wanted to do a public repository. The next thing, this is very important, you get this right in the first try, is select which files should be included in the repo. I don't care about this DS store, any of these hidden files per se, which hidden files are anything with a dot in the front of it. I do want my SQL files in there. I don't need that bookmarks folder, that diagrams folder, that scripts folder. I do need my images because they have the images for my analysis. You could, if you want, include the scripts. I don't really care about that. That's just like throwaway scripts. I'm not maintaining that in version control. Okay, I have, in my case, 5 files selected. I'm gonna go ahead and select OK. And it's me going through publishing, and it says that, hey, this was successfully published to my GitHub. Now what I'm gonna do is navigate back to GitHub and go to my repository. I can just get to my repository or get it to my profile by clicking the name in the top upper right corner. One thing to note, if you haven't done this already, I recommend filling out any of the different social information along with your name and adding a picture to make it look like you have a legit profile. Anyway, if I want to look at the repos myself, I can go up here to Repositories tab, and it has this project, which I titled 𝗏𝗏𝗏𝗏 project. I can go ahead and click on it. And it includes that images folder, which I can click into it, has all 3 of my images. Next is my git ignore, which basically ignores all those different files that we said, hey, don't import into Git. So that's why it's there, and you didn't see it before. Then our 3 SQL files, and finally our README, which we talked about before. The README is actually going to appear down below in this section. And this has all of our analysis on this homepage. This is really great that it is all there. This is actually the URL that I would want to share to other people to showcase my work. Now there's one last core concept that I want to go over before we conclude this on GitHub, and that's on how to actually sync your profile with GitHub or sync your project with GitHub as you go along. Let's say that we do have a change inside of our README file itself. Specifically, I'm going to go under Analysis Tools, and not only do I use Postgres, but I also use things like DBeaver and pgadmin. Okay, so I have these new changes in here. I'm gonna go ahead and do Command S and save it. I can now see, based on these changes, that we have an M next to this. This means that this file is now modified. And underneath the version control, I can see I have this notification here for 1, and it's telling me that the README is in fact modified. Now, just to show, I'm gonna refresh this page real quick. Just to show, if I scroll on down, these tools are not present here, but we wanna get them updated on the technical details up here. So what we need to do is as you can see, this is underneath changes. We need to stage these changes in our local repository. We need to give a message of what we did here. And I'll say, you can just leave it super short. I'm gonna say we updated tools, and I'm gonna click commit. And it's gonna say, hey, there are no staged changes to commit. Would you like to stage all of your changes and commit them directly? Basically, previously we'd have to go through staging all the changes and then committing them. We're gonna basically combine this step together. And so I'm gonna click yes. Now, these are still not up on GitHub. This is only committed locally to our repo. So what we're gonna do is now push it to our GitHub repo by clicking sync changes. And it's gonna say, hey, this action will pull and push commits from origin main, which is the version that we wanna get updated to in our repo. We're gonna click OK. And also, I don't wanna show this again, so I'm gonna click OK, don't show again. So now we can see we went here from first commit to now our second commit of updated tools. And if I navigate over to the README, refresh this page, we can now see that it is now added to it. So that was an example of pushing our changes. We can also pull changes. Basically, if there are changes in our remote repo, like when me and Kelly work together, she pushes those changes up. I want to pull those changes. But we're gonna just implement a change in here and then pull it from there. So what I'm gonna do is, inside of GitHub here, I can actually edit this file. Oh, and let me actually show you what I'm gonna edit. So these images, I have them around 50%. I'm gonna update this one. This one's just too big. I'm gonna update it to 50%. I'm gonna click edit, and then I'm gonna go to the code. Now this is HTML code that I'm using for this. I'm using an image tag. You don't need to necessarily do that. All you need to understand is that I wanna update the percentage. And this is actually the image for question number 3. I want question number 2, which isn't in an image tag. So what I can do is copy this code from down here, put it down, and this says image from our source. Specifically, I want this image right here from this source. So I'll put this in. We want the alt tag or the name of it to be cohort analysis. And then for the width, 50%, height auto, I'm gonna go ahead and do this. By the way, you don't need to necessarily use this HTML formatting for image. This is just sort of fancy dancy I'm using to get this 50%. Anyway, now that we've done these changes in the README, I'm gonna go ahead and go, hey, I wanna commit changes. For the commit message, I'm actually gonna change it to more descriptive to update second image size. If you wanna do an extended description, you can. And I wanna commit directly to the main branch. I'm gonna go ahead and commit changes. Now, scrolling on down in that README, I can see that we have that image formatted correctly. So our remote repository is updated. But if I actually view our README from our local repository, we can see the number 3 image is pretty small, but the second image is pretty big, and it's still using it's using our just markdown format for having our images. So going over to version control, we want to pull these changes down from GitHub. So I'm gonna select more actions and specifically pull. And we can see down below underneath it, we not only have first commit update tools, but now we have update second image size. And closing this out and looking at this, we can see from this that all the image sizes are now formatted correctly, and I have that updated code here. So remember, there's 2 main concepts that went over here. One is pushing the changes, and this is sending our local repository changes up into our remote repository in GitHub. And then secondly, we can pull changes. If there are any changes on the remote repository, I can then pull them down into my local repository, and then my local repository can be up to date. Now that was just a brief intro into Git and GitHub. If you're new to this and you want additional resources on it, I have an entire YouTube video on it. I'll link up above. You'll be able to go through and see even more detail to understand the ins and outs of Git. All right. In the next lesson, we're going to, now that we have this public repository on GitHub, we're going to go forward with sharing it on LinkedIn. So with that, see you in the next one. All right, welcome to this very last lesson. Once again, congratulations for finishing that project. It's now time to get into sharing that GitHub repo onto LinkedIn. And we're also going to be going through how those that purchase the course perks can also upload their course certificate, which you're going to get after completing your end of course survey. So let's navigate on over to LinkedIn. You should have a profile. If you don't, I highly recommend that you create one. This is where employers are at, and this is where they're checking your work. Anyway, I'm here on my profile. In here, they have sections on and about, featured, activity. But what I care about is this section here on licenses and certifications. This is where we're going to be uploading your course certificate. Remember, you complete the end of course survey, I'll be emailing it to you. You'll not only get a link, but you can also download the physical certificate as well. Now, if you're not seeing licenses and certifications, you can actually come all the way up to the top, click Add Profile section, and underneath Recommended, you can click Add Licenses and Certifications. Anyway, let's add that certificate to it by clicking this plus icon. From there, you'll go through and fill this all in. Here I filled in with Intermediate SQL for Data Analytics, put me as the issuing organization. I have the issue date of March 2025. This certificate never expires, so you don't put an expiration date in. There's a credential ID located on the certificate, so put that in along with the URL. Underneath skills, you can list up to 5 skills. I'd recommend these of PostgreSQL, Git, GitHub, and DBeaver. Finally, I also like including the image of the certificate itself. So I select Add Media and then Add Media, and then attach the file itself in there. Give it an appropriate title. From there, click Apply. All right, once you have everything in there, all you gotta do is click Save, and it's there. The next thing you'll do is actually update this project because we have our certificate, but we also, part of this course, a project. So underneath this project section, I'm gonna click the Add icon. From there, I give it a name of Intermediate SQL, Sales Analysis, short description that I stole from our README. Fill in the 5 core skills that we're saying from that certificate. Next is the media. And I like to include a link, specifically a link to the GitHub repo. So what I'm going to do is just grab this URL right here and copy it and then paste it right into here and click Add. I'm liking everything that it has for this. I'm going to go ahead and click Apply. Now that we have our media in, we can do our start date. I started this bad boy making this back in October of 2024. And I just finished it this month in March of 2025. If you worked on it with somebody like 𝗖cie𝗂𝗿𝗀𝗄𝗏, so I could add her as a contributor, and I can associate with other projects. I don't have that. Okay, now I'd go through and click Save, and my project's going to be updated to my LinkedIn. Last thing I'm going to recommend to do is sharing a social media post on LinkedIn, or making a post, if you will, of this project completion to let everybody know that you've done this. In it, I'd call out that you completed the course and also did the project. Don't forget to tag me and Kelly in this, as it's super awesome. I love going through this and being able to see all the different work, and I can comment on it as well. Once again, congratulations on all the work that you've put into completing this course and also this project. What are the next steps? Well, I have coming up shortly in the next few months, we'll be releasing an advanced SQL for Data Analytics course, which I'll link somewhere on here, that way you can go and check it out if you're interested in it. With that, don't forget to follow me on LinkedIn and smash that like button. See you in the next one.